What is up, game dev gangsters? So I'm doing a new series on Unity where I'm going to teach you everything from the, basic things, from downloading Unity all the way to creating your game. And this is the first video in that series. So I'm going to put timestamps below because this is very basic in the beginning. For those of you who know all these things, you can skip it because first I'm going to download Unity, introduce Unity, show you the interface, then we're going to code in C#, and then we're going to dive in to create a really cool game. Now, this is going to be, as I said, the first part in the series that I'm going to create. I'm going to add more parts in my Game Development Academy, so you can check that out below because I'm going to add a lot of more cool games where the progression of those games is going to go, like this. So steadily, but, upwards. And everything that you learn in every session, in every video, is going to progressively expand your knowledge. Anyways, I'm going to stop talking, just watch the video, hit the like button, subscribe, and all the good stuff. See ya. Starting from the very basics, the first thing that we are going to do is download Unity Hub. And I'm not going directly to download Unity editors, different versions of it, because we are going to control all of that from the Unity Hub application. And simply type on Google, download Unity Hub, and then go on this link, download Unity Hub. Now, if you see something different in terms of UI of the website, here that you see on Unity, maybe they redesigned things, don't worry about that, just find the download Unity Hub button, click on it and download it. When you download it, this is what you will see, but before you actually see this, you will need to log in or create an account, and that's simple, same as creating an account on Facebook, on whatever, but that is what you need to do. Now, of course, for the projects over here, you will not see anything because if it's your first time opening Unity Hub, you don't have any projects. Now, from here, how you can install different versions of Unity? Well, simply you're going to go here under Installs tab, and from there you are going to see which versions you currently have and how or download the new ones. How you can do that, simply click here on Add, and then here you will be prompted to download the versions that they give you, such as 2020, 2020.1, and so on and so forth. But if you want to download later versions, basically, versions before this, you can simply click here on Visit Our Download Archive. So when you click on that, it will take you over here, or simply type Unity Download Archive on Google and you will find it. And from here, you have versions dating from version 3 up to version 2020. And this is very important for you to do, so pay attention now. When you want to download a specific version, let's say you want to download Unity version 2022.2, then from here, you're going to click on Unity Hub. So this green button, download it from Unity Hub. Don't download it here from Windows or Mac, basically the installer. Don't do that. The reason for that is because when you click here, download from Unity Hub, and I'm going to click on Open Application, Unity Hub, open the link, and it is going to open the link right here. You will see it in a few moments. There you go. So now we are prompted to download things such as Android build support, iOS build support, tvOS build support, so on and so forth. Now, of course, you are prompted to download these same way over here if you were to download the installer, but the difference is later on, if, for example, you're developing your game for Android, you will download Android SDK and NDK tools and the OpenJDK tools as well. So you don't have to download that separately and install them on your own and all of the, tedious stuff. So it's done for you. And plus, when you install Unity this way, then you will have it over here in your installs, and you can of course choose later on when you open a game or create a game with which version you want to download it or actually create it, and so on and so forth. Now over here, if I click on to download it and choose application, same as what we did before, you are going to select all the tools you need. So here you can select Android build support, iOS build support. If you need, Windows build support, click on that as well. And then from there, you're going to click on install and proceed to install the requirements or Unity editor and everything that comes with it. Now, one thing that I want to show you right now before I end this video and you install Unity, what I'm talking about when I say you can, have better control with Unity Hub is, for example, over here for my 2020 version, I didn't download the Windows build support. So if I want to do that, I'm going to click on three dots and I'm going to click here on add modules. And from here, I am simply going to click on Windows build support, click done, and it will download it, and there you go. Whereas if you have downloaded over here the Unity installer and installed it, you don't have that option in Unity Hub. So when you come later on, no matter if you added here your Unity version, if you click here, you will not see this add modules option. So that's why I said that you should download it with Unity Hub. Anyways, download and install Unity, and we'll continue from the next video. Before we proceed further on, I want to explain one thing that I want you to understand because I think it's very crucial. And I've been doing this for a few years now, and I see that a lot of beginners and even people who are beyond beginner level have an issue with this. As you can see here, we have multiple Unity versions from Unity version 3 up to 2020. Now, don't think that if you're watching a tutorial that is using Unity version 2018, then, well, you're lost if you don't use Unity 2020, if 2020 version is out. Why I say this? Because a lot of people are like, oh, and I especially see this on my YouTube channel, but this is not 2020 version or X version, whatever. The point is that the fundamental things that I'm going to teach you are never changing. So they will never change. I am using Unity since version 4, and I think it was version 4.55, or even I believe it was 5.1. So it's June from 2014, more than 6 years. So this year it's going to be my 7th year using Unity. And the things I learned using this version 4.5.1, I'm still using in the version 2020. So the fundamental things don't change. They add new features, but most of the time, your game can go out with those features, except only if you want to add them for whatever reason. And even currently, I'm developing 2 games that I'm going to publish, and they're probably published from the time you're watching this video, and I am using Unity version 2019 and not 2020, even though it is out. So don't worry about that. And I need to emphasize this because later on, when you go on YouTube and you want to see a quick tutorial how to do this and that, what if the person is using Unity version 5 and you're like going to panic or stuff? No, just follow along. If there are some differences, there are going to be small differences, but when you learn the concepts and how to use it, then you will not have an issue with that. So that being said, what I want to show you now is here you have installed Unity, you have your versions over here, multiple ones if you install multiple and only one if you install one from the previous video. If you want to create a new project, you're going to go here into the project tab and simply over here, you're going to click on new. If you have a project that you downloaded from online, or maybe you removed this project from Unity Hub, and you do that by clicking on 3 dots, remove from list. In order to locate it, you're going to click on add and then find it again. But if you have a new project or you want to create a new one, click here on new, and then there you go. From here, you are going to select if it's a 2D or a 3D project, and even though if you select 2D for a 3D project and vice versa, you can change that in Unity. So don't worry about that. Here is the location where you want to store your Unity save file. That is your preference. You can save it wherever you want to save it. And this right here is the name of your project or your game that you are going to create. So these are basic, simple things that you can do on your own. I don't have to guide you through how you can do this. Then you click on create, wait for Unity to, do its thing. One thing that I am going to show you is depending on how many versions you have over here, and if you want to create a new project with a specific version, you're going to click on the drop down list over here. So on new, click on the drop down list, and from here choose the version with which you want to create your new project. And that is basically all you need to know. So remember, when you learn the basics, when you learn the fundamentals, it's like driving a car. When you learn how to drive a car, no matter in which car you sit or drive, the driving is the same. So keep that in mind. So this is what you see when you create a project in Unity. It's an empty field space or workspace where you have these tabs. And I'm going to go through these tabs one by one, explain what they are, and we're going to move from there. First here, you will see the hierarchy tab, which is at the left side. Now this is by default, and when I say by default, I mean this over here, this layer. You will see default over here, and you can rearrange these however you want. So for example, I can take the hierarchy and I can put it over here, or I can take the project and I can put it over here. This is your preference. And later on, when you get used to working in Unity, you will then see which tabs you use more than the others, and you will dock them and you will rearrange them however you want to rearrange them. If you want to see my rearrangement, it's over here. I'm going to click here on default, or actually on this drop down list, and I'm going to click here on my layout. As I said, you can save this, so you can rearrange them however you want to rearrange them. And then from here you can go and click on this layout. So if you don't see, but why shouldn't you? You probably see it, and I'm going to draw it over here. So this right here, you can click on it, and then you can see or click here, save layout. Then you can give it a name and then click on save, and there you go. So the first thing that we have over here is the hierarchy tab. Inside of the hierarchy tab, you have all the game objects that form your game. So every part of your game inside of Unity is called a game object, and on that game object you put components that will make them do stuff in order to form your game. So while I'm in the hierarchy panel, I can right click, and from here I can click on create empty. Of course you can create a 2D object, 3D object, effects, but we will come to that later on. When I click on create empty, this is the game object I'm talking about. And this can be your player, this can be your enemy, this can be whatever you want it to be. Now, when you select the player, you will notice here at my right side, I have the inspector panel. If you are on the default layer, you will also see on your right side the inspector panel. But from now on, I'm going to switch to my layout, and I'm going to use all these tabs from my layout. But they're the same tabs, just on different position. So when I click the game object player, you will see the inspector panel or tab on my right side. Here you will see every component that is attached on that game object. Since I have created an empty game object, which is a default one, you will only see transform. But later on in the game, we will see sprites, which are representing 2D game objects, which are basically image renderers. So sprites are, or sprite renderer are image renderers. So if you have a character, that sprite render will render it, basically draw it on screen, same as from the image. You will also see rigid bodies, which simulate physics. You will see colliders, which helps us collide or help two game objects collide with each other. You will see audio components, which will allow us to play sound, and so on and so forth, but that will come later on. And basically you simply click on add component and filter for it. For example, if you want a rigid body, here it is. If you want a sprite component, here it is. You simply type sprite, and here it is, sprite renderer, and so on and so forth. So all of the information about the game object and its component, you will see in the inspector panel. And you will also see scripts that are attached on the game object, because scripts are also components. Moving forward, here you will see the project tab, and this is at my bottom left corner. So the project tab will show you all the folders and files you have in your game. Currently by default we have this scene folder, but we can right click, we can create a new folder over here, and I can name it, for example, scripts folder. I can name it prefabs. Prefabs are saved game objects. We will come to that, don't worry about that. We can save audio files, fonts, UI images, and all of the good stuff. Everything will be available here in the project tab. Now, one thing about the project tab is remember to keep it organized. You saw me create a folder for scripts. Same way you will see me create a folder for my images, for my sounds, for my fonts, for my prefabs, for everything. I love to group it so that I know where it is when the time comes. Moving forward, here at the top left corner, I have the scene tab. So the scene tab, which is this right here, is basically the game in Unity Editor. That means every game object I put inside, I will see it in the scene tab. For example, here is the player game object, and I can click here on the player game object, and in the inspector panel I can click on this cube over here and I can give him an icon, and there you go. So now he has an icon, and this is in the scene tab is where you are going to position your game objects, your UI elements, and so on and so forth. So for example, if your game or our game is going to be within this bounds or these bounds that you see over here, so this rectangle, which represent the camera, by the way, then if I want to position a game object here, I'm simply going to move it in the scene tab, and this is where he is going to be located. So the scene tab is for that, rearranging game objects within your game. Now the game tab over here is how your game is going to be displayed on an actual device, be that computer device, desktop device, laptop device, mobile device, and so on and so forth. So all devices that you can imagine. Inside of this game tab, you can do one important thing. Over here, you will see this free aspect. Here you can add a desired resolution for your game. So when I click here, full HD, and for some reason I have it full HD, it is going to change the scene over here, how we see it, as you can see, and as well over here, the shape of the camera. Now, what do I mean by that? Well, if I go back over here in full HD or full HD, I'm going to click on the plus sign to add my own resolution. And over here, I'm going to say full HD portrait, and I'm going to say 1080 by 1920, which is the portrait mode. You will see now that we are in the portrait, or we see the game in portrait. Same over here, we go back in the scene, we see the camera in portrait mode. There you go. So this is how you basically develop games for mobile devices in portrait or landscape mode. I can go back over here and select the full HD 1920 by 1080, so vice versa, and now I see it in portrait mode. So this is how that is done. But of course, this doesn't mean if you set here the resolution to full HD and design your game for mobile devices, and this is referring to mobile devices mostly, this doesn't mean that your game will look the same on every device. We'll talk about that later on, and I've talked about that on my YouTube channel. You can check out the videos for that. But this is just to show you for what is the game tab. Now, the resolutions over here that you see will depend on from file and then build settings from the platform your game is selected for. So currently it's for PC, Mac, and Linux standalone. If you want for Android, you're going to click on Android over here and click on Switch Platform. It is going to take a few moments depending on also how large your project is. So if you have, a lot of assets and game objects, you progressed a lot in your project, and for some reason you need to switch platform. This happens when you develop for Android and iOS as well. Then you will wait a moment or two for all of this to compile and, yada, yada, yada. So that's basically it. There is no way to speed it up except for you to have a good computer. So now if I go over here, I have more options for these resolutions. And of course, you can do the same thing I did. You can click on the drop-down list over here where it says, landscape in this 1920. You can click on the plus button. You can give it your own name over here, name of your resolution. Here is the width and the height, and there you go. Moving forward, we have the console tab, which I'm going to move over here. The console tab is basically used for debugging. So you will see any errors that your project has, they will be displayed here in the console tab. Also your own debugging, so when you add debug.log or print statements or so on and so forth, you will see all that being displayed right here inside of the console tab. And you will mostly use it, as I said, for debugging. Now, this console tab is pretty good, but there are also better ones on the asset store which give you more information, but I will talk about that later on. I also talk about that on my YouTube channel. This is for your own development, to speed up your development process, but as time goes, that will come, so don't worry about that. Currently, we don't see anything. Later on, I will show you when we create a simple script and we type debug.log, I will show you how that is displayed over here in the console, and we will explore it. The asset store over here, as you can see, it is moved. Now this is moved from, as you can see, you can visit the asset store website from 2020 version onwards and also import your purchase from the package manager. Basically, the asset store before Unity version 2020 was a tab where you import the assets that you get on the asset store, either paid or free assets. But now that is moved to window and then package manager. So here is the new asset store. So any new asset, we can close this tab, and any new asset that you purchased, they will be available here when you click on the packages, and here my assets, they will be available from this tab. So you can see these are all the assets that I've purchased and got for free on the Unity asset store. And a lot of these are really amazing assets that, you know, help you develop your games faster and so on and so forth. As you can see over here, I have 126 currently, and I will have more because they really help you develop your games faster. Next over here we have the animation tab, or actually the animator, but the animation over here is where we create animations. In our example project that will come a few videos from this one, we will see how we can create simple animations. Don't worry about that, but later on when we start creating real world games, we will see how we can, you know, create more complex animations, use them in our code and all of the good stuff. Now this is where we create the animations and display them, and also set the frame rate and the other stuff related to animations. And over here into the animator tab is where we connect those animations together. And later on, don't worry about that, we will see that. So we will have one animation here, another animation here. We will create connections. For example, we go from this animation to this, and from this animation to this, and so on and so forth. And we'll see how we can create parameters from this tab over here, the parameter tab, to help us navigate from this animation and from this animation and vice versa. So we will see all of that. Don't worry about that. So these are the basic, most used tabs when you develop your games. Of course, other tabs are located under window, and then you have over here. So you have under general, you have, you know, scene, game, inspector, project, console, services, when we later on want to implement ads in our game or in-app purchase, rendering for lights in our game, or, you know, lighting, and animations here. Here are the animation tabs, the animator and the animation that we saw. Audio is, you know, for audio mixer. Analysis for the profiler when we want to profile and analyze our game, debug it, and so on and so forth. But that will all come later on in your development. What is important now to, you know, learn, which we did, about these basic tabs that are used all the time. So this is, or, you know, just memorize these. You can go through the video again to know these basic tabs. And from there on, when you get used to, you know, using Unity, other tabs will come and we will then mention them on the go. Let's get into the juicy stuff. Over here, I have a game character, and if I double click it, this is what you see. And this is a nice little one-eyed, I don't know, fluffy thing, which is a character from my game called Gravity Control. And this right here is called a sprite sheet. Why? Well, because we have multiple characters, basically multiple images inside of one image. And this will form a blink animation inside of the game, which we will see in a moment. But on its own, this is the character, and you can either import him like this, or you can import him like a sprite sheet. Why do I import him as a sprite sheet? Well, because this is more efficient memory-wise and performance-wise, because you have all of the characters inside of one image, and then you import them in your game and you slice them up. That means choppa, choppa, choppa. So let's see how that works. First things first, over here in the assets, remember by the organization, I'm going to right click and create a new folder. And I'm going to call it sprites folder. Of course, further on in the assets, you can subcategorize. So over here, you are going to right click and you're going to create a folder for characters or UI elements or enemies or so on and so forth. You get the point. And inside of here is where I am going to import my character. How does that work? Simply, you know, drag it with your left mouse click. You see the plus sign or the plus button, and now you release the mouse, and there you go. This is your character. And voila, here is our character inside of the game. Now I can, as I said, I can simply drag him like this inside of the scene. Remember, the scene is where you form your game, where you arrange elements and characters and all of the good stuff. So I can put him over here, and that's it. I can go here in the game tab, and remember, game tab shows you how your game looks like. And if I were to hit the play button over here and the middle, or the, top middle, not corner, but top middle, this is what we have in our game. Of course, this is not something that you want to have in your game, except if you're creating some weird game. So I can, right click on the character game object in the hierarchy, and I can click here, delete, or I can command delete or delete button on Windows. Now, one thing I'm going to explain before we go, notice over here we have a sprite renderer component attached on that game object. In order for Unity to render this image, we need a sprite renderer component, and over here we provide the sprite that we want to render, which in this case is this character. So this is one component that I talked about, and this is how it works. So I'm going to delete it now, and I'm going to click it, because you're probably wondering, okay, teacher, you are crazy. I'm not going to use this in my game. And I know I am crazy, and I know you're not going to use it in your game like this. You want to use every different element of this sprite in your game. How can you do that? When you are in the sprites folder, you are going to select your character. From there, when you select it, over here in the inspector, you will see the properties of that sprite. And you will see something called sprite mode, which is currently set at single. What you can do is you can click on that drop down list and change it to multiple, and then hit this apply button over here at the bottom right corner for the inspector of your sprite. When you click apply, it applies that change, and then you can click on this button here called sprite editor. When you do that, now you see your sprite over here, and what you can do is you can slice it up. As I said, you can choppa. So we can, slice it into parts like this, and then we can use every individual part from this sprite. And in order to do that, I click the slice button over here. There you go. And click on it. And over here, we have the type of slice that we want to do. We can do an automatic, which will allow Unity to automatically slice all of these sprites, which Unity does a really good job at, by the way. And we can also click on the drop down list, and we can, do it by, we can do it grid by cell size, which basically means we are going to set our own pixels and offsetting and so on and so forth. Don't worry about that now. That will come later on. This is basically for images that have the same width and height. For example, 512 by 512, or I don't know, 1620 by 1620, or 1080 by 1080. I mean the resolution of the image in sizes. And then you can specify these grids that you will use to slice it. As I said later on about that. But when you set on automatic, Unity does a pretty good job, and I'm going to click on slice, and there you go. This is everything we need to do. You will notice little cubes around our characters. So over here, you can see it over here, and so on and so forth. These are indicating how these sprites are sliced. And if I click on each and one of those, you can rename it over here. So you see over here we have character 1_0, then character 1_1, so on and so forth. And you can rename these, especially if you have a sprite sheet of UI elements where you have multiple buttons. You definitely want to rename your buttons to know which is the play button, which is the level button, so that you can locate it more quickly when you are using it in your game. That's the wisdom behind the renaming. Over here, we don't have to do anything because, it's a character. It simply slices it in parts. We can probably say character 1, 2, 3, 4, 5, and yada, 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 but we don't have to do that. When we are done, you can also, by the way, if for some reason, and sometimes Unity does this because, as I said, it does a pretty good job at slicing all of these, but sometimes it will miss, and maybe you will see this over here. So it's not on your game object wholly. So it's not circling your game object. What you can do is simply, change these. You can move them, and you can, position them over here. You can zoom in to see where you're going to position them so that you position them correctly. There you go. And over here as well, we can do that, so on and so forth. So you can, you can correct the errors that Unity has done, but that rarely happens. It depends on your image most of the times, but as I said, that rarely happens. So simply slice, and there you go. And then click on the apply button, which is right here. Here is the apply button. So over here, click on it, and there you go. Which means now I can go back over here and I can use all of these characters on their own. So now you will see when I go in the game tab, we have a single character as opposed to having all of those characters at once in our game, same as we had, a moment ago. So this is how we can separate individual sprites from a sprite sheet and use them in our game. Of course, if this is a game we are creating, not an example that we are currently going through, we will add a rigid body, we will add all of those components. Don't worry about that. That will come and that will form a game object, or that will form your character in the game. One thing that I want to point out before we continue is that you can have all of these images separated. So this can be image on its own, this one can be an image on its own, and you can import them as 3, 6, 8. So we have 8 images over here. You can import them as 8 different images. But as I said, when you put them here in a sprite sheet, that is more efficient when it comes to memory in your game, when it comes to performance and all of the other stuff. So it's a lot better to do it like this. But I'm just going to, I had to say this just so that you don't think that this is the only way to import images inside of Unity. And then you would also create animations by dragging all those images, and we will see that in a moment. But first, before we do that, I want to show a couple of components that we have that I briefly mentioned, such as a rigid body. So in our game, we will want to simulate physics. And physics, I don't have to explain it. It gives, physics to our game objects. It applies gravity to it, forces can affect it, you can interact with it, and all of the good stuff. And in order to do that, as I already said, you simply go here, select the game object inside of the hierarchy panel, because if you remember, when we introduced the hierarchy panel, it represents all the game objects in your game. When you select the game object that is in the hierarchy, here in the inspector panel, you will see all of the component and properties that are attached to it. Currently, we only have the transform, which is the default one. We saw that, and now we have the sprite render, and we already explained that. So next, we are going to click here on add component, and here in this little search bar, you can filter for rigid body. But you can also do this. You can go over here and you can filter for these options that you have. So over here we have physics 2D. You can click on that, and here you see all of the things that we have. But usually you are going to type here in the search bar because it's a lot faster. So simply going to type rigid body. Now, one thing that I want to point out that is, you will see over here, and well, it went away since I took my annotation. Anyways, you will see here we have a rigid body and rigid body 2D. That rigid body 2D is self-explanatory, but rigid body is for 3D. I don't know why they didn't put rigid body 3D and rigid body 2D, but anyways, 2D is for 2D games, 3D is for 3D games. So if you're creating a 2D game, don't confuse and put a rigid body, which is for 3D, on your game object. So I'm going to select rigid body 2D, and that's all there is to it. Over here, you will see on the rigid body, we have a few options. So we have the body type, which is dynamic, kinematic, and static. I will talk about that in a moment. We also have over here for the mass, should we set the auto mass, we can set it on our own. So currently it's 1, or by default it's 1. We can set it at 1000, whichever number we want. Linear drag, angular drag, gravity scale. Basically, gravity scale is, how much gravity is applied on our player. If we set that to negative size or negative value, it will draw the player up. So it will move him up and not down, because we know gravity pulls you down. So over here, we also have constraints. If we want to freeze the position for X and Y and freeze the rotation for the Z, so that will not allow our character to rotate and move and so on and so forth. We will explore this. Don't worry about that. But I want to show you one thing. If I hit the play button now, we will notice that, there you go. You see that our game object fell, and it's over here. See, it's falling down. And why is that? Well, because we applied a rigid body on it. It pulls him down. It's gravity, as I already said. Now, in order for us to land on something, we need to have a collider. And for that, I'm going to right click over here and create an empty game object, which I'm going to call, I don't know, ground collider. And even though it's an empty game object, we can still attach a collider on it. So we can select it and we can go here in the inspector and we can filter for collider, and I'm going to select box collider 2D. So you can see the shape is a box. If I select it, it's a box. And over here inside of the inspector, you have options. So we have the offset. You see, this is offsetting the box, even though it's not moving the game object from its own position. You have the size. So if I resize it, you will notice now the box collider is bigger. One thing that I want to point out is that in the scene view, because we are laying out our game objects, we can see this box visually, but in the game we don't see it. You see, in the game we don't see it. If I hit the play button, we will notice now that again our character fell down. And now you're going to think that I'm crazy, and you're going to be like, teacher, but you said it's not going to fall down. Listen, I know I'm crazy, but that's another story. But as I said, we need a collider. And we need a collider for our own game object as well. So no matter if it has a rigid body, if it doesn't have a collider, it will not collide with a collider. So even though this ground is right below our character, this fluffy thing, we also need to select it and go over here, and we can filter for colliders, and we have something called a circle collider 2D, which is going to, you see, be a circle or circle it around. Now, which colliders you want to apply will depend on the shape of your game object. So if you have a cube or something that is similar to a cube, you're going to add a box collider. If you have a circular game object like this one over here, you're going to apply a circle collider. So over here, I'm also going to change the radius because we have a lot of options here that I encourage you to play inside of the inspector panel. And that way you will learn faster and more efficient and better. I'm just showing examples over here, but when you play with these, you will notice what is going to happen. So now if I hit the play button that we have attached the collider on our character, bam, you see now they are standing on each other. And here is our character, and if you look at here, he is standing on an invisible ground. If I select the ground collider over here, you will notice, and for some reason it is not showing up, here is the ground. Where is the ground collider? Here it is. For some reason it didn't show it right away, but anyways, you can see that he is standing right on the collider of this game object. And if I select the character as well, you will notice how their two colliders are overlapping with each other. Of course, in the game it will not look like this. You will probably have a ground, so it will similarly look something like this. So he will be standing on some type of ground, which is also a sprite component as well. Now I want to show you another thing, and that is when I select the character over here inside of the collider, you will notice one thing. We have something over here called is trigger, and it's a checkbox. What will happen if I check that checkbox? Well, let's find out. I'm going to hit the play button, and now again you will see that my character fell through the ground collider, even though it has a collider. So what's going on? Teacher, again you said, don't cry, don't panic. I'm going to uncheck the is trigger. Basically, later on in the code, we're going to see how we are going to detect these collisions between game objects, because this is currently a ground, but imagine it to be a collectible item, a coin or a health item or whatever. We need to know when these two touch each other inside of our game. And in order to do that, we are going to use code. Now, one of the ways to know that is by checking this is trigger checkbox, which is over here. And later on in the code, we are going to use something like onTriggerEnter. It's a function that's called onTriggerEnter that allows us to detect which game objects have collided with which game objects. And a trigger collider is not a solid collider, as you saw a moment ago. It can pass through other colliders, but still detect collision. Why am I showing you and telling you this? Well, because imagine you have a collectible item. You want it not to be a solid collider. You just want to, collect it, and there you go. You don't want to hit it and be bounced off it or something like that. So for that, we're going to use trigger colliders. But don't worry about that. We will see it with real world examples later on when it comes in the game. Next on the menu, we have the audio source, and I removed all the components that we used previously. And if you're wondering how you can remove a component, so for example, if I have a box collider over here, you are simply going to click here where are these three dots on the component itself. As you can see over here, these three dots. When you click on them, you will see this remove component, and voila, That's all there is to it. Next, I'm going to click on here, add component, and I'm going to filter for audio source. And this is a component that will allow us to play music in our game. Sound effects and all of the other stuff, of course. Now, as you can see over here, we have one thing which is audio clip, and it says none because we didn't attach any. The audio clip is your MP3 file, WAV file, whatever file that plays audio sounds, and you attach it over here, and then this audio source will play it. You have other options over here, of course, to mute. You have options to play on awake, which means as soon as we run the game, it will start playing. We have loop to loop it over and over again. You have over here the volume, the pitch, and so on and so forth. You can play with these, and these all are accessible via code. And most of the time, we will play these via code. Now, as an example, I have one sound effect over here, and I'm going to select the character. And by the way, I have attached this audio source on the character, but you can attach it on whatever you want. You can attach it on your grandma if you want that, okay? Just kidding. But anyways, you can attach it wherever you want to attach it. You will have probably a game object called BG Music, sound effects, or whatever, and you will attach the audio source components on them. And if I drag now this piano audio clip and I put it over here, if I run the game, but before that, let me just lower the volume a little bit so that we don't, go deaf. Here we go. So this is playing audio in our game, and this is also if the game is run on a device, mobile, desktop, no matter what, or which device, it will be played the same way. Of course, as I said, this can be controlled via code, where we write code, audio source.play, stop, and so on and so forth, and it will play and stop this audio sound as well. So I'm going to remove this component, and before we, go into the nuts and bits of coding and all of the good stuff, I want to show you another common component that is used all the time, which is UI elements. And if I right click over here, you will go under UI, and then over here you have the UI elements. You have the text, you have the text mesh pro, I cannot pronounce, I don't know how to speak. We have the button, we have the image. So let's start with the image. I'm going to click here. Now, one thing you will notice is you see this big thing now over here, this big rectangle, whatever it's called. That's the canvas. And the canvas has its own options. You can see over here, when I clicked on the image, it automatically created a canvas because every UI element needs to be a child of a canvas. And it also created an event system, which is responsible for detecting input on UI elements. Now, the canvas has a few options over here. For simplicity, because we will talk about that later on, for simplicity, I'm going to select the canvas and change this screen space overlay to screen space camera, and I'm going to attach the main camera over here just so that we can, make it a little bit, smaller, because it's easier to interact with a smaller canvas just because of the visuals. Anyways, this is our image, and you will notice it if I select the image, and I can move it left and right. If I can select it first, I can move it left and right, up and down, and you will notice it wherever I move it, it will be present here inside of the game. Of course, we can select the image, and over here we can attach a sprite. So let's go over here inside of our sprites, and over here I'm going to drag, I don't know, let's say character 1, the same one we have over here. And I can click this set native size, which will set the native size, width, and height, which you can see over here. Width is 150, height is 119. And you will notice it. This right here is our UI element on the left side, and on the right side is our game character. And of course, this is our own character. You can use it, for example, we can position him over here at the top left corner, and he will be used to represent health status or whatever. Same way, this can be a coin representing how many coins we picked up, and so on and so forth. You get the point. We can also create a button. I can right click over here, and we can go under UI, and we can create a button, and voila, there is our button. Our button can be also resized, so we can do something like this. We can resize it. We can select the text which is inside of the button. We can say, for example, play game or something like that, and I can, resize it over here. There you go. If I hit the play button, we can press the button. if I hit the play button, we can press, and you will notice it is blinking, which is indicating that we are pressing it, and I'm currently pressing it. And I'm pressing it with the mouse button, but same way, you can press it with your finger on mobile devices and it will work the same. Of course, later on, we will see how we can execute functions and code when we press a button. Now, another UI element, and that is going to be the last one that I'm going to introduce over here, is a text. Now, we have a text and we have Text Mesh Pro. We will talk about both, but currently I'm just going to show you the text one, which is a simple text. You can, move it left and right. We can resize it like this. There you go. We can, over here inside of the inspector, we can type whatever we want, whatever I want, and I can, change the color, the font over here. You see, we have some fonts. Actually, we don't, for some reason. Yeah, we have only the default Arial one, but we can import our own fonts, whichever font you find online, of course, that is permitted to be used commercially, or if you buy it. And over here, you can set it to be normal, bold, italic. If you use any text editor, you know what I'm talking about. You know what this is. And since you're on a computer, you probably used one. Over here, you can change the color of the text. So, for example, we have it to red one, and you see whatever I want. And this is how we are going to represent text in our game. For example, how many lives we have, how many coins we picked up, what is the current score, so on and so forth. So these are the three most common used UI elements. Of course, we have many others. So over here in the UI, you see we have raw image, button, toggle, slider, drop down, input field, and all of the good stuff. But I wanted to cover the most used components in these 2 or 3 videos, which are rigid bodies, sprite components or sprite renders, audio sources, and these UI elements. So these are the most used ones, basically the components you cannot create a game without. So yeah, this was a brief introduction to those components, and later on in our game, when we start creating things, make it interact with each other, we will, introduce them in more depth, use them via code, and all of the good stuff. Okay, so now we're going to get into the scary part and create a full game in 2 minutes. And I'm just kidding, of course, we're just going to go briefly and see what scripting is. But before that, when you download Unity, you also downloaded Visual Studio with it. So just make sure over here under Unity and Preferences, this is for Mac. For Windows, it's Edit and Preferences are somewhere over here. But you are going to go under Preferences, and let me just open this window nicely. So there you go. Here you have external tools. Here it is, Visual Studio for Mac. So there you go. And if you do not see it by any means over here, you can click on Browse and you can locate your app and just, select it. For example, I can go in Applications, and from here, I can find Visual Studio or whatever. So here it is, and click on it, and there you go. So do the same thing for Windows. Just make sure that external scripting or script editor is your Visual Studio. You can also use Visual Studio Code, but that is your own preference. So going back over here inside of my scripts folder, I already created a player movement script. And before you start judging me and telling me I'm crazy, which is something we already know, just right click over here and go on Create and click on C# script. And when you click on that, just give it a name. So script name. There you go. And then simply double click it and it will open in Visual Studio. I am going to delete this because I have the player movement and I have created it in the exact same way I just showed you. So I am going to double click it and it is going to open over here. So what do we have here? Now, don't worry if you don't understand all of these things. If you don't understand what it is, and over here I just wrote class, do not worry about that. All of this here is not important that you understand it right away, because after this we are going to go into C# and learn it step by step. But what I'm going to do is I am going to create a public float speed variable, and I'm going to say that is equal to 5 by default. Why? Well, because we are going to go inside of Unity. And I am going to select the character. Remember, I told you that here, when you select it in the inspector, you see all of the components attached on that game object. Well, our script is also a component, so I can attach it over here. And there we go, we have it. And we also see this speed variable, which has a value 5, which is the one that I created a moment ago, this over here. So what do I want to do inside of this script? I'm simply going to move the character, and we are going to move it by using a float, which I'm going to say h is equal to input. So input, if I can, type it correctly, get axis horizontal. There you go. And I'm also going to say float v is equal to input.get axis vertical. What is this? Again, do not worry. It's not important that you understand everything right away what it is. But basically with input, we get the input from the user. Get axis and passing horizontal, that means we will get input for the A key. So I'm going to go over here for the A key, and I'm going to put them in a comment. A key, D key, left arrow, and right arrow. That is the horizontal input, basically moving left and right. And the V key is exactly that, up and down. Vertical is up and down, W and S key. So now what we can do is we can get the position of our character. We can say vector3 or vector2 position, which is, so I can say POS is equal to transform that position. Transform that position is basically, and again, it's not important that you understand it right away, but I'm just telling you how things are connected. So if I go back over here, notice that we have our transform, which is our default. We know that it's our default component attached on our game object, on every game object that is. So it has a property position, rotation and scale, and we're using the position, which is going to tell us the position of our character inside of the game. So next, what I'm going to say pos.x, so the x-axis of the position, plus equals h multiplied with time dot delta time. And our position dot y plus equals v multiplied with time dot delta time. And then what I'm simply going to do is I'm going to say transform dot position is equal to POS. And here it's not POX, it's POS. So what is happening over here, I'm getting the input. Should we go left or right, up or down? And I'm multiplying that value with time dot delta time, which is basically a value or a time frame. You see over here the completion time in seconds since the last frame, basically time between every frame. And you will notice here the update function is called once per frame, which means if we have 60 frames in a second, it will be called 60 times. So we are using this to smooth things out, to smooth out the movement, and we will see, of course, this later on in our game. Do not worry about that. I'm just showing you basic things, how it works, so that you don't get scared, because people are usually scared because of the coding and all of the good stuff and how scary it is. So if I hit the play button now, we will be able to move our characters, you can see left and right, up and down. And also when I select him, I can change the speed variable, so I can change it to 10 from 5, and now he will move a little bit faster. Let's change it to 50, and now he will move even faster. So this is how we can change, and let's go over here, turn off the game and change it to 20 like this, because I think I was not feeling the change in the speed. Yeah, actually we need to just simply put a higher value. So there you go. So now he is going to move, let's say 1,000. So he will move faster. Anyways, this is how we can move a character. It's very simple, and you can see him, he is moving inside of the game. And this is how it would look like on a real mobile device or on a real desktop device, and so on and so forth. So let me just try it like this, private float instead of, so I can say private. When you set it to be private, we will talk about this, then it is not visible anymore in the inspector panel. So over here, oh, actually this is why it didn't work, because I am stupid. We need to do this over here, 5 and then F. I need to do it h multiplied with time dot delta time, but before that multiplied with speed, and then multiplied with time dot delta time. And same thing we need to do over here. So I forgot the speed variable, that's why it was not affecting the movement or the speed of our character. You see how all of this is connected. So this is how things work. So now I'm going to set the speed back to 5 and go over here. Now when we change it, it will move. You see now he is moving a lot faster. And if I set the value to 10, there you go. See, he is moving a little bit faster. I'm not even going to set it to 100 because then it will, move like crazy. But basically this is it. This is, you see, a few lines of code. 1, 2, 3, 4, 5, 6 lines of code, and we are already moving our game character with only 6 of these lines, as you can see over here. And they are not large lines like you see from the images and online and so on and so forth. But again, don't be overwhelmed. Don't think that you need to understand all of this right away. I'm just showing you how simple it is for us to perform a movement of our character the same way we would perform a jump or a crouch or a sprint or whatever. So this is how things work. Of course, now we're going to jump into C# and then we are going to learn how things work and all of the good stuff. And we will go back and forth when we explain things, what this here is, how it works, and so on and so forth. So that way everything will be clear before we jump into the real world projects that we are going to create in this course. Moving forward from the basic programming example we saw in the previous video, we are going to dive into programming. But before we do that, I just want to emphasize, I am going to use the same project we did so far, but it is not mandatory for you to do the same thing. I'm saying this because I did something similar in one of my other courses. People got confused, but anyways, you can create a completely new project from scratch, or you can use the one that I'm currently using to follow along. What's important for you to do is in the scripts folder, you're going to create a script called learning how to program. And I've cleaned the script. I've removed the 2 functions. You can do the same thing. And I will explain what are functions later on. But first, we are going to talk about variables. The variable or a variable is a foundation of programming. In order for us to program at all, in order to represent anything, we need variables. And these variables are numbers and characters and booleans. So, which types of variables do we have? We have a float variable. So that is one of the variables that we have. And a float is a decimal point number, which is, if I go back over here, I'm just going to use this as a reference, the project we did, we used a float to make a speed variable, or we used float to create speed for our game for the movement of the player. So floats are decimal point numbers. Now over here I set it to be equal to 5, but that's still a decimal point number. So over here I can say, for example, speed is equal to 5, and as I said, that's still a decimal point number. We can say 5.0f like this. For a float, if you are adding these point or decimal numbers, you need to denote that it's f float, because we also have a double, and I'm going to call it, I don't know, health, for example, which is equal to 100 like this. So for a double, we don't have to add f at the end, and they are both decimal point numbers. The only difference is that a double can go up to, I don't know, let's say up to this many numbers in decimal points, something like that, and a float can go up to this number. And this is just my rough guess. I don't know 100%, but in Unity, most of the times we'll use floats. Now, before we proceed, let me just denote this or break it down. So over here, we have a float, and this is a type of variable. So it's a type. In order to declare a variable, we first need to declare its type, then give it a name, and optionally give it a value. Why do I say optionally? Well, because we are not obligated to give a value to a variable right away. We can simply say float speed, and there you go. And we end the statement of declaration by using the semicolon over here at the end. So this is a float type of variable with the name speed. And over here, this is a float type of variable named speed with a value of 1.4. So this is how we declare variables. First, the type of the variable, be that a float or any other variable from the next variables that you are going to talk about, and then we add over here speed, or give it a name. It doesn't have to be speed, it can be power, it can be mana, it can be stamina, it can be whatever. But then you give it a name, because this is the name you're going to use to reference that variable in your code later on. And over here you can give it a value. And I said it can be optional, because most of the times, or a lot of the times, you will have variables that you just declare, and then later on in your game you assign it a value on the go. Okay, so moving forward, the next one is a double, and I don't know, we can call it mana, which is equal to 15.4 or 15.5. Basically the same concept. Type of the variable, name of the variable, value, which is again optional. And we said, or I briefly talked about the difference between a float and a double. A double is a little bit more precise, but you can research, and I encourage you to do that on your own. Just go online, type what is the difference between a float and a double in programming, and then you will see. But in Unity, most of the times we will use a float variable. Moving forward, the next one, we have an integer, which is int. So that is a shortcut for writing that type, or basically that's the name of the type, how we write it, int. We don't write it integer like this, simply int. And we give it a name, for example, health, which is equal to 100. And an integer is a whole number. It's not a decimal point number, it's a whole number. So we cannot do this. We cannot say 100.0. As you can see right away, we have this error over here telling us that we cannot do that because we declared an integer. It is expecting a whole number without decimal points. So that's an integer. And again, type int and then name and then value, which again is optional. The next variable that we have is called a string, and a string is a set of characters. So over here we call or type the type string, and then I can say name, for example, from our character name, and we use quotes. So these two quotes is where we put the value. So for example, I can say warrior like this, and there you go. So this is how we create a string, and it is used to represent text in our game. For example, here we set warrior, and it can be the player name. So I can say something like over here, player name, which is referring to the player or the character in my game. And again, we type the name or the type of the variable, which is string, and then we type the name, give it a name that we are going to use later on to reference it in the code. And then over here, we give it a value, which again is optional. And we will use strings to find game objects in the scene by given name. We will use it to compare tags between game objects when we want to detect collision between them, and so on and so forth. And the last variable that we are going to use or introduce is called a bool variable or a boolean. And for example, I'm going to call it like this, is dead, which is equal to true. Now, a boolean is a variable that only has one of two values. It can either be true or it can either be false, as you can see over here. And the name of the variable is boolean, but a shortcut or how we declare it is bool. So B-O-O-L. And there you go. So this is the type of the variable, this is the name of the variable, and this is the value of that variable. Of course, as I said, we're declaring this on top, so it can be optional, but later on in the code in our game, we add values to it. We will see examples of that. We also have another variable which is called char, which is a character, and I can call it one char. And basically a character, and this one char is, for example, like this. So it only stores one character, but most of the times we will use strings. I say most of the times. I'm using Unity for 7 years and never once have I used a char variable in my game or in the tutorials that I'm doing. But I'm just mentioning it here because probably if you went or if you tried to program before, you probably saw this variable, or maybe you saw it in another tutorial. So I'm just going briefly to explain, or I just explain what it is. It's basically a variable that can hold one character, but we have a string that can hold multiple characters. It can also hold one character. So W over here is the same thing. The only difference over here, when we declare a char, we only use one quote instead of two quotes when we declare a string. And notice also on the end of every one of these variables declarations, we are using these or this semicolon to end the statement. If you don't use it, then again, you will see over here, you will see an error because it is not detecting this as the end of the line in the declaration. So basically, these 5 variables. So we are not going to count in the char because, as I said, I'm using Unity 7 years. Not once have I used char in my projects. So float, double, int, string, and boolean. And most of the time it's going to be float, int, string, and boolean. So these 4 variables without bool, and I can put actually without the double, and I can put the double here at the top. So these 4 variables are the ones that we're going to use a lot and most of the times when we are developing our games in Unity. And again, float a decimal point number, double a decimal point number, integer a whole number, string, character, holding variable, so variable that can hold characters from 1 to more, and a boolean which is either true or false. Now, before we end this video, I also told you that we are going to talk about comments. And what are comments? Well, when you first created this class or this script, you saw those green letters with double backslashes. Basically this over here, I wrote class. Comments are not compiled by the compiler. Basically you can write there whatever you want to write and it will just stay there as a reference. And in programming, people use that to denote what that particular part of their code is doing. So for example, over here I can backslash. If this is a backslash, for those of you who are going to correct me, I don't care, I'm just kidding. But anyways, over here, write anything you want. There you go. And this will not be compiled by the compiler. We would not have any errors for this. And as I said, you use it to note down what a particular part of your code is doing. You can also write comments like this with the backslash and then star and backslash again. And now anything you type over here, anything, so anything in between is a comment. So you can also write a comment like that. And you will notice when you first create a script in Unity, you will see 2 functions. One is start and another is update, and you will see 2 comments above them. So a comment here, and you will also see a comment for update. I cannot remember exactly what the comments say, but they are comments. And as I said, backslash, so 2 backslashes, and then you can write anything what you want to write. So for example, over here we can do something like main variables for class, something like that, and then you know what they are. And over here you can end them, for example, end of main variables for class, something like that. I'm not saying you should do it exactly like this. You will see people telling you there are naming conventions, there are other conventions, how you use this in your code. But what I learned during my own development is that you develop your own way of using comments, your own way of using things, how you want to use them. Of course, if you work in a company, you must follow their own conventions, naming conventions, comment conventions, how they are using it. But for yourself, you can develop one your own and use it however you want to use it without any problems. The main thing is that you understand what they are and you can program with them. So basically that's it. Let's talk about the scariest part in game development, which is math. And this is something that a lot of people are asking me. Can I be a programmer if I'm not good at math? Do I need to learn math, physics, so on and so forth? Listen, this video is going to show you that everything you need to know about math in game development is plus, minus, multiply, and divide. So let's get into it. Over here, I have my start function, and if you don't have it, simply type start like this. So it's start, but because I have it, it's not going to give it to me. So here it is, start, and there you go. Or you can simply type void start. Later on, we will explain what is private, what is void, what is start. Don't worry about that, but just know that start function is the first, or actually the second function that will be executed when a program runs in Unity. Awake is the first one, but we will talk about that as well. What I wanted to show you over here is first we need to go inside of our Unity editor. And we can use our own character over here. It's not important. So we can select a new character or this one over here, or we can simply create an empty one and we can call it learning how to program. There you go. And now we can attach our learning how to program script on him by simply dragging it over here inside of the inspector on the game object itself. Why is this important? Well, in order for every script to run in Unity, it needs to be attached on a game object. That is a script that inherits from on a behavior. We will talk about that as well, but we need to attach it. for this start over here in order to run, if it's not attached on a game object, then it will not run. So what I want to show you first before we dive into operations is that we have two functions that we can use to print in the console. If you remember, I talked about when we introduced programming, or actually Unity's interface, we talked about this console over here. And I said that over here, you will see errors that you have in your own project and also the debug.logs that you output. So there are two ways how we can do it. We can use print over here, or we can use debug.log. Both of these take a string, which is a double code that we learned in the previous video. So in order for us to print, we use a string. And over here, I'm going to say this is from print like this. And over here, I'm going to say this is from debug.log, so that we know from which is printed. So if I go back in Unity, in order for this to work, we need to hit the play button. When we run our game by clicking the play button, there you go. So we see here, this is from print, this is from debug.log. So you can use either of these. It doesn't matter, you can use both. We will probably use debug.log most of the time, but if from time to time you see print and vice versa, don't worry, it's the exact same thing. So now that we know how we can print out messages to the console, let's perform a few operations. So over here I can declare an integer a and I can declare an integer b. First a is equal to, let's say, 10, int b is equal to 5, and we can have an integer c. Now this integer c can be a product of these two. It can be 10, it can be c is equal to a plus b, for example. It can be equal to c is equal to a minus b, or a divided by b, or a multiplied by b. That's all there is to it. Basically, I can sum it up in this single sentence. That's all there is to it. For more complicated operations like math, or actually sine and cosine and calculating angles, you have built-in functions for that, and you have Stack Overflow and Unity answers for that as well. So you don't have to worry about that. And every single programmer in the world uses these resources. So don't think less of yourself that you're not a programmer if you use them. So let's do it like this. Over here we can say a plus b is equal to, and notice now, because this is a string, we cannot simply add over here c. So we cannot say it's equal to c, and here I'm going to say a plus b like this. We cannot say it's equal to c because this will print out in the console. It will simply print out a plus b is equal to c. If I hit the play button, we will see that now inside of the console over here. There you go. A plus b is equal to c. We don't want this. What we want to display this result. And how we can do that is by using string concatenation. That basically means we are adding to the string variable a variable that's not a string. Or it can also be a string, but we're adding to it another variable. In this case, an integer. So over here we can say a plus b is equal to c. And now outside of these quotes, so outside we can say plus, and then we can say c. And there you go. This is going to concatenate or merge this string with this integer, and it will merge it and create a new string out of these two. So if I go back now over here, notice the difference. Currently we have a plus b is equal to c. If I hit now the play button, we will notice in the console a plus b is equal to 15. There you go. And we can also do it like this. So we can say something like, I can remove this from here, and I can say a, which is the integer, plus, and over here with a space in these quotes because we want to separate them. It's like writing. So think of it like this. If I say a plus b, I want to separate them. So space here, space here. In order to do that, I'm adding space between these two quotes. So a plus, and over here, I'm going to add the plus sign. So a plus, and over here plus b, and again plus, and in quotes again use space is equal to, and then space, and then plus c. So essentially what we are doing, we are concatenating this integer and this string with the b integer, with this string, and lastly with c. So now over here we can add whichever numbers we want. We don't have to type them over here as we typed them a moment ago. We don't have to say debug.log, and over here we need to type 10 plus, so 10 plus 5 is equal to, actually we typed a plus b, but we don't have to type it like this, 10 plus 5, and then it's equal to, and then plus over here c. Because now if we change the number over here to 11 and over here we change it to 7, we need to do the same thing over here. So 11 and then 7, there you go. But if we're using this over here, we don't have to change these values. They will be automatically changed by changing them over here. So I can remove this, and now 11 plus 7 is going to be 18. If I go back over here, let us just wait for Unity to compile everything, hit the play button. We will notice 11 plus 7 is equal to 18. Same thing, we can do, for example, 20, and over here I can say 5, and I can say C is divided. So A divided by B, and over here I'm going to, instead of plus, add the divide sign. So if I go back, now we're going to calculate 20 divided by 5, that is going to be equal to 4. There you go. So 20 divided by 5 is equal to 4. We can do the same thing with multiply. So over here we can multiply, over here we can change that. If I go back inside, and I know this is a tedious process when it comes to going back and forth, but this is how it works. We cannot speed it up except for us to have a faster computer, and mine's pretty fast, so be thankful. Thank you, teacher. Anyways, 20 multiplied by 5 is 100. And we see all those results inside of the console. We can also use the minus. So 20 minus 5. And again, we can go back inside of Unity. And I can hit the play button. And we will notice 20 minus 5 is 15. Now, one thing that I want to notice or emphasize, for example, if I have 7 over here and we use the divide, because this is not the decimal point number, then integers are whole numbers, they will round up to a whole number. Even though 20 divided by 7, it's less than 3, because 21 divided by 7 is 3. But if I go back now, it is going to round it to the closest number of the decimal point number it is. So over here, 20 divided by 7, it's 2. Which brings me to the part of precision. So if you want precise calculations, decimal points, you will use float. So over here, I'm going to use float, and over here, I'm going to use float, and there you go. So now, instead of this calculation being equal to 2, so 20 divided by 7 is 2, if I hit the play button, now it is going to calculate 20 divided by 7 is equal to 2.85. And these other decimal point numbers, but we're interested in the first two. So 20 divided by 7 is, as you can see, a decimal point number. That's why now you understand why we have decimal point numbers, why we have integers, and all the other variables. So some variables are used for some things and others are not. So for example, over here, in order to calculate a number, a precise number that we need, in this case, we need to use a float, because an integer is a whole number. It will round up to the full number and it will not display the decimal pointed numbers after it. And same thing works for the multiply and subscribe, multiplication, division, and addition, not subscription, addition. So if I hit the play button, and over here it says 20 divided by 7 is 140. I forgot to add over here the multiply, but you get the point. These are the basic calculations or operations, mathematical ones, that you need to know in order to program in Unity and generally in programming. It's not the scary thing that a lot of people think and believe, oh, you need to know this or that. Look at me. I was one of the worst kids in math and physics overall, in elementary, in high school, and even in college. But I'm living out of game development. I'm earning money from this, from my games, from my YouTube channel, from game development overall. And I'm, supporting myself, and I don't know math. So you can do the same thing, same exact thing. Anyways, this is when it comes to operations with variables. Now you can, and I encourage you to experiment on your own. Try these operations. Also try these string concatenations in order for you to memorize them faster and be acquainted to them or get used to them. And again, string concatenation is by adding or using plus to add to a string. I can do something like this. I can also say string I don't know, let's say AA is equal to, and over here I can say A and I can say plus A, like this. You see, I can say a letter plus A, which is a float variable number 20, and it will add that and it will create a string from that. So basically think of string concatenation, just adding plus in the string in order to append to it or merge two variables into one variable. It works with floats, it works with integers, with doubles, it works also with other strings. So you can have over here string, I don't know, name, which is equal to Carl, and you can have string last name, which is equal to Florian, and you can have a new string out of these two. So you can have a string full name is equal to name plus last name. This also works. So it doesn't have to be only numbers in string concatenation. Two strings work with each other as well. So just I encourage you to practice that a little bit. Stop this video right now, don't move on to the next one, just practice this. Write down some basic operations, debug.log them, concatenate them with the string, and that way you will learn and memorize them much faster. Using the example from the previous video where we performed the operations with variables, we are going to demonstrate a new concept which is called a function, or grouping a block of code. What do I mean by that? Well, for example, over here we have float A and B, and we want to calculate float C by adding A and B, and this can be a tedious process. So for example, we need to call this code in, let's say, 10 places in our project. Now, it can be a tedious process for us to do all of that. So instead, what we would do, we would group a code in a function. So what is a function and how do we declare a function? Well, over here, you're looking at a function. So this void start is a function. This is a built-in function, basically inherited function. We will talk about that when inheritance comes, don't worry about it. But this is a function. And in order to declare a function, you type void, which means the function doesn't return anything. And we will get to that, don't worry about it. So you type void, then name of the function. We can say, for example, over here, calculate numbers or two numbers, like this. And then open close parentheses, open close curly brackets. This is a function. This concept, or this struct over here that you see, is called a function. Now, any code that we put inside will be executed. What do I mean by that? Well, we can simply say debug.log, just for the sake of it, for the sake of the example, we can say printed from function, And instead of us calling this over here, we simply need to call the name of the function. I'm going to call it over here in the start method, because we know in order for the game to run, or start function is the first function that will be called. Awake is actually the first one, but we will get to that, don't worry about it. But for initialization, you use start. So go over here and hit the play button. We will notice in the debug.log printed, or printay, I didn't add D at the end, and I don't want the D at the end, okay? Don't judge me. Anyways, moving forward, we have over here printed from function, which means when we call this, actually it will execute the code that we have over here. So this is what is a function. Think of a function as a basket that holds your code. So instead of us doing all of this over here, we can simply add it here inside of our function, and there you go. We can remove it from here, and I can simply use the sum is, and I can say the sum of A and B. So removing this from here, I can say the sum of A and B is colon, and over here plus C. So that is going to be the sum of A and B. And we can go over here inside of our Unity editor. Let me clear the console so that we don't see anything. Hit the play button, and we will see the sum of A and B is 22. We can also use the sum of, over here, add, append A, or concatenate A and B to see the numbers, but that's not important. The important thing is now we don't have to call these 3 lines of code everywhere in our project. Instead, we can simply call calculate two numbers. Now, this is a basic setup of a function, and this is called a normal, basically no name, but I'm giving it like a name, a normal function. That means it doesn't return anything, which says here void, and it doesn't take parameters. What does that mean? Well, that means for the returning part, we will come to it, just wait. But for the parameters, let's say over here we have float A and float B, which have values 10. And what if we don't have to calculate, we don't want to calculate 10 plus 12? Maybe I want to calculate 30 plus 2 or 100 plus 3 and so on and so forth. What can we do there? Well, over here, I can say, for example, void calculate to numbers, and here inside of these parentheses, so open close parentheses, and over here inside of the parentheses I can say float A, and then I can say comma float B. So now instead of me calculating rough values or hard-coded values from A and B are here, and I can say something like debug.log, and I can say the sum of A and B is over here plus, and in parentheses I can say A plus B. We don't have to create C in order to do this. You can do the calculation right here in parentheses, because then it will calculate A plus B and it will append that into this string. So over here now I'm going to comment this out, and by the way, I selected this line of code and command and backslash. On Windows, it's probably control backslash, or you can look it up on Google. It's not important. So now I can say calculate two numbers. Instead of using the default one, which is 10 and 12, I can say, I don't know, let's say calculate 30 and 22. So now this will give me a result of 52. If I go back inside of Unity, wait for the painful compiler to compile and hit the play button, we will notice now in the console the sum of A and B is 52. So this is a function that takes parameters. Over here I'm going to add a comment, a function that doesn't return a value and doesn't take parameters. There you go. And over here, this is a function that doesn't take, so a function that doesn't return a value but takes parameters. Now, one thing that I want to point out over here is that I've used two floats as parameters. You are not limited by that. You can add whatever want from parameters. It can be 10 floats, 400 floats, whatever, and they don't have to be floats. It can be two integers, it can be booleans, it can be strings. Later on when we talk about objects, they can be objects. Just remember that parameters over here can be whatever type you need it to be. Maybe you don't need to calculate two floats, maybe you need to calculate two doubles or two integers. You get the point. Now let's talk about the third type that I call a function that returns a value. So over here I can say float and I can say return to numbers, so numbers like this. And I can return a float, and over here I'm going to add a return statement, because a function that returns a value, it needs to have a return statement. So I can say, for example, 20 plus 30. That can't do. Notice the difference. The difference is over here I've used void so far on these two that indicates the function doesn't return anything. Over here I'm using a float and I'm returning 20 plus 30, and I can go over here, I can comment this bad boy out, and I can simply say debug.log, and from here I can say the sum is, and over here I can say plus return two numbers. And I need to call it as a function, so with parentheses, and I am appending that over here in a string. And if you're wondering how can I append a function to a string, well, because this function is going to return a float, so essentially this over here is going to be a float. And if I go back, and I will demonstrate that in a moment, because if I go back over here, I'm going to clear everything, I'm going to hit the play button, you will notice that here it says the sum is 50. Which is 20 plus 30, which is basically what we did. And going back to what I said, this is a float, we can do something like this. We can say float sum is equal to return two numbers. There you go. And over here, instead of return this value, I can say sum, and the outcome will be exactly the same. So what does this mean? This basically means that over here, we are returning a float. We can return an integer. a boolean, a string, an object. Later on, we will see that. When we talk about objects, we will see how we can also add objects in these parameters. So that can also work. But I'm using float as an example. I need to mention this so that you don't think and somebody doesn't get confused and thinks that only a float value can be returned. So that is not the case at all. So this is a function that returns a value. And before somebody asks for what we can use these functions, don't worry about that for now. For now, just remember what are functions and how you can create them and how they're structured. But later on, when you create your game, it will depend. For example, you will group all your code in functions. When you move a character, you will put the code that moves a character in a function called moveCharacter, for example, or something like that. You will have a function to attack the enemy from the character. So you will create the code for attacking and you will put it in a function called attack, and so on and so forth. And the last function that we have returns a value. So over here I'm going to say float, and let me check if I can actually reuse the same name, return to numbers, because I'm not sure if I can reuse the same name. And over here I can say float a comma float b comma, there you go. And no, I cannot return, I cannot use the same. So what I can do over here, calculate sum. Actually, no, I didn't return it, so I need to say return a plus b. There you go. And yes, I can use it now. Because you cannot have functions with the same name, but over here they are different because this doesn't take any parameters and this one takes parameters. So you can have multiple functions with same name but different parameter types or different parameter numbers. Now this is exactly the function that we would use for a case like this. For something where we need to calculate two numbers. Instead of doing all of this what we did so far, we can simply do it like this. We can say debug.log, so .log, and over here we can say something like the sum of, or simply sum is colon, and over here plus, so plus, come on, it's plus, calculate two numbers. And over here we can pass, let's say, number 10 and number 20. And there you go. Did I call it actually return two numbers? Excuse me. So over here we need to say return two numbers. This function is not only going to take these two parameters 20 and 10 or 10 and 20, it's also going to calculate the sum of these two numbers and return it to us. So now I can go back over here and we will see that 10 plus 20 is actually 30, which you will be surprised to hear. And there you go, sum is 30. So, a recap, what is this? This function returns a float and it takes two parameters. Again, you don't have to, you're not limited by two parameters. You can have 10, 20, 30, 40, a gazillion parameters. You can have floats, booleans, doubles. And it doesn't have to be all floats or all integers or all booleans and doubles. You can basically mix them up. You can have a float, then an integer, then I don't know, a boolean, a string, an object. All that can be parameters on their own within the same function. So don't worry about that. Quick recap again. So this is a simple function that only groups a block of code. For example, over here you can, instead of calculate two numbers, you can name this function player movement or move the player. And over here you will add the code to move the player. And instead of typing, let's say you need 100 lines of code, for example, to move the character. Instead of using those 100 lines of code over and over, all over the place in your code, you're going to group all that code in a single function and then use that function to call it in your whole project. And that way, when you get an error, you know that's inside of that function. You don't have to go and inspect thousands of lines of code to find where your problem is. Next, we have a function that takes two parameters. So for example, we can have a function, let's say deal damage. And over here, we would have a damage amount, an integer or a float representing the damage amount to the player. So we will call deal damage, passing the parameter same way as we did over here, and then we will subtract from the health and so on and so forth. Next, over here, we have a function that returns a value, and we return a float. Imagine in a real game where you have a character and he has health stats. So, for example, how high his health number is, stamina, mana, magic. We can use the return function to get that value. So we can say, for example, return health status. And there we can return the health value of the player. And finally, we have a function that returns a value and takes two parameters. And over here, we pass two floats. Again, it can be whatever you want it to be. So it can be a float, it can be a boolean, it can be whatever. And at the top of my head, I cannot think of a situation practically like for what I can use it, but probably you can use it, for example, I don't know, if you want to calculate, let's say, players' stats or progress based on his health and mana or magic, or for example, if he can cast some power, so you can over here add a power type, which can be an integer, for example, and over here you can check or add the mana of the player and then compare the two. So depending on the mana's value, if the player can, I don't know, cast that spell or he cannot. And this can be a boolean value that you return. So it can either be true or false. So you can say if mana is greater than 50, then he can cast this, for example, magic. And then you can return either that is true or false. And then you can use that in your code to check if it's true, cast it. If it's not true, then don't. Again, use this and practice. So practice a little bit, create functions. You see them over here. I'm not going to delete them right now. You can see them, pause the video, practice, create your own functions, and try to understand how they are. Basically, functions are just grouping of code. Functions that return a value need to have this return statement. That's why they are called return functions that return a value. So you need to have a return and the value that you want to return. When you're playing a video game, a lot of choices are being done behind the scenes. For example, if the enemy is dead or not, if the player health is below 0 or not, does the player have enough mana to throw this magic or not, and so on and so forth. And in order to achieve that, we use conditional statements. So what are conditional statements? Well, basically we use them, and the most famous one is the if statement, and it goes like this: if and open close parentheses. And as I was saying, we use them to test conditions. And over here, open close curly brackets. Now here we add conditions that we want to test. For example, imagine that we have a float that is called health, which is equal to 100. And this is the health of our character. We want to test if the player is dead, or should we kill the player. So over here we're going to say if, and inside of these parentheses we are going to test if health is less than 0. If health is less than 0, over here we can say player is dead. Do the appropriate things, what you want to do when the player dies. And this is called a conditional statement. And we use them to make choices in our game. What's important to know is inside of this conditional statement, what you add, the condition will either be true or it will be false. Meaning, if, and over here we're testing. So think of it like when you're coding, think of it like you're talking to the computer. So over here you're asking the computer if health is less than, and this is the less than sign if you've been to school, even if you didn't. If you know how to calculate numbers, you know the less than sign, greater than sign, less than or equal to, so on and so forth. These are basic things. So if health is less than 0, if that is true, code here will be executed. So if health is less than 0, then condition is true. And then code that is here will be executed. There you go. That's all there is to it. So this is a conditional statement. Now over here we can add whatever we want, but I also want to talk about another thing, that is, what if this is not true? Well, we can continue to add more conditions. So we can say if our health, or actually it goes else if our health is, let's say for example, if it's less than 50. Maybe if the health of the player is less than 50, you want to give the player some boost, or maybe you give him some weapon that he cannot use if he has full health, so on and so forth. So over here, else if health is less than 50, then what we are going to do? you can add the code over here. And you can go like this forever, else if, else if, else if. And in the end, if you want to have like sort of like a default value, then over here you can say else, which means if all of these conditions here are not true, then else will be executed. Of course, if you don't want to use it, then you don't use it. But if you want to execute something, then you can have a condition like this. So basically over here, we're testing if our health is greater than 0, if or else if health is less than 50, else if, so on and so forth, or else, and then over here the code will be executed. But one thing to remember is when you're using else, that means if all conditions before this else condition, so if all other conditions are not true and they don't get executed, then else over here will be true. And when I say all other conditions, it goes like this. When the conditioning starts, so when it starts executing, it will test if this over here is true. If it's not true, it will move to the else if. If that is not true, it will move to the next else if you have it, and so on and so forth. And then at the end, if you don't have any more else ifs, it will go to the else condition. And it will test it, or actually it will not test it, it will execute the code that's here right away. So when it gets to else, it will execute that code right away. Now, of course, over here, one thing to remember is that you don't have to test if health is less than 0. You can test if it's less than or equal to, meaning if health gets to the value that's equal to 0 or below 0, that means the player has died. You can test if the health is greater than 0. You can test if it's equal to 0. So this is how these are the special characters, or how to say, these are the characters that you use to test that. I'm out of words, okay? But you get my point. Anyways, if it's greater than or equal to, so this is the test if it's greater than or equal to. This is if it's greater than, if it's less than, if it's less than, or equal to. And lastly, if you want to test if it's equal to 0, you don't use a single equal sign, because a single equal sign is used to assign values to variables. For example, over here, we used health is equal to 100, meaning we have assigned 100 to health. And if you want to test if it's equal to, so if health value of the health is equal to 0, you use the double equal sign. There you go. So if health is less than, or actually over here, if it's equal to. And these over here, they need to be true. So these statements over here, they need to be true in order for this to execute. So this is when it comes to the if, else, and you can have a gazillion these else, if, and so on and so forth. Even inside, within an if statement over here, you can have another if and some condition to test, and then you can, perform actions based on that condition, so on and so forth. So you can, or while you can nest if statements inside of each other, don't over nest them. So don't have like a gazillion ifs inside of ifs, and so on and so forth. Now, another thing that I want to show you is over here, and basically I'm going to go below. I said that if, for example, health is less than 0, that needs to be true in order for something to happen over here. But we can have multiple conditions inside of a single if statement. So for example, over here we can test if health is greater than 0, and over here we can test or if health is, I don't know, let's say, actually over here, if it's less than, I don't know, let's say 20, and over here, or if health is less than 30. For example, just imagine this is an example because you would not test it like this. You can just test it if it's less than 30. But of course, if you want to do something for this specific range, when the health is at that value, then you will test it like this. So these double pipe signs mean or, which means if this is true, or if this is true, so if either of these conditions are true, then execute the code in here. Basically, this is a shortcut instead of typing if health is less than 20, or actually first if health is less than 30, and then inside we would add another if health is less than 20, and so on and so forth. You get the point. So over here, instead of testing it like that, we can do it in a single statement, which means if this is true, or if this is true, then the whole condition is true. Only if both of these are false, then this over here will not be true and the code inside will not get executed. I'm saying this that both conditions over here need to be true because we also have the AND parameter. So over here, actually the operator AND, which is the double AND sign, which means if health is less than 20 and health is less than 30. Basically, you would test it if health is less than 30 and health is less than 20. In this case, both of these conditions, they need to be true in order for the whole statement over here, for the whole condition to be true. If this is true and this is false, for example, if health is 25, and you will get to the point and over here you will see health is less than 30, and if health is less than 20, if health is 25, this will not get executed. And of course you can use debug.logs over here. I'm just trying to spare the time because over here, and I want to assign that to you because I want you to practice and I want you to put this into good use. I'm going to show one example at the end, of course, but then you will practice on your own. But basically in this case, both of these conditions, they need to be true in order for this whole statement to be true. So when you use the double AND sign, this means AND. So if health is less than 30 and health is less than 20, that's what you have over here. And over here we can use a simple debug.log. So we can say, as I said, as an example, health is 0, player has died. If health is less than 50, then for example we can say over here health is 50 or less than 50, unlock some power for player, something like that. And over here else, then the player has health greater than 50, for example. We can say that like that. So over here I can say something like player has health greater than 50, for example. And of course if we go inside of Unity we can see this in action, but as I said, then I want you to practice. I want you to practice and see, although you see player has health greater than 50, and which means this over here has been executed. As I said, if neither of these conditions are not executed or not true, then else will be called by default, which means over here I want you to change the value of 100 of the health and test out these conditions, but that is on you. I want you to do that because that's how you will practice. Before I go, and I don't mean go away forever, except if I die after this video, you'll probably be glad. Maybe not, maybe you love me, but you know, thank you for that. Anyways, here we have another conditional statement, which is called a switch. And it goes like this. We call switch, open close parentheses, open close curly brackets. Inside of this switch, we add a condition. For example, the condition can be health. So now, in order for us to execute the code, we need to have cases. And over here we can have a case, for example, I don't know, let's say case 100 and colon and then break. And then we can have a case of, let's say, 50 and then break. And we can then have a case of 0 and then break. What does this mean? Since this is a float variable, we are adding it to the switch statement. Basically, we are testing the value of the health inside of this switch and case, which means in the switch over here, we add the value we want to test, which is health. And now we are testing its values. Case 100, meaning the value of the health is 100. What then? Well, we're going to say debug.log, and over here we can say health is 100. So health is 100. Case 50, that means the value of the health is 50. We can say health is 50. And then case 0, and over here we are going to say health is 0. Because the value of the health is currently 100, you can imagine what's going to happen when I go back over here. Let me just clear the console and hit the play button. We will see now health is 100. That's all there is to it. So this is switching case. So over here, imagining it to convert it, to translate it into if statements, we're testing if health is equal to 100. So this is what we are doing. Else if health is equal to 50. And then over here, else if health is equal to 0. What about the else, the default one over here when it comes to the switching case? Well, the default one is the default. We simply type default and over here break. But what is this break? Well, break breaks out of the switch and case, meaning if health is 100, it will go into this case, it will test. If health is equal to 100, it will execute the code that we add over here. It can be, you can have 100 lines of code over here. You can have a function that has 100 lines of code, so there is no limit to that. After all the code is executed that we have, the break statement will be hit in execution, and then it will break out of the switch in case, and it will not test other cases down below, so that it doesn't risk of executing those because we already executed one of these cases. So the default one, we can say over here, not the default, I was going to type default. Over here we can say health is neither of the values above. Not sabots, it's above. Which means if I set over here the value to be 101 and I go over here inside of my editor and I hit the play button, we will see that health is neither of the value above. Basically values, but not value, plural, not singular. But anyways, it's not important, you get the point. So this is how we can use switch and case. I want you to practice switch and case and if statements. I want you to practice these on your own. Use the debug.log, use these statements, change the values over here. I've gave enough examples and explain it. Please rewatch the video if there is a need to do that and ask questions if you don't understand so that I can explain it. But I believe that these conditionals are easy to understand because there is not much to them. And you can also test the or and. So if health is less than 20 or health is less than 30 and health is less than so on and so forth, you get the point, but you change these values. By changing these values, you will see the output for every of these cases and all these conditions, and that way you will understand much better. So this is what I emphasize. So please practice, and yeah, these were conditional statements. One of the things in programming that you will do a lot is repeat yourself. Repeat yourself. Repeat yourself. See what I did there? I'm very funny. Anyways, but that is true. You will repeat a lot of the code that you have in your game. And instead of you retyping it every single time you want to repeat it, for example, over here, if we have a debug.log and it's .log like this, if I can type it correctly, and over here I want to type something. So type something. I want to repeat this 10 times. I would do this, this, and this, and this, and this, and this, and this, and this. You get the point. Now, just by looking at it, you see it's tedious, you see it's not practical, and you see that you will probably go insane and kill me for showing you this. So what is the better solution? Well, a better solution is something called a loop. And a loop goes like this. You type for, and inside of parentheses, you type int I, which is equal to 0, and I is less than, let's say you want to repeat this 10 times, so I'm going to say less than 10, and over here I'm going to say I++, and there you go. Now, before we all go in the panic mode, let us explain what this over here is. That's why I'm going to be a good teacher. I'm going to take the annotate screen, I'm going to draw it for you. So you first start with the for, which is a for loop. So this is called a for loop because, well, you can see over here we have the for. Now, int I is basically a loop or a variable, it's a variable that we are going to use inside of this loop. So this I, which is a type of integer, we can use this variable inside of the loop over here. So between this curly bracket and this curly bracket, it's going to be the code that we are going to execute inside of that loop. And as I said, we can use this I inside of that loop. The current value of the I is set to 0. Now, this is the condition of the loop. So the loop has a declaration, a condition, and the iteration. So this is the condition. The condition is, as long as I is less than number 10, we are going to loop that number of times in this for loop. And every iteration, we are going to increment I by 1. Now, if you're wondering, I++, what the hell is that, teacher? Confused me, I never saw that in math. Well, I++ is a shortcut. So for example, if I have, for example, over here, int I is equal to 0. And I want to increase it by 1, I can say I is equal to I plus 1. That is totally legit. It will increase it by 1, so it will take the current value of A, and I said previously I know that, don't judge me, plus 1. But a shortcut for that is simply saying A++, and there you go. So now this variable is increased by 1. It says plus plus, which means add 1 to that variable. So add 1 to that variable. And we can test it out. So I can use the same things. I can say debug.log as we did a moment ago. And I can say this, the value of I, colon, and space, plus, and I can add over here I, which is this one over here. And we can see this in action. So if I go back over here in my Unity editor, I can go into the console and hit the play button so that we can see what is going on over here. And there you go. So you see the value of I is 0, then 1, then 2, then 3, and it finishes at number 9. Now, before you say, but teacher, you said over here as long as less than 10. Yeah, but it started from number 0. So it goes 0, 1, 2, 3, 4, up to number 9. If it goes from 1, that it will be 1, 2, 3, 4, 5, 6, 7, 10. And I cannot count, I know that. But if it starts from 0, it goes from 0, 1, 2, 3, up to number 9. Which in total, and you can count this, in total over here, we have 10 iterations. So this is a for loop. Now, for what we are using a for loop, as I said, when we have a code that we want to repeat, when we have arrays that we want to iterate, in the next video we will see what arrays are, don't worry about that, and things are going to start to click, and you will see how we can implement all of these things that we are using. Now, another type of iteration that we have, so a loop basically, is called a while loop. And don't worry, I will recap this, but I believe it is crystal clear. There is not much for a for loop. For example, over here, I used a hard-coded value of 10. You can have a value over here, for example, int iteration time is equal to 10. And over here, I can use, instead of 10, iteration time, which means it will iterate this many times. And I can just change this number. If I say here number is 100, this means that this loop will iterate 100 times. And the code between these two curly brackets will execute 100 times. So basically, how many times the loop will iterate depends on the condition that you have over here. It can be less than or equal to as well. It doesn't have to be less than. It can be less than or equal to as well. So this is basically the condition setup that you can set up. The condition setup that you can set up, I mean, for your iteration. This is for the for loop. Now, going back over here, we have also another type, which is called a while loop. And it goes like this, while in curly brackets, actually in parentheses, then in curly brackets. So over here, the condition that we add in a while loop, it needs to be true for the while loop to execute. So over here, if I want to do the same thing, I'm going to take this and I am going to paste it over here, except I need to remove the value of I. And now, if I were to run my game, this will probably crash my computer. Why? Well, because this is a while loop that will never end. Its condition is forever true. And yeah, we will execute this a gazillion times until my computer explodes. I don't want that. Neither do you. So how can we set up a condition that will actually expire? Well, we can do it like this. We can say int I is equal to 0. And over here, we can say as long as I is less than 10, for example, we can debug.log the value of I plus I. But over here, inside of the while loop, we need to make sure that this condition will eventually get to be false. Otherwise, again, this will be an infinite while loop. So over here, I'm going to say I++. So this is the equivalent for this over here. It's going to spit out the exact code. It's not going to spit it, actually. It's going to write it down. But, you know, I'm slanging over here. If I hit the play button, you will notice that the same values are printed. You see, from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the same values are printed, but it's a different loop. And again, when we are using while loops, we will see a lot of examples for that. Do not worry about it. We will see it. We will cover it. We will go through it. But one thing to remember when it comes to a while loop is that make sure that this condition, no matter what it is that you have over here, make sure that this condition will eventually get to be false. Otherwise, you will have an infinite while loop, and that's when your programs are going to crash, or in this case, games. So the condition over here for me to eventually get to this condition to be false is I++. So I is 0, as long as I is less than 10, go into the while loop, execute the code, at the end increment I so that eventually gets to the value that is, greater or equal to 10, because when I gets to the value that is equal to 10, then this will not be true. We are testing if I is less than 10. And how this iteration works, same applies for this over here. This iteration now that I'm going to demonstrate applies for the for loop as well as for the while loop. So in the first iteration, I has a value of 0. In the second iteration, I has a value of 1. In the third iteration, I has a value of 2. And it goes like that. So then 3, 4, 5, 6, 7, 8, and 9. So this is how it goes. So over here, like this, like this, like this, like this. And what did I do? It goes like this. Yeah. Did I skip a number? It's not important. Yeah, I did skip a number, but yeah. Anyways, you get the point. This is how it works. So every iteration, and what does that mean? Iteration is going inside of the while loop and executing everything that's inside once. In this case over here for the for loop, same thing. Going inside of the for loop, executing everything that's inside of these parentheses once. That's one iteration. So this is how while and for loop works. Continuing on the road of often used stuff in game development, we have a delayed behavior, because a lot of the times when something happens in your game, you want to delay an event that will follow it up. For example, if you enter the chamber of the boss in your game, you don't want the boss to appear right away, but you will register in your game when the user goes through that chamber, and then maybe after 2 or 3 or 4 seconds, the boss will appear. Well, for Unity, or in order to make that happen in Unity, we use something called a coroutine. And a coroutine is also a function. So we know that we have a function over here that I'm going to call void, and let's say perform or execute something. Execute something like this. And we can add over here, for example, debug.log, the usual, because I cannot write, the next Grand Theft Auto right away. It will take time for you to learn that, and something is executed. If I were to call this from the start function over here, we will know that this will be printed in the console just for the sake of example, so you don't think that I am lying to you and you don't accuse me, because people accuse me for a lot of things. Lying is probably one of them. Anyways, something is executed. There we go. So if I go back over here, how can we make this into a coroutine? A coroutine's sign or signature, so to say, is not void, but over here we need to say I enumerator. And over here, as you can see, I have typed I enum, and we have enumerator, blah, 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 blah. We want this one, enumerator. Now, you will notice over here, I enumerator, learning how to code, not all code path returns a value. This is because we said that we are going to return an I enumerator, but we are not returning. And in order to do that, we simply need to say return new, actually yield return, excuse me for that. So yield return new, wait for seconds, and you can assume over here the number that we typed out is going to be how many seconds we need to wait in order to execute the code that's over here. So instead of calling a coroutine like this, which is not going to work, we need to do something like this. We need to say start coroutine, and inside of these parentheses, we need to pass the coroutine with parentheses, so the coroutine name along with the parentheses in order to call it. So if I were to go back now in my Unity editor now, and if I hit the play button, you will notice that not right away, but after 1, 2, there you go, something is executed, is printed in the console. This is called a coroutine, as I already explained. Now, we can also call the coroutine like this. We can say start coroutine, so coroutine, and over here, as quotes, so as a string name, we can pass execute something. What is the difference between these two? Well, the difference is when you call a coroutine like this with a string, then you can call stop coroutine with strings like this in order to stop the execution if for whatever reason you need to stop execution of your coroutine during your game. That's the difference. Now, it's not only once that we can use this yield return, we can use it over here, and then over here we can use it, and then we can have more code here, so more code, then again, but you get the point, this can go forever. You're not bound by only using this once and then having some line of code, and then over here, and all of the good stuff, you get the point. Also, coroutines can take parameters. They are like a regular function, except they have this returning type of IEnumerator, and they need to have this yield return. Don't even ask me what this yield is. I don't know. You can look it up online, but it's not important because it will not improve your knowledge about coroutines. Know that you need to type yield return and then you wait for seconds and you have more of these. So when I say more, you can have yield return new, and over here wait for the end of the frame, wait for fixed update, wait for seconds real time, wait until, while, so on and so forth. And don't worry, we will cover a lot of these when we start developing our game. And coroutines, you can practice them. I am advising you to start practicing them right away, so that you can, again, follow my philosophy that I already talked about so many times during these video series, that the more you practice, the better you will be, and the more you will learn. But what I'm also going to do, because I have a detailed video about coroutines on my YouTube channel for maybe 30 minutes. When I say detailed, I use a lot of examples out of the bat, not in-game, but I show you how that can be used potentially in games. When we start developing our games in the course, don't worry, we will use coroutines a lot. But if you want to examine them even in more depth, I will put a link to that video below this video as well. This is it. This is everything I can say about coroutines because they are relatively simple. They are like a function, except over here, you return IEnumerator and you have this statement. That's all there is to it. As I said, you can have here int, I don't know, A, int, B, so on and so forth. Over here, you can pass 2 and 3. Then you see coroutines are like regular functions. Then, for example, over here, you can use float time. So it can be like this, float time or wait time. That's how you can specify it. And over here, I can say 2. And there you go. Then you can have a flexible coroutine with not fixed time, so you will pass the time on your own. Anyways, as I said, this is about coroutines. Start practicing them right away and watch the video for in more depth about coroutines, which will be below this one. And of course, if something is not clear, make sure that you also ask below this video. Now we're getting into the serious stuff, because so far you're probably wondering, what is this public? What is this class? What is this mono behavior? And how can I put all of that together? Well, now we're going to dive into those things, because the basis of all bases or basics or whatever in object-oriented programming is a class. And you can think of a class as a blueprint for creating objects. What do I mean by that? Well, first, let's go over here into the scripts folder and create a new C# class that I am going to call player. Because in your game, you're going to have a player class. And I'm going to double click it and open it over here, hoping that Visual Studio will see mercy upon me. And there you go. We have mercy. I'm going to add a comment over here at the end so that we know that the class ends here. I'm going to remove the functions that we get by default. I'm also going to move this mono behavior. Now, don't panic. This will not break anything. We will go through it together. I will hold your hand and you're in the right place. So as I said, you can think of a class as a blueprint for creating objects. And in a game, you can have, as you see over here, we have a player. And think of as that blueprint. So we use the class, and this is the blueprint that can create objects. Imagine that you have some sort of game where you have multiple characters, and you have a base class, player, or a character, no matter what, however name you give it, and we can create multiple of these. So we can create one, so one is over here, we can create another one, it's over here, and another one, it's over here. Basically, this is what a class is doing, and in order for that to work, let's imagine that your player has 3 variables. It has a health variable, it has a power variable, and it has a string variable for his name. Now you can understand or slowly see why I first introduced variables to you, then functions, and then we went through all of the things that we went through before we introduced classes, because the classes, as I said, are the basis. They are the base of everything that we will do inside of object-oriented programming. So why didn't I explain that first? Well, as you can see, the parts of a class, or what creates a class, are its variables, its functions, and so on and so forth. Now, one thing that is important to know when it comes to a class, in order to create an object that you just saw, so creating a player, that's called actually creating an object from a class. Remember, blueprint for creating objects. In order to create an object, we need to have a constructor, and a constructor is basically the same name of the class. So over here we will type public player, open close parentheses, open close curly brackets. This is called a constructor. As you can see, it has the same signature as a function, because you create a function by using a name, open close parentheses, except over here we don't have void or a returning statement, because this is a constructor. You see, the name, the same name of the class is the name of the constructor. And now what we can do is we can add, or we can initialize these health, power, and name inside of the constructor. We can do that over here. We can say something like health is equal to 100, power is equal to 50, for example, and the name can be, for example, warrior. Name is warrior, like that. And over here in the constructor, we can say debug.log, and we can type over here. So we can do something like parentheses, health is, and here plus health, not JetBrains. We actually want health. There you go. Copy paste. Over here, we're going to say power is, passing over here the power, and the name is, and passing over here the name. So how can we create an object from a constructor? That's very simple to do. We can go over here in our function, learning how to program, and in the start, we can say, for example, player, and I can say warrior is equal to new player. There you go. So we saw this new when we were creating arrays. I didn't explain it then, but what is this new? New is used when you are creating new objects from a class. So as you can see, this is the blueprint. The blueprint is basically the player, which means the player has a health, power, and name, and now we can create as many objects as we want from that single blueprint. Think of it as a recipe for a cake. You have one recipe, but you can create multiple cakes from that recipe. Simple. And if I go inside of my editor and wait for it, for Unity to have mercy upon me, if I hit the play button, you will notice that in the console, health over here, so you can see health is 100, power is 50, name is warrior. Same thing that we typed out over here. Now this is, or we set those variables up over here. If I were to remove the default values, I'm going to remove them like this. Now they have 0, 0 for health and for our power, and the name is an empty string. So how can we declare these from within the constructor? So over here, I can say int, and I can call health over here, int, I can say power, and string, I can say name. Same way as functions, constructors can also take parameters. As you can see over here, now the name of our own variable is health, and the name of this is health as well. Now, in order to differentiate them, now when we assign them, you can use this dot health, and this dot health is referring to this health over here, and we can say it's equal to health. Now, in order for you not to get confused, I'm going to explain like this. This keyword is referring to the class name itself. So it is referring to the class where we are using this keyword. Dot health, or this dot, and any variable that we use is referring to the class variable that we have declared over here. Is equal to over here health. Now this health is referring to this health over here. You're using this, or we use this when we want to differentiate these, like in this case, but you can also do something like this. You can say underscore health over here, and instead of using this, you can simply say underscore health is equal to health. That can work as well. But for this example, I'm going to use this, and over here, I'm going to remove the underscore. This dot power is equal to power, and this dot name is equal to name. Now, of course, since we changed the constructor's signature over here, we will have an error, which means we need to give it health, power, and name. So let's say health is 1, power is 2, name is lizard, for example. If I were to go back in Unity's editor, we will see all of these things over here. So if I go back, hit the play button, you will notice health 1, power 2, name is lizard. And this way we can create multiple characters, as I said. So over here we can say player, I don't know, let's say archer is equal to new player. And over here he can have 20 for the health, 30 for the power. His name is Archer. There you go. So now we have different players. We can also do it over and over again. I'm not going to create multiple these. You get the point. You can practice that on your own. You will see multiple things here being printed in the console. So you will see the first one has a health 1, power 2, name is lizard. Next one, health 20, power 30, name Archer. So this is how things work with programming, actually with classes. And this is what I meant when I said that, and I'm throwing bars. This is what I meant when I said that. Enough. Anyways, this is what I meant when I said that you can create multiple objects from a single blueprint or class. You can also declare these variables over here at the top. So you can do something like this. You can say warrior over here. There you go. And over here it can be archer, like this, because they are now variables. They are same as if you were declaring an integer, because now when you declare them over here, you can use them across the whole class. We can have a function inside of this learning how to program where we can, use it to call warrior or archer and perform whatever we want to perform. And we are not bound by this over here as well. We can do something like public void info, and we can put all of these over here like this. And instead of having them in the constructor, now if I go back over here, this will not be printed out. If I go back just to show you that it will not be printed out, I don't want you to accuse me and everything. I don't want you to sue me for something I didn't say or say. You see, nothing is printed. But if I go now over here and if I say warrior.info, there you go, and archer.info, not comma, but .info, this is how we get the execution. This is how we call functions from objects. We say dot and the function name. If I hit the play button now, you will see the same info we had a moment ago. Now, of course, I'm not going to repeat now, of course. Anyways, over here is how you can have functions. Same, everything that we talked about so far now applies to these classes. Don't worry about this public. We will talk about that starting from the next video. We'll discuss public, we'll discuss private, what that is, how we can use it, and all of the good stuff. So do not worry about that at all. You will understand what this public means. And over here, we can also declare variables as private and public. We will talk about that. But over here is how we can declare functions inside of the class. And just imagine this is your game. You can have a function, because this is a player class, you can have a function attack, which means now the player can attack. And over here, of course, we need to say void because it doesn't return anything, debug log. And over here, I can say something like player, or we can even say name. So we can say the name of the player. So name plus is attacking. And we can call it over here, for example, for the warrior.attack. And if I were to go back inside of my editor, let's clear everything from the console, hit the play button. We will notice that at the end, lizard is attacking is being printed in the console. So this is how you can then have functionality within your game. This is where you create functions. This is where you declare the behavior of your class, of your player, and we are going to use all of this. We are going to use all of this inside of our games that we are creating. And I encourage you to practice a little bit more, creating more variables over here, more functions that you can call, and then creating over here objects from those classes. And this is, again, how you can create multiple of these, because there is no limit now. We have a blueprint over here. We have a recipe for our cake. There is no limit how many cakes we can create or we will create. So I encourage you to practice. Try to create multiple functions over here inside of the player class for attacking, for healing, and just use debug.log and call them over here. And that way you will see the pattern, how everything works. If something is not clear, please make sure that you ask in the comment below. I believe there is no complexity when it comes over here to classes. Just understand there are blueprints that you can use to create objects from, and that's all there is to it. And this is how the structure or how the workflow goes. Again, make sure that you practice. Something not clear, ask down below the video, and that's it about classes. Before we proceed to go in more depth with classes and programming and game development, I want to talk about this public little thing that you see over here that we have on our functions and on the constructor. So if I go back over here, we see that the attack is public, and over here inside of this function, we can call attack. And I am going to remove these because we have the warrior, and when we attack, we display this warrior or the name of the character or the player, and then is attacking. What will happen if I go over here and instead of public, I say private? And now going back over here, there you go. We see over here, player attack is inaccessible due to its protection level. Basically, these public and private keywords are called accessibility modifiers. We have some code in our game that's only going to be available within the class itself, and we are not going to allow it to go outside of that class, which is usually done for variables. Because if we try to access one of these variables, if I go over here and instead of calling attack, if I try to say warrior.health, you see it's not even printing it out. If I say info, it prints it out right away. If I call health like this, and we know that we have a health variable inside of our player, you see here is the health. If I try to access it, it will say it's inaccessible due to its protection level. If I were to go back over here and if I say public, then it will be accessible and this error from here will go away. Let me just try it over here. Public int health, there you go. And over here we can say, for example, is equal to 2, and now the error will go away. Now you're wondering, how was this inaccessible when we didn't have public, we didn't even have private? So it's only int health, but it's still inaccessible. Well, by default, if you don't declare a variable to be public, by default, the variable is going to be private. So essentially typing out int health or int health, it's the same as if you typed private int. It's exactly the same. You cannot access it. So this is really important to understand, because now when we start to talk about inheritance, we will go and see how we can extend these classes over here, how we can extend the player class to make it to suit it, for example, for a higher player. What do I mean by that? Let's imagine you have a character or multiple characters in your game. You have a base class. Every character can run, he can jump, he can attack. But what if when you power up with your character, then the next character can have some special attacks? So he can have special attack 1, maybe special attack 2, so on and so forth. You get the point. We create a base class for all players with similar or with the exact same behavior functionality, such as walking, attacking, jumping, picking up items, so on and so forth. But then for characters that are upgraded, the ones that are higher levels, we create another class. We extend the current class that we have and we add to it. We will see that. Don't worry about that. But that's why these accessory variables or parameters, how you get the point. I have blocked over here, but this is why they are important. So if we have some variables that we don't want them to be accessible in any other class except here, then we will make them private, such as our power, health, and name. So we want them only to be accessible over here within this same class. Now you might be wondering, okay, we have the health, which is only accessible over here. How can we get that health value if we want to check how or the current status of the player's health? Because if the player's health gets to 0, how can we get that value if we don't have access to it? Because currently, if I try to do something like this, if our warrior.health, I cannot even do that. If I say health is equal to 0 to test if the player has died, you see, no, it will not happen. Well, for that, we create getters and setters, and they go like this. For example, I'm going to use the health one. You can say public void set health, which takes int health as a parameter, and over here you're going to say this dot health is equal to health. There you go. This is how you set the value. So if you deal damage to the player, you can say, for example, warrior dot set health, and over here you can set the new value, which is equal to 20, and there you go. It's going to call this function, take this parameter, and it is going to set that parameter to this health. We talked about that, which is the private health of the class. How can we get the value? I'm going to give you just a few seconds for you, or better yet, pause the video and try to figure out how we can get it. You see how we can get it? And I'm going to continue now. Over here, we can say public int get health. So we can say get health like this. And over here, simply we're going to say return health. That's all there is to it. And if I go back over here now, we can say something like this, debug.log, and the health of the warrior is colon plus warrior get health. That's all there is to it. If I were to go back in Unity editor, we will notice now, let me just wait for it to finish and compile and all of the good stuff, hit the play button, you will notice over here what's being printed out, the health of the warrior is 20. So this is how we can access these variables even though they are private. Now there is another way how we can access them even though they are private, not using functions. So what I'm going to do is I'm going to comment these out. Maybe you want to write them down in your own script. But what I'm going to do over here is I'm going to create a private underscore health like this, and I will need to change it over here and over here. So I have the private health. What I'm going to do now is I'm going to create accessibility modifiers, which means I'm going to create a public int that I'm going to call health with capital H, open, close, you see, open, close, curly brackets. So over here, I'm going to say get, open, close, curly brackets, and I'm going to say return health, or actually underscore health. And over here, I'm going to say set, and I'm going to say underscore health is equal to value. And in most cases, we're probably going to use it like this. Sometimes we're going to use getters and setters, but now over here, I am going to change this from this dot health to simply health over here also health, and there you go. So it's the exact same thing. What I can do now, I can say warrior.health is equal to 20, and I can say again debug.log, and over here I can say the health is colon plus warrior.health. There you go. Now, if you're confused by one thing that we typed over here, we use set and we set underscore health is equal to value. Value, this is, how can I explain? It's a parameter that goes simply over here when we pass, as we said over here, health is equal to 20, this value becomes 20. So the number that we say equal to, and that number is actually the value. And this is the signature how we can create these accessibility modifiers. So we create public int health, and then here we have a getter and a setter. As opposed to over here, we had the getter and a setter as a function. Over here, we have it as a variable. So now we simply say get, and here we return underscore health, which will give us the information, the value, the current amount or whatever of this variable. Set and health is equal to value. Basically, when we say it's equal to the number that we pass, that is equal to the value over here. So if I go back now inside of the editor, we will see the same result. If I hit the play button, we will notice over here the exact same result. Health is 20. And if you think that I staged this because I used health is equal to 22 times, I'm going to go over here and say health is 50, just for the sake of example. I don't want to be accused. I don't know what's my thing with being accused. Nobody accused me of anything, but I don't know, man. Anyways, over here, health is equal to 50. There you go. So we see how and what are public and private. And for most cases, what I do is I declare my functions either public or private. I rarely declare functions like, just void, for example, or something like that. I usually use either private or public in order to, declare my functions, even my variables. In most cases, I don't type just int health. I type private int to know that is a private one. And then I use either accessibility modifiers or I use getters and setters as we did over here. Now your assignment is to do the exact same thing for the power and the name, use them as accessibility modifiers and use them as functions over here and print it out in the console and see the result. But again, this is not hard. This is just using either private or public. You can go through the video again to see the examples. They are all over here. Again, as I said, your assignment, do that for the power and the name. That way you will practice and you will understand this much better. And something is not clear, just ask in the comment below. Now that we understand what are classes and how we can use them, we are going to introduce a new concept which is called inheritance. And in order to do that, I'm going to go back here in the editor and right click in the scripts folder. And I'm going to create a new C# script that I'm going to call warrior. And of course, double click that bad boy to open it over here. And for some reason, it was lightning fast. I am surprised. Anyways, so what I'm going to do is I'm going to remove all of this from here. So the start and the update function. And instead of over here, mount behavior, I'm going to type player. Not player, it's player. So what the hell did you do, teacher? I'm confused. I'm going to kill you. Just don't. Okay, so don't kill me. What is wrong over here? First things first, we have over here a problem. You see, there is no argument, blah, 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 blah. This column over here is informing us that the warrior class is inheriting from the player class. And the issue that you see here, the red line, is because over here in the player class, we need to implement a constructor, same as the one you have here, but with no argument. So we need to type over here public player like this, open close parentheses, open close curly brackets. If I go back over here, now that error goes away. So if you are first inheriting from one class, so you're inheriting another class, the inherited class, so the class that is being inherited, in this case player, needs to implement the public constructor like this. Even though if you don't use it, even though if you don't plan to put anything inside, you still need to implement it, or otherwise you will have issues over here. So what's the deal with the warrior over here? So what is the issue? Well, now that we have inherited the player class, the warrior class can access all the public variables and functions inside of the player class. So it can access the attack, well actually not, attack is private, but it can access the public info, and I can show you that. I can go over here and I can, instead of creating warrior as the player, what I can do now, I can remove this and I can say warrior is, or W is equal to new warrior. Simple as that. There you go. I have created it, and I can say w.info and call the info function. Over here I'm going to say warrior with lowercase, just so that it is, you know, better for the used for the example. So if I go back over here in the editor and in the console, if I hit the play button, you will notice that in the console, health is 0, power is 0, name is, we don't have the name. The reason for that is because we created a default, or the warrior creating the default constructor, which in terms, so this constructor, the default one, the no arguments one, in terms, it will call this bad boy over here, this constructor, which basically has nothing inside. That's why you saw over here 0 for health, 0 for power, and name is 0. Now, you were to think that if I go and implement these in the warrior, so if I create a warrior passing over here 3 for the health, 5 for the power, and warrior for the name, that it will work because it is inheriting the constructor, but actually no. In order for this to work, as you can see, we have an error. We need to go over here and create a constructor for public warrior, and over here it will take int health, and int power, and string name. So now this over here will work, but still when we use the print, it will not print anything because we're not changing the variables. If I hit the play button, you will notice here in the console health is 0, power is 0, name is empty. The reason for that is because if we go back in the player, remember in the previous video, we talked about private and public. Currently, only the health variable is public and we can access it. So if I do something like this, after I create my warrior, I can say warrior, so warrior.health is equal to 20, for example. Now, when I call info it will print that the health is equal to 20, but the power and the name will still stay empty, actually 0 and empty. But health is equal to 20, and this is what I am talking about. So this is called inheritance. And again, what is it? Notice over here in the warrior, I'm calling warrior.health to set the health, even though over here in the warrior, we didn't declare a health variable anywhere. You don't see the health variable over here inside of the script, but you see it over here in the player. Here it is. And since we have inherited, and that is done by using these colon and then the name of the class we want to inherit. Going back to the previous lecture where we talked about private and public, and only public variables and public functions can be accessed inside of this class or the child class. So the class that is inheriting is also called a child class, and the class that is being inherited, in this case the player class, is called the parent class. So the child class can only access public and private, only public methods and variables from the parent game, or actually class. If I change attack from private to public, we will be able to access it, but currently if I try to do that, so I'm going to remove this here, and if I say warrior.attack, we don't even get it. You see, in the autocomplete, we don't get it, and over here it's throwing the error, player attack is accessible due to its protection level, which means if I go back over here and I set it to be public, now this error over here is going to go away. And this is what I was talking about. You model the behavior of your objects within a single class, and then you extend it further on. Notice over here is attacking. The issue here, we see the empty string is attacking, is because if I go in the player, we are using name plus is attacking. Since we are not setting the name over here due to its protection level, then we cannot do anything. But if I do something like this, so over here we have power, and if I do the exact same thing over here for my power, so over here underscore power, and over here capital power, and there you go. So over here, power, there you go, power. Actually, I'm going to remove this from here and simply call the capital power. And over here, we also need to call capital power. Do the same exact thing for our health, or actually, for the string. And over here, I'm going to quickly copy it. And over here, it's a string and it's a name. There you go. Over here, we have the underscore name. And voila, we are done. So just change the name over here in the code where we used it previously. That's all there is to it. So now we have public accessors for all of our private variables, which means now over here, I can do something like this. When we create our constructor that has health, power, and name, I can say health with the capital H is equal to health with lowercase, meaning we're setting the health, which is this one over here. So the main health variable, this one over here, from the parent class to the one that is being passed as the parameter. We can do the same thing with the power. So capital P, and that is equal to lowercase p power, and uppercase N is equal to lowercase n for the name. And if I were to go over here now, since we passed the warrior for the name, we will see finally inside of our editor, if I close it or actually clear it, hit the play button, you will notice that the warrior is attacking. Even if I go and do this, if I say warrior.info, it will still work, and now it will display 3, 5, and warrior. So hit the play button again, we will notice health is 3, power is 5, name is warrior, and the warrior is attacking. This is called inheritance. So this is called inheritance. And this is, again, what I meant when I said I'm throwing bars at your Mars, and I'm just going to stop. Moving from where I left off, this is what I meant when I said that when you model a base class in your game, you have a character, and you're going to have multiple characters that you can choose from in your game, which means every single character can move, he can attack, he can jump, he can pick up items. You model all that common, or actually same behavior that all classes or all players have, and then you can create separate classes for specific types of your characters, such as the warrior, the archer, the wizard, the lizard, the swordsman, whatever. You get the point. And you model those classes to add some extra to add some extra functionality that the previous class doesn't have. As I said, for example, over here, the main players can only attack. What if the warrior can throw an axe? An archer cannot do that. A swordsman cannot do that. The wizard cannot do that. That is only specific to the warrior. So over here, you would create public void, throw axe. One thing that I want to mention and point out is that inheritance doesn't go backwards, it goes forwards, meaning the player cannot access the throw axe. It cannot access the throw axe function from if you just create a player class. So that cannot happen. But if you have the throw axe function over here inside of the player, then the warrior will be able to access it. That's the main philosophy over here. Now, also one thing that I want to point out is something called override. Now, what is that? Currently over here, we see the name plus is attacking. What if I don't want that? Let's say over here, I'm going to remove this and I'm simply going to say a generic one. Player is attacking with, I don't know, with fire. For example, this is the generic attack. If I were to go back now and hit the play button, we will notice that in the console, player is attacking with fire. Now that is the generic attack of every player. What if I do not want that? And I'm going to remove the info. I want the attack of the warrior to be attack with an axe. So if we say something like public void attack like this, there you go. If I hover over, you see warrior attack hides inherited member from player attack. But basically what we can do is we can say public override, so override void, and now we can override the attack function. See, warrior attack cannot override inherited member player attack because it's not marked in virtual abstract or override. So let me just go over here, public virtual void, and now we will be able to inherit or actually override it. What is override? Again, going back over here, the function that you want to override, meaning change its signature, it needs to go public virtual void. So that's how you add it. Actually, it can be a void or a function that returns a value that depends on your needs. But you need to have this keyword virtual, which means now over here, I can have my own attack function inside of the warrior child class. And instead of having here player is attacking with fire, I can have something like warrior. So warrior is attacking with axe like this. And if I were to go inside of Unity, we will not see player is attacking with fire. You see, if I hit the play button, you will notice warrior is attacking with axe. With an axe, actually, but I don't care about grammar, do you? I guess so, yeah. Anyways, this is how we can change the signature of the main function inside of the parent class. But in a lot of the cases, you will not use this. I'm just showing you as an example. Maybe you will have a good use of it, but I'm developing games for 6-7 years. I didn't use some of these things. So I'm just throwing this out there because a lot of people think that you need to implement every single aspect of object-oriented programming, every single aspect of inheritance and polymorphism and whatnot, and so on and so forth. You don't have to do that. You're not obligated. You will develop your own coding style during time while you're creating your games. I'm not saying that it should be something out of this world, because when you start to work in a company, you need to follow their own coding style, but for yourself, you will have your own coding style. That is totally normal. And I'm telling you again this because a lot of people are, oh, this is how you need to follow it, and no, you don't. No, you don't. So yeah, this is how we can override an existing function. Why is this inheritance important at all? Why are we talking about this? Why? Well, because if I go back over here, you see that every class that we create in Unity has this mono behavior. This means that every class that we create in Unity by default, it will inherit from mono behavior. That's why you see the start function. Here it is, private void start. That's why you see the update function, which is this one over here. So update, when you create your functions, these are all inherited from mono behavior, or classes along the inheritance hierarchy, because multiple classes or you can inherit from multiple classes. A class can inherit from a class, it can then inherit from a class, it can then inherit from a class, so on and so forth. So you can have over here a player class, then a warrior extends the player, then you can have some power up warrior extending the warrior, so on and so forth. That can go forever. So the start and update are functions that are inherited from mono behavior or some classes in the hierarchy. And now I can also introduce you to the awake function and talk about the execution order. So when you first run your game, and I mentioned this in previous videos, update, or actually awake, is the first function that is called when your game starts. After that, you have on enable. This is the second one that is called, second function called, and start is the third function called when your game, so third function called. Of course, in a lot of cases, you will only use awake and start. What I love to do is only use awake to initialize the variables that I need to initialize, and then in start, I'm using functions that require those variables that are going to be initialized. So awake is the first function in every script that is being called when your game runs. So just make sure that you remember that. And even if you don't worry, we will, when we create our games, I will show you a lot of examples, so you will definitely understand. Now, this is everything I have to say about inheritance. I encourage you to practice a little bit more, create more variables over here, try to access them from Warrior, try to use private and public and see what is going to happen. Try to use a little bit more of these public virtual voids. Like, model your base class for a player. So the generic functionality of every player in your game, model it in a player class and extend it with one class that will inherit all of those and implement a few of its own features, something similar as I did over here. That will be your assignment, and you can submit it to me via the comments down below. So just make sure that you do that. If something is not clear, just make sure you also ask in the comment below. But I believe everything is covered when it comes to inheritance, because it's not that hard. You just, use the colon, inherit the class name, then you can access all public functions and variables that are inside of the parent class or the class that is being inherited. Again, make sure that you practice all of that and ask below if something is not clear and submit the assignments down below. Now that we understand the concept of classes and objects, we can dive into explanations such as over here. What is this? What is this learning how to program that I have created? This is called a game object, and any game object or anything that you have in your scene is a game object, and that game object can have components attached on it. For example, I can right click over here and I can click here, create empty, and right away you see it has created an empty game object. An empty game object meaning it has no components. By default, so that you don't get confused, by default, every game object has this transform component attached on it. But when you create a new one, as you just saw, it only has the transform and no other components attached on it. For our learning how to program, it only has the transform and the learning how to program script. In the beginning, we saw an example of a few components such as the rigid body, we mentioned animations and so on and so forth. These are all components that you can attach on every game object in your scene. But of course, you will attach the appropriate components that you need for that particular thing that you want to achieve. Now over here inside of our add component, I can click over here and I can filter for example, rigid body 2D. If we're working on a 2D game, we will use rigid body 2D. Rigid body is a component that adds physics to your game object, which means, and we saw that example, if I hit the play button, our little fluffy monster over here is going to, and for some reason it is not falling. Yeah, actually it is falling down, but we don't see that because of the camera. So selecting the main character, actually our learning how to program is falling down. For some reason I thought that I have attached it on this little character monster, but anyways, it's not important. What I want to show you is, for example, I can also attach a box collider. I can also attach an audio source. I can also attach a animator. Now, what can we do with all of these, and why am I attaching these components? Well, simply because we can go back over here and I can declare all of these. I can say, for example, private rigid body 2D, and I can call it my body. I can also declare a private box collider 2D, and I can call it my collider. I can also create here private audio source, and I can call it music or audio source like this. I can also get the private animator, not animation, animator, and I can call him anim. What I can do now is I can get a reference to these components in my code. I can say my body is equal to get component, and I can pass over here a rigid body to the component that I want to get. There you go. So this will get me a reference, and a reference is a reference to that object. Same as with our classes. When you create an object, and let's go over here to annotate the screen. So imagine this is the player class over here. So we can say player like this. So player, blah, blah. Now we can create multiple players, as I already mentioned. So this is one player, this is the second, this is the third, this is the fourth, for example. So over here and over here and over here. Now all four of these, they are objects. And when you create, for example, player P, so let's say P1, and you say it's equal to new, and then you create a new player, you know how it goes. Then you have one reference. The P1 is basically the reference to the player class. What do I mean by that? Let's quickly do that over here. So over here, I can say player. So player P is equal to new player. There you go. So this P variable is a reference. It is referencing a player class, which has its own functions, own variables, and so on and so forth. But this is a reference referencing that in memory. So you can imagine this is a computer, this is a computer memory, and here is the player P. So this P is referencing that part in the memory. And this is what we are doing over here. So now we are instead of creating new rigid body, we're simply saying get component. This is the same because we don't have to create a new one. We already have one attached on it. So here it is. We have one attached on our learning how to program. So it is attached. We have an object. So this object is created. We don't have to say it's equal to new rigid body 2D in order to create it. We simply use get component, and there you go. So now we can perform anything that this rigid body has. We can say add force, and over here we can pass the force that we want to add, so on and so forth. We can do a lot of the things. And of course here we need to provide multiple parameters, but that's not important at the moment. What I want to show you is how we can access all of its public variables and all of its public functions. Same thing with the audio source. So I can say audio source, and it's lowercase a, and I can say it's equal to get component audio source like this. And now I can call my audio source, and I can say dot play, and it will start to play the audio sound that I have attached on it. Don't worry, that will come, but I'm just showing you how this object-oriented programming works back and forth, because now that we have a reference, we have created a variable out of that class, or basically the class was already, the object was already created, we just simply got a reference to it. Now we can access all of its public variables and functions and manipulate with it so that we can perform certain actions in our game. Same as here, if I want to get the reference to this transform, I can say it like this. I can say transform because we can get it right away, or we can also create here, I can say private transform my trans, so my transform, there you go, and I can simply say my transform is equal to, now we can say here get component, and we can get the transform component. This will also work, or we can simply say over here transform, because this is the inherited component. You see here the transform attached to the game object. Because we are inheriting mono behavior, we have access from it, we have access to the transform, and we can access it right away. And from here I can say my transform dot, and I can say dot position, and now I can change the position, so new vector 3, and now I can change the position to, for example, 10, 20, 30. For example, now for that I will have to deactivate the rigid body component, or simply set over here to kinematic so that gravity doesn't affect it, just so that I can show you that this works. Because if you pay attention, when I select the learning how to program, and if you pay attention, the position is at 0.7, minus 1.2, or basically I can set it 0, 0, 0, that will be easier. But when I hit the play button now, it will get the rigid body component, and notice where its position is now, 10, 20, 30, which is exact position that we set over here, 10, 20, 30. Now, I am not going to go into detail for every one of these components, such as the animator. We can simply say get component animator, and this is how you get the component. You type get component, and then in these greater than and less than sign, or between or in between them, you type the name of the component that you want to get. In our case, or the type of the component, not the name, but the type, which is basically the name. So we want to get the animator. As I said, I'm not going to go into high detail from every single one of these components, because we will start creating games, and then we are going to go and dive deeper and deeper and deeper into every single one of these components. And again, we will revisit all of this, what is happening, why we're using it, how we're using it, and I'm going to connect the dots. Okay, this is that object, and this is how we use it, and this is that lecture that we did about, you know, data encapsulation, and or basically public and private variables and so on and so forth, and you get the point. So this is how we can get components, and I just wanted to show you this before we start creating our games, so that you know or have a clear picture how Unity works. Everything that we covered so far is what you need to know as a beginner to start working with Unity. And of course, when we start to create our games, we're going to take off from there. If something is not clear, just make sure that you ask in the comment below. What is cracking, game dev gangsters? So now that we went through the basics of Unity, we downloaded Unity, we saw some basics of programming, let us create our first game where we are going to implement everything what we learned and some extra things, and we're going to see it in action. So let me first preview the game that we're going to create. It's a game I call Monster Chase, and it's a remake of my old tutorial that I did probably 6 years ago, but in more depth, in a lot more depth. So basically what I have over here is my main menu, and I went from it, but here I have my main menu, and I can select one of the two characters, left one or the right one. So if I select, for example, the right one, there you go. Now I have a character. I go over here, I can jump. You see, that is the point of the game, and we jump over monsters. So yeah, but basically no monsters currently in the game. Just kidding, but they're coming from the left and right side, and you saw how one of the monsters just tried to kill me, and I was so smart, and you know, but I'm not so, oh, you can, okay, it's intense, you can see that. And when they kill me, bam, I die, nothing happens. I can restart the game, play it again. I can go back here in the home, select the other character, and voila, there you go. So that is the point of the game. Even though it looks like a simple game, we're going to cover a lot of cool things, a lot of cool features. We're going to implement everything what we learned, everything we talked about, and yada, yada, yada. I'm going to stop talking. Let us get into the game and create it. Let us now put everything that we learned in previous videos into use by creating an MMO online RPG game, and I'm just kidding. We're going to create a simple 2D game, and yes, we are going to implement a lot of the things that we learned in the previous videos, but don't worry, I'm going to explain in detail what is going on. I'm going to go and reference back things, so everything will be crystal clear. For starters, create a normal, or actually a new project, not a normal, but a new project. Every project is normal. And it's going to be a 2D project, and what I'm going to do is change the name of the scene. So here in the scenes folder, change the sample scene to gameplay, because this is where the gameplay is going to happen. Why should I not name it gameplay? Next, what I'm going to do is in the game mode over here, I'm going to click on this tab where it says free aspect, and I'm going to change that to full HD, because our game is going to be full HD. Every game is a full HD. Everybody loves full HD. So the next thing is over here in the assets folder, we have the fonts and the sprites. We are going to import these because we cannot work with an empty project, and they will be provided. Link will be in the description below, so you can download these assets to follow along with the course. And you can also download the complete project for your own reference to compare with my code and inspect it and practice and so on and so forth. So simply select both of these files and drag them over here, and voila, there you go. That's everything we need to do. Actually, I dragged them in the scenes folder because I am stupid, so simply going to put them in the assets folder over here, so they are in my top or main project. So assets, and then we have all folders, so don't put them in the scenes folder like I did. Anyways, moving forward, what we need to do is select, and by the way, how Unity project tab works is like any other file manager on your computer. You can drag this asset, or actually you can drag this file or folder in another folder, and subgroup folders. You can, for example, go here and just take this, the enemy's image, and you can put it in another folder. It works like that, so it's basic thing. Next, what I'm going to introduce to you is something called a sprite sheet. Now, if I were to select the player's image over here, if I double click it, this is what we have. You see, this is the image of the players. And as you can see, it's an image where we basically have two players on a single image. And how can we use this? Because if I take the image and I put it over here in the game, this is what we see in the game. This is the game window, and if I move it, you see the blue thing now, this is the game window. And if we try to move them like this, our players would go like this. We players, we. This is not a game that anyone wants to play. So how can we fix this? First, I'm going to remove this from the hierarchy. Next, I'm going to select the player image, and let me just annotate this. So selecting the image, and over here now into the inspector tab, we have something called a sprite mode. Now for the sprite mode, which is a drop down list over here, we need to click on it, and we are going to change it from single to multiple. So click on it and change it to multiple, and then hit the apply button over here at the bottom right corner in the inspector tab. Now, when we have done that, we are going to click here on the sprite editor button. So click on it, and here it is. This is our sprite sheet. And now we need to separate every individual image on its own. And in order to do that, there are two ways. The first one is the hard one. So I'm going to show you that one. And how we can do it is simply by dragging with our mouse. So left click and draw a rectangle around our sprite, and there you go. So over here, I'm going to position it something like this so that we draw it nicely. There you go, yada, yada, yada. But this can get tedious, as you already see, because we have 1, 2, 3, 4, 5, 6, 7, 8 images multiplied by 2, 16 images. I'm very good in math. So we have 16 images in this sprite sheet alone. Imagine you having a sprite sheet where you have 100 icons, 200 icons, and all of the good stuff. That would be tedious to do. So there must be a better way, teacher. Yes, there is a better way. Now, a better way is to actually select this slice over here button that we have. So actually click on it, and then the type will be set to automatic. So automatic, and then we click on slice, and there you go. Now Unity is pretty good at doing its job. So in 99.99% of the times, it will slice your images correctly. Now, before you start to panic, teacher, but you say it's gonna work. Yes, I said 99% of the times it will work, but sometimes you will have to manually change these. So what you can do, for example, you can go over here, you can change them something like this, you can move them over here. And if you don't like how, the way how they are sliced, or sometimes, especially if you have multiple letters, Unity will slice in between letters. So it will not slice the complete title on its own, it will slice the letters on their own. So if you have a title from 5 characters, for example, it will not slice it into a one slice containing all 5 letters. It will slice it letter by letter. So sometimes you need to correct things, but this is totally fine for me. And in order for this to, work, we need to hit this apply button at the top bottom corner. So click on the apply button, and there you go. Now we have every individual image on its own. So what I can do now is go in the scenes, and I can drag the player one image of the player, and I can go now into the game tab, and this is now what we see. We have a single player as opposed, a gazillion players that we had in the previous attempt. Also, what I'm going to do is, or show you one more thing, is that you can see that we have names for these individual sprite pieces. So we have player _1, _0, 1, 2, 3, yada, yada, yada. You see all of that. I don't have to, recite it to you. So I'm going to select the players, and again over here we're going to set to sprite editor, and what you can do is you can select every individual. So you can click on every individual image over here, and then here at the bottom right corner you have the name. You see here we have players _0 and so on and so forth. You get the point. So you can change this name, but if you change the name, so you can say, for example, player 1-1, and for this one it can be, player 2-2 and all of the good stuff. This can be player 3-3 -3, so on and so forth. When you change all of that, what you can do is hit apply. So now those changes will be applied, and there you go. You see we have player 1-1, 2-2, yada yada yada. You see all of the good stuff. Now for you, you can rename all of this on your own. So you can rename all the players, or basically frames of the players or image parts. So this is going to be player 1, this is going to be player 2. We will need that later on because we're going to create player 1 separately and player 2 separately. So again, just briefly, when you select the sprite sheet, click over here and change it from single to multiple. And this single doesn't mean that the sprite sheet is single, it cannot find the girlfriend or whatever. It means it's a single image. So don't get those two confused. Anyways, this is how we can work with sprite sheets. And what is the benefit? Before I go, what is the benefit of a sprite sheet? Well, the benefit is this will save a draw time or draw calls. It will save draw calls, which will make your game more optimized, no matter if it's desktop, console, or mobile. And especially on mobile, this is very useful because it will save you draw calls. It will optimize your game even more. So it's better to have this single image containing all of these players than to have these players separated from each other as an individual image. Of course, there will be times where you need to separate them. This is not like a general rule that you always need to follow, but often you will put all your images into a single sprite sheet, and this is how you can work with sprite sheets in Unity. The next step is to create the animations for the player. And for that, I'm going to take the player 1, and I renamed all of this as you should have done in the previous video. I mean, it's not mandatory, but you can do it. And I'm going to take player 1, I'm going to put him over here. This is our player 1. Look at the chill dude, look at the chill face and all the good stuff. I'm going to change the name here in the hierarchy from player 1-1 to simply player. That's all there is to it. Or maybe player 1 because we have player 2, the other player. So what I'm going to do now is, since we have over here our player, I'm going to go into assets and right click and create a new folder. I'm going to call it, and for some reason didn't create it, so going back, call it animations. Did I create a new folder somewhere here by accident? I'm not sure. No, I didn't. Anyways, in the animations folder, I'm going to right click and create another folder that I'm going to call player or player animations. And inside of it, we're going to create another folder, and I am going to call this one player 1 animations. And inside of this folder, we're going to create another folder, and until the end of this video, we're only going to create folders, and I'm just kidding. So I'm going to right click and create, and we want to create this animator controller. You see this? Animator controller. And I'm going to call this bad boy player 1 animator, okay? Player 1 animator. Now, what I'm going to do is select the player here in the hierarchy, and I am going to click here on add component. And we're not going to attach the player 1 animator component on him. Instead, here in the search box, we are going to filter for animator. Here it is, animator, and I'm going to click on it. So you can see over here now that we have this component that is called animator. It has a property over here called controller, which currently has none, meaning empty field. This player 1 animator is going to be dragged and dropped over there because he's the animator controller that allows us to actually control the animations that we are going to create for our player. So what we need to do is drag and drop the animator 1 or player 1 animator. There you go. Or we can simply call it player 1 controller because it's an animator controller and I'm calling it controller. So we dragged and dropped player 1 controller on him. What is the next step? The next step is to create the animations. And for that, we're going to select the player, go into the animation tab. So not the animator, but the animation tab. If you don't have them, it's under window of animation. Here is the animation and animator. So in the animation tab, while we have the player selected, over here you see to begin animating player 1, create an animation clip. So simply click here to create and selecting player 1 animations. Over here, before we press save, I am going to change the name to idle, and I'm going to press save. So now we have the idle animation on the player. Now the idle animation doesn't have any animation parts, any animation frames, and we can see that because this timeline over here is empty. And if you worked in any timeline on any video editing software or whatever, it's basically the same. It's a timeline where you drag and drop frames. So before I try, or I not try, but I actually do. So before I drag the frames here, I'm going to click here where it says idle. So now when you are inside of the animation tab, and you see over here, we have this where it says below preview, we have the idle. So what we are going to do now is click on this idle, which is basically the name of the animation that we are currently in. But when you click on it, you will see here create new clip, because we already have one clip. We don't have that create button that we had a moment ago over here. So I'm going to click here create new clip, and I am going to create the walk animation as well. So I'm going to say here walk, and there you go. That's all there is to it. So now we have the idle, and now we have the walk animation, which means now we can go back into the assets and sprites. And for the idle animation, I'm going to drag and drop player 1-1. So this is for the idle animation. So drag player 1-1. When you want to switch animations, again, clicking over here where it says idle, and by the way, now we see that we have frames. Now our timeline over here is not empty anymore. We have these frames, which is basically the sprite from the player. And if I click the drop-down list, you see this is the animation right there. So now again, where it says idle, click there and select walk. And for the walk, I am going to choose, so I'm not going to choose the player 1-8 because that is the player's jump animation. So this one over here, we don't want that. I don't want the jump animation. So I want all frames from player -7 or 1-7 up to player 1-1. And I'm going to drag all those frames over here. And voila, there you go. These are the frames that we see for the animation. Here they are, 1 frame, 2 frame, 3 frame, you get the point. So these are the frames. And we can preview this as well. What I can do is I can put my animation window over here, and I can go and select the player, and now I have the walk animation. I can click here the play button and it will preview it, you see, and he is, you know, running like crazy. You know, look at that, like a Speedy Gonzalez. Look at that. I don't know what that sound was, but what we can do over here for this bad boy is we can click on this or these 3 dots. So while he is inside of the animation, these 3 dots over here, we can click on them, and we can go over here from set sample rate from 60 frames to 24 frames. This will make him a little bit slower. As you can see, he is a little bit slower, but still he is too fast. Of course, we will see later on in our game, don't worry about that, how we can change this. But for now, we are satisfied with this result. And for the idle animation, it's simple. I can just go over here, select the idle. It doesn't play anything, basically just the basic animation. Here it is, you know, nothing happens on the screen. It's just 1 frame, so nothing will happen, nothing will change in terms of shape of the player and so on and so forth. You get the point. Now, this is for the animation of the player inside of the animator controller. You see, we have these 2 animations. So we have the idle, we have the walk animation. And later on, we will also see how we can use transitions inside of code. And in order to do that, actually, you see here we have this inside, and this is again in the animator tab, not the animation. In the animation, we create the animations. In the animator tab, we control the animations. Now, in order for us to go from idle to walk, we need to right click on the idle animation, and we need to click this make transition. And now you will have this, actually for some reason I don't see it, but you can see a little small line over here. I can point my mouse on the walk animation, I can left click on it, and there you go, automatically this line is now attached on him. And you will notice the arrow, it is pointing downwards, which means we are going from idle to walk animation. Now we need to do the same thing. We need to go from walk to idle animation. In order to do that, right click on the walk, click here, make transition, and click on the idle, and there you go. So you see these animations now are, pointing to each other, which means we can go from idle to walk and back from walk to idle. Now, in order for this to happen, we need to do this in the code, but before that, we need to set parameters or conditions. So conditions, so now these lines that you see, this white one and this white one, they are transitions. And in order for transitions to happen, some condition needs to be met. And I can click on one of these transitions and you will see over here that the conditions are empty. You see, list is empty. We don't have any conditions to go from one animation to another. So how can we do that? It's simple. We go here where it says parameters. Now, maybe for you, this tab layers will be, open. So click on the parameters tab. So simply click on it. And over here on this plus sign, you can click it and it will open this drop down list. Over here, you see a float, integer, boolean, a trigger. Now, these are familiar things. So we are going to select a boolean and I'm going to call the bool walk. So you can name it. You see over here, we can give it a name and I'm going to call it walk. And what I'm going to do is I'm going to select this transition. So from idle to walk. And now for the conditions over here, click on the plus button. You see this plus button over here. I'm going to click on that and automatically we have the walk condition. If we have more conditions over here, if I add another float or an integer or whatnot, it would be visible over here when we click on the drop down list for this condition. So the condition is when walk has a value of true, as you can see over here, when walk has a value of true, we're going to go from idle to walk animation. On the opposite side, clicking the transition from walk to idle, clicking on the plus button to add a condition, when walk has a value of false, then we are going to go back from walk to idle animation. Now, for now, do not worry about this. We will see in the code later on when we start coding the player to move him left and right and so on and so forth. We will see how we can use this in the code. But just know that we set up conditions in order for these transitions to be performed or to actually execute. That's all there is to it. So going back over here to the player. Before we wrap this up, I'm also going to select the player and I'm going to go over here and attach a component. So first things first, I'm going to attach a box collider 2D component on the player. Now, one thing that you will notice is that the collider is circling the player. I don't want the collider to fill up this empty space. That means when a monster touches the player outside of his body, so when he touches this empty space, in the code we will detect that the monster has touched the player. But because we slice the player in this way because of his hair, he is sliced in that way that the collider thinks that this is also a body part. So what we can do is select the player, go over here for the box collider 2D and click on this edit collider button. You see we have this edit collider, we have these three dots button, click on that. And now we can, select these dots over here and I can move the collider up to here and I can move this collider up to here. Maybe if you want, you can also set the collider somewhere around here on his feet. And I don't know, for the hair, it can stay as is because the monsters can only touch the player on his body. And I'm going to hit again the edit collider button so that, we don't edit it anymore. Now, the last step for the player is click on the edit and I'm going to attach a rigid body 2D. Now, don't get confused and attach a rigid body or a box collider 2D. Attach a rigid body 2D or a box collider 2D. Don't attach just box collider or rigid body because rigid body is for 3D, rigid body 2D is for 2D. So now we are basically done. And before I, wrap it up, one thing that I want to show that is pretty useful. Let's say, for example, I have duplicated the player. So this is the copy of the player game object. Control D or Command D on Mac, Control D on Windows to duplicate game objects. And there you go. So I have a player. If I select him, he has an animator controller or actually an animator component with the controller, box collider, rigid body. If I were to delete player 1 in parentheses 1, so player 1 clone, that's how I'm going to call it. If I were to delete player 1 clone, so control or command delete, he is gone. Now I need him back. Well, in order to do that, again, what I need to do is create the player and go through all the things that we did just now, attach an animator controller on him, actually a component, then the controller, then the box collider, then the rigid body, and all of that process, as you can hear, not see, it's tedious. So there must be a better way, teacher. Well, of course, the wise master teacher to the rescue. What we can do is we can create prefabs out of our game objects. So right click here in the assets and go to create and folder, and I'm going to call this bad boy prefabs. A prefab is basically a reusable game object. So I'm going to drag and drop player 1 over here, and voila, that's all there is to it. We created a prefab. If you take a look at the player over here, he is blue, his icon is now blue, and we created a prefab out of him. Over here also in the hierarchy, he's a prefab. His icon is blue. That means I can take him now and delete him from the game, and before you start to panic, teacher, we need to go through it again. No, we don't, because now I can simply drag the player over here in the hierarchy, and there you go. He has all of his components, the animator, the box collider, the rigid body, and all of those components he has on him. So basically we don't have to do anything more than what we did so far. One assignment that I have for you is don't forget player 2, because we have player 1 and we have player 2. Do the exact same things that we did for player 1, do them for player 2. Try to pause the video and redo the things on your own, because that's the best way to learn. That is how you will memorize all of the things that we're doing faster and more efficiently. Of course, if you are lost, just rewind the video, rewatch it, do the same steps for player 2, but instead of dragging player 1 animations, you're going to drag player 2 animations. Just remember, don't drag the last animation, and for some reason over here I have this last, I didn't rename it correctly, but anyways, don't drag this animation. We don't want this one to be for the player 2. We don't want the jump. So all of these are the walk animations, and this one is the idle animation. So make sure that you also do everything what we did for player 1, do it for player 2, and save him as a prefab as well. So now we have the player and he has all of his components, and if I were to hit the play button, we will notice one thing. The player is simply going to go down, whee, there's the player, whee, and the player is having a good time, but we are not, because we cannot play the game without the player. So in order to fix this, what we need to do is go over here, and inside of our sprites folder, we have our background, we have the ground, and we have the moon. Before we start to add everything inside of the scene, I'm going to right click over here and create an empty game object. And I'm going to call this bad boy game BG. And of course, set the position to 0, 0, 0. You can do this. So select X, then Y, then Z, and set them to 0, 0, 0. You can also right click on the transform and click reset, and it will reset to default values, which are the values that you see over here. So inside of this bad boy, I'm going to right click and create another empty game object that I am going to call background. So background holder. This is going to hold the background image. Now here is the background image. I'm going to simply drag it, there it is, and I'm going to put it here under the background holder. One thing to notice right away, the player is not visible. The player is in the scene, so we can see, actually we cannot. If I turn off the background, we can see the player, but like this, we cannot. You see the player is over here. Here is the player, but we don't see him. What is the issue? Well, you will notice that all game objects that have a sprite renderer component on it, such as the player, and every game object that renders an image on the screen has a sprite renderer component. So you will notice in the sprite render, this additional settings, it says sorting layer and order in layer. So what is a sorting layer? What is order in layer? You see, sorting layer is the default. So we only have the default sorting layer. Order in layer is basically the order by which game objects or sprites are drawn within this layer. So in the default layer, we have the player on order in layer 0. We have the background on order in layer 0. If I were to go here and select the player and set the order in layer 1, automatically we see the player right here in front of the background image being rendered. So the order in layer is basically the order by which sprites are rendered within that same layer, so within the default layer. But sorting layers on their own, we can create a new sorting layer. So you can click here, add sorting layer, and then I can click on the plus button and I can create a new layer for background. So I can say this background, for example, and I can select the background and I can put it on the background layer. Automatically, again, the player is not visible. Why? Well, because within these sorting layers, if I click here, add sorting layers, you will notice that they are, put in an order. The first layer is the default one, and we cannot change that. The second layer is the background layer. The layer that has a higher order, in this case the background, it will be rendered on top of layers that are behind it. So currently the layers default are behind the background, which means everything that's on the default layer will be rendered behind the background layer. No matter if we have order in layer set to 1 in the default, we said that that's the order within the layer itself. So that is the order within the layer itself, but for a higher sorting layer, that doesn't count, because we would need to set the player on the background layer and then set the order in layer to 1 for him to be able to be rendered on top of the background. But what we can do also is we can go over here and we can click on the plus button and we can add a player sorting layer. Player layer. Now, what we can do is select the player and go over here from the default, change him to player, and automatically you will notice that the player is being rendered in front of the background. Now, because the player is a prefab, one thing that I want to mention is when you make a change on a prefab, in the hierarchy, this is really important to remember. So in the hierarchy, when you make a change to a prefab, you need to click here where it says overrides, and when you click on that, over here you will see apply all. So apply all changes. This is only if you want those changes to be applied to the original prefab over here that's inside of the prefabs folder. Because now that we have created a prefab, the original prefab is the one that is here in the folder. If you want to make a change to it while he is in the hierarchy and you want those changes to apply to the original prefab, because if I select the player prefab here, you will notice that he is still on the default layer. He is not on the player layer. So if you want those changes to apply, click here, overrides, hit apply all. So now this player over here will also be on sorting or sorting layer player. Now select the player 2 as well and go over here and set him on the player layer, but you can also use the order in layer to achieve this as well. So you can use the order in layer to achieve it. You can put everything on the default background, and the sprites that have a higher order in layer will be rendered on top of the sprites that have a lower order in layer. It's simple as that. Now, since this video turned into talk about sorting layers and order in layer, I'm going to, cut it out here. And in the next video, we're going to continue to put our backgrounds. So you'll see how that goes as well. But again, I encourage you to practice. So please make sure that you practice, and that way you will see the effects of sorting layers and order in layers the best way possible. Now that we know how we can sort the order of the renders, let us create our background. So over here we have our background, the default one, the one that we have imported, and I'm going to name it background 1. I'm going to duplicate it, and this is going to be background 2. Now what I'm going to do for the background 2 is drag it, and I want to align it over here exactly to be in the line with this one. So they are going to be like connected. And for that, I am going to move this over here, and voila, there you go. But this can sometimes be imprecise because we don't know exactly how we can, put them together on each other. But there is always a better way and a solution. So what you can do is, while you select the background that you want to move, so in our case, background 2, I can zoom in over here and I can hold the V key, not the W, but the V key. And as you can see, let me just go over here, holding the V key, and when I move my mouse to the corners, it will move. You see, it is moving these arrows in those corners as well, meaning I can take that part of the background and I can snap it to another part over here, in our case to the other background. So I'm going to take or hold the V key. It's important to hold it, so press it and hold it. And now I'm going to select this or click it with my mouse and just move it over here, and voila, there you go, it has snapped. So it has snapped exactly on that background, and now I know 100% they are put together on each other. I'm going to duplicate these two and move them like this. So duplicate and move them like this. This one is going to be background 3. This one is going to be background 4. Now this is not mandatory for you to rename them. I'm just renaming them, you know, just so, but it's not mandatory. It will not make you a better game developer. You will not follow the course better, and so on and so forth. So now selecting these two, so I have selected these two backgrounds, going over here, holding the V key, snapping it. There you go. So again, duplicating them, moving them over here, zooming in a little bit, holding the V key and snapping them. There you go. So this one is going to be background 5 and background 6, and not 7 but 6. And last but not least, what I'm going to do is I am going to duplicate all of these and I'm going to move them down like this over here, and then I am going to snap them, and there you go. Voila. Actually, I believe I can remove the down ones. I don't think I need them. Yeah, I don't need the down ones. So this is basically what we need in order to form our background. So 7 over here, 8 over here, and 9. And there you go. This is our background. Of course, we're not finished. So what I'm going to do is duplicate this and Control D and move it over here. And let me just connect all of this. There you go. Let me just see one thing. I'm going to take the camera and move it over here. So this is at 47. I believe I can take 2 more. So this one, and I can duplicate them. And actually it needs to be this one. It needs to be 3 of these. But you can see it can get sometimes tedious depending on, but I'm going to do it like this. Duplicate them and move them over here, and I'm going to snap them. There you go. Duplicate one more and put it over here and snap it. Voila, there you go. So these are my backgrounds. So again, from here to here, I'm going to duplicate them, move them over here, snap them one more time. Duplicate this one, actually this one and this one, duplicate it. Did I duplicate it? Yes, I did. There you go. They are duplicated. Move them over here and snap them, and duplicating one more and snapping it over here. See, this is not hard at all. Of course, you can, as I said, rename these, but you don't have to do it. It's not mandatory. Now, these are the backgrounds. The next, what we are going to do is go back the next thing that we're going to do in sprites, and I'm going to take the moon and I'm going to put it over here in my scene. Of course, we don't see it. I'm going to put it here in the game BG game object, but we don't see it because it's on the sorting layer default. So I'm going to put it on the background. And because we want this moon to always be rendered on top of the backgrounds, I'm going to set his order in layer to be 1. Because the backgrounds are on order in layer 2, or actually, excuse me, 0. That's why the moon is going to be on order in layer 1. And I'm going to position him somewhere around here. So here and here. This is where the moon is going to be. Next, I'm going to right click on the game BG, and I'm going to create an empty, and I'm going to call this one ground holder, because we are going to hold grounds. And we are going to select or take the ground and put it over here. Voila, there you go. We don't see it because, again, set it on background layer, and of course set it over here on order in layer 1, because we always want it to be rendered on top of the background. And I'm going to move it down here. So for example, at negative, minus 5.78, for example, I believe this is totally fine. Now, I'm going to duplicate it and again do the same thing. So over here and voila, and duplicate this one and move it over here and voila, there you go. So we have the ground. I can hit the play button and everything is going to be fine, and no, it's not. The player still is falling down, he is having fun, and all of the good stuff, but we are not. So what we need to do with the ground is we forgot the most important ingredient, which is selecting all the 3 grounds that we created and attaching a box collider 2D on them. So make sure that you attach a box collider, as you can see. So now you see the green thing circling them or surrounding them. If I hit the play button now, you will notice that the player now is finally standing on the ground. So there you go. Now, I encourage you, I'm going to finish this, wrap it up. I encourage you to pause the video and sort the grounds on your own till one end and the other end. So pause the video, try to do it on your own. That's the best way to learn. Hear my advice. I'm here to tell you, do things the right way. So pause the video and try to do it, but I'm going to continue and, sort them right now. So from here, there you go. Now I'm going to duplicate these bad boys and I am going to zoom in and I am going to set them over here. So I'm going to duplicate all of them now and move them over here. And come on, what did I do? Let me see if I selected all of them. Yes, I did. So going over here. No, this is not what I want to do. You see, sometimes you need to zoom in closer for them to actually snap correctly. There you go. Finally. So selecting 1 and 2, actually this one and duplicating them one more time, going over here. Voila, there you go. So now what I'm going to do is from ground here, all the copied ones, duplicate them and move them over here. And let's zoom in just a little bit more, move them closer to the edge where I want to snap them. Come on, snap, there you go. So voila, this is going to be our play field in the game where we can move, where the enemies are going to attack us and all of the good stuff and yada, yada, yada. Now, again, if something is not clear, make sure that you ask in the comments down below, but just make sure that you set all of this, make sure that you practice how to snap things. And yeah, again, renaming these is not mandatory. You can do it. You're not obligated. It's your own will. And that's it from me. Okay, let's get into the juicy stuff. So now we're going to program the player's movement. I'm going to right click over here and create a folder that I'm going to call scripts. And inside of that folder, right click, and we are going to create a C# script. I am, of course, going to call it the player. And I am going to attach it on the player game object. But of course, first we do need to wait for the compiler and all the good stuff. And anyways, we have attached a component, which means we made a change on a prefab. So what we need to do is go over here, click on overrides and apply all. So now our copy or the original prefab in the folder has this change. Let's double click this bad boy and open it here in my Visual Studio. So over here, I'm going to say class. So now we're going to apply everything what we learned so far. Now, what do we need in order to move our game object or the player? Well, if you remember in the lecture about variables, I said that, the mandatory part of every program are variables. So over here as well. So what we can do is we can say public float, and I can say move force, which is the value or actually the variable that we are going to use to move the player. I'm going to say by default it's equal to 10. And now you will see why I say by default. So next, what we can do is I can say public float. This one's going to be the jump force. By default is equal to 11F. And last but not least, public float maximum velocity is going to be equal to 22F. Now, why am I saying by default? What is the value by default? Well, by default, if I go back over here inside of my Unity editor And if I select the player, you will notice one thing. So selecting the player, if I scroll down where the class are, the player class is, which basically is a component that is attached, you will notice three variables. We have the move force, the jump force, and the maximum velocity. So they are here. And why are they here? How can we see them? Why is that possible? Well, the reason for that is simple, because we made them public. Now, we will not need this maximum velocity. I was experimenting something with it, but we don't need it, so we can remove it safely. But what I want to show you over here is we set this to be public. If you remember in the lecture about public and private variables, which is basically called data encapsulation, we said that variables, that you're going to set variables to be public or private and so on and so forth, depending on your needs. And again, I said as a general rule, you will make your variables private and create accessors and so on and so forth. But as I said, that's a general rule, but doesn't apply to every situation. So over here, we need these variables to be public. We can make them private as well, and I will show you that. So we set them over here to be public, and now they are also visible inside of the inspector panel. So any variable that you make public, it will be visible here in the inspector panel. You can edit these changes. So I can change this value from 10 to 20, and that new change that I made over here in the inspector panel will be the value that will be used for that variable. So if I set here the value to be 20, then that value will be the current value of the move force. Same thing for the jump force. Now we can make them private. So if I say this private over here and private over here and go back in my editor, and if I select the player now, you will notice that these variables are missing. So they are missing and we cannot use them. If you want to encapsulate your value, so you don't want the move force and jump force to be accessible in any other script, so you want to make them private, but you still want to edit these values in the inspector panel because it's pretty useful. You don't have to go into your script, change the code, save the code, wait for it to compile, then use it. You can directly change it over here in the inspector and the changes apply automatically. So what is the solution over here if we want them to be private? Well, there is one thing that we can do. In open close square brackets above the variable that we have declared, so above it, we can type serialize field. And over here, I can type as well serialize field. And I can go back. So now these variables again are going to be visible in the inspector panel, which means they are private. They cannot be accessed by other classes, but they are visible in the inspector panel. We can edit them here and that change will apply. So yeah, that's some knowledge right there off the bat. Next, what I'm going to do is we are going to create a private float, movement X. So I'm going to call it movement X. And now we need to get our components, which are the rigid body, the animator, and so on and so forth. So we need to say private rigid body 2D. I'm going to call it my body. We are also going to get the private animator that I'm going to call anim, and we are going to have a private string which is going to be walk animation by default, or actually the value is going to be walk. We will see later on for what we are going to use these. Do not worry about that, but just now know that we have these components. And last but not least, we are also going to get a private sprite render SR. I'm going to call it like that because we want to access the sprite component, and we will see why. Don't worry about that. What I want to talk next is we need to get these components. Simply here, we have declared them. So they are declared over here. How can we get them? How can we get a reference to them so that we can access them via code and use them in the code? Because now if I try to do anything, and I'm going to use awake for this, if I try, for example, my body add force new vector 3 or 2 to 2 like this. So I'm just adding force to demonstrate my point. If I go back over here, and if I go in the console, clear everything, hit the play button, notice what is going to happen. We have a null reference exception. It says object reference not set to an instance of an object. What does that mean? That means that our rigid body and it's pointing over here. See, it is telling you it's on in the player class on line 25, and this is the line 25, meaning we are trying to modify or access properties from the rigid body, but we don't have a reference. Remember, when we create a class and then we create an object from that class, that object is a reference. So that object is a reference, and we only have here a declaration of it. We don't have a reference. So the solution can be, we can either make it public. So if we make it public and then we go over here inside of the inspector panel, you will notice that the body, so you see my body now, it's currently set to none, so it's empty, but we have it, it's visible over here. We can take the rigid body component that's attached on our player and we can drag it over here. That will work. You see, we have attached it. We can also drag the player himself over here and that will work because he has a rigid body component, and that works fine. And now we don't have that null reference exception. So this is one of the ways how we can do it. Another way, we can create it to be private and we can set the serialized field and do the exact same process. So we can repeat what we just did. So we can go back over here. It is set to be private. And now I can drag the player over here and voila, there you go. Because the field is visible over here in the inspector panel, meaning we can attach a component directly on it. So this is the second way, which is basically the same as the first way, but our variable is private instead of public. Last but not least, we can go here in the awaken. If you remember the lectures, we used get component. So we can say my body is equal to get component rigid body 2D, and this is how we get that component from code. So this right here that we are doing is equivalent to what we did now by dragging and dropping this same component in the field in the inspector panel. So this is how we do it via code. Now we are going to get the body, we are going to get the animator. So over here, not animation, but actually animator. Here it is. This is what we want. Last but not least, SR is equal to get component, and we want to get the sprite renderer component, and voila, there you go. So this is what we need for now in order to move the player. Well, actually, we don't need any of these to move the player because we're going to move it via transform, but yeah, we will need it later on, so don't worry about that. So now below the update, I'm going to create void and I'm going to call this function player move keyboard because we're going to use the keyboard to move the player. And as I said, below update, but inside update, we are going to call this function. So what's gonna happen over here? What's gonna happen is that we are going to get the movement x, which is the variable that we have created over here. So we're going to get the movement x, and that's going to be equal to input get axis raw, and then I'm going to say horizontal, and voila, that's all there is to it. What the hell is this get axis raw, teacher? I don't know. I am going to start to panic. You are crazy, teacher. You're on some kind of weird things that you're smoking. I'm not saying that's not true. I'm just kidding. I don't encourage anything. Just kidding. But yeah, anyways, get axis raw. You see, it returns the value of the virtual axis identified by the axis name. We set horizontal to be that name. That means we're going to get the input when we press the left or right arrow key or A and D key. And this value is going to be either -1 when we press the A key or left arrow, +1 if we press the D key or right arrow, and 0 if we don't press any keys. Now we also have over here get axis, so that's also what we can do. But get axis, the value goes from 0 slowly up to -1. So it goes 0.01, 0.02, and so on and so forth, up to -1. And the same way it goes from the positive to the, from 0 to +1. And to show you that, I'm going to simply say debug.log. And from here, I'm going to say move x value is : plus movement x. And why is it? So over here, plus, oh yeah, I added a colon instead of a semicolon. So let's go back over here and let's try it out. This is get axis, not get axis raw. Notice in the console, I'm not pressing anything, the value is 0. I'm going to press the A key. So now I'm pressing the A key, pay attention down, but for some reason the console didn't do it. Okay, let's try to press the A key. There you go. You see now the console, it's showing 1, and now I'm pressing the D key, and there you go. But one thing that you notice is, pay attention. You see what I said? It goes from slower, or it doesn't go directly to 1 or -1. You see, it goes from 0, then 0.03, 0.04. You get the point, up to 1. For the negative, it does the same thing, except it goes into the negative side. This is if you press the A or the D key, left arrow or right arrow. If I use get axis raw, we're going to see the same thing, except we don't see the 0.01 and 2 and then 3. Here we see 0, and now I'm going to press the D key, automatically we see 1. I release it, we see 0. I'm going to press the A key, automatically we see -1. There you go. Now you are probably asking me, what is the wisdom if we press those keys and we know the value is -1 or 1? Well, the wisdom is that this is the coordination system. This is X and this is Y. And down there is also Y, and over here is also X. The left side is the negative side. The right side is the positive. Up is positive, down is negative. This is on the vertical. We're not going to use vertical now, we're using horizontal, but you know, the same explanation for horizontal applies to vertical. So if we press the left arrow key or the A key, the value is going to be -1, which means we're going to the left side. If we press the D key or the right arrow key, the value is going to be positive, which means we're going to the right side. That's how we know where we are going, left or right. So next, what we are going to do is we're going to use the transform.position is going to be plus equal to, and we're going to say new vector 3, and to it I'm going to apply the movement X, and 0 for the X, 0 for the Y, actually Y and the Z. And then I'm going to multiply that with time.delta time, and then I'm going to multiply that with the move force. So what is this plus equals? Well, we explained it. Plus equals is same as if we type transform.position is equal to transform.position, and then plus all of this over here. So instead of typing all of that, which you see it's much more in code, we are simply typing plus equals. That's a shortcut to add this value to this value over here. And we're adding a new vector 3 and only adding here the movement X. Why movement X? Because we're only moving on the left and the right side. We're multiplying that with time.delta time and move force. Before you ask why we multiply like this, I will show you right now. Let's go over here just to test it out if this actually works. We're calling it in the update. I'm going to hit the play button. So now you see we are moving left and right. So what is this? Well, naturally, you want to move your character, so you're going to multiply it with a certain value. If you don't multiply it, so if we don't multiply the character, we only set here the movement X, that is the value. It will either be 0, -1, or 1. So if I go over here, and if I hit the play button, you will notice, you see how he's moving? He's moving like crazy. You see, he's moving pretty fast. He's moving 1 unit per frame. So we don't want that. What we want is to multiply it. So that's why we are multiplying with the move force. But move force on its own is a high value. It has a value of 10. And I'm not even going to try this because you saw just by adding 1 or -1 how fast the player was moving. If I multiply that with this value, it's going to move like crazy. But I'm multiplying that with multiply time.delta time. And if I hover over, you will see that time.delta time is the completion time in seconds since the last frame. Basically, time.delta time is the time between each frame. So if we have 60 frames in a single second, you can assume that this is a very low number. But in order to smooth out the movement in Unity, when you're moving game objects like this using the transform component, then you multiply it with time.delta time. So now look at this. Look at how the player is moving. You see how his movement is smooth. It is very smooth. He's not moving like crazy and so on and so forth. And you get the point. So your assignment is try to move the player without using multiply time.delta time. So just multiply it with move force and then multiply with time.delta time and see the difference. Also, you can use debug.log to print out time.delta time. That's on you. I want you to do that too. That is how you will understand these things much, much better. So use debug.log to multiply that, and also multiply these values, or just multiply the movement with the move force. You get the point, and then you will see the difference, and then you will see what does it mean when we say, or in another tutorial when somebody is explaining what does it say, what does it mean that you smooth out the movement with time.delta time. So yeah, just test it out and you will see for yourself. Alrighty then, my little game developer elves, now that we are moving the player with these two simple lines of code, let us now animate the player. So for that, right below this function, I'm going to create a new one, void, and I'm going to call it animate player. And notice how I am creating functions. If you remember, the lecture about functions is that we have functions that don't return anything, denoted by void, and we put lines of code inside that we want to execute over and over. So you can see now and get an idea how you can create your own functions. For example, over here we have the player move keyboard. Instead of putting this or these two lines of code in the update, we put them in a function and then we put them inside of update. Same thing with the animate player. So below the player move keyboard, I'm going to call animate player function. And inside of the animate player function, we're going to take advantage of our movement x variable. If you remember all the talk I did about get access raw, how it will return either -1, 0, or 1, depending on if I'm pressing or not pressing the keyboard keys on my keyboard. Keyboard keys on the keyboard. Yeah, I mean, what else is on the keyboard? So if I press A or left arrow, we will get -1 because we're going to the left side. If I press D or right arrow, we are going to get 1 because we're going to the right side. And if I don't press anything, we're going to get 0. We can use that information because now I can say if the movement X, but first things first, in order to animate the player, we're going to call anim set bool, and we are going to call the walk animation, and over here I'm going to set it to be equal to true. And this is how we are going to animate the player. Now, before we proceed to do all of this that I just wanted to do, let me just show you the animation and what will happen when we animate the player. So going back here inside of my game, hit the clear over here for the console, hit the play button. Now when we animate the player, see what happens? Well, basically, the player is animating this whole time. Even when we are standing, he is running like crazy. You see the crazy player, crazy. The issue here is if we just call this anim to set the bool animation, or to set that transition, then you see what happens. And I will get to this set bool and what this over here is, don't worry about that. Going back to what I was talking about, now we can use the movement X and we can say if movement X is greater than 0. So if it's greater than 0, we know that the value is equal to 1, and we know that we are going to the right side. We are going to the right side, and you will see in a moment why this is important. Else, if our movement X is less than 0, we know that we are going to the left side. So over here we can say we are going to the left side. Else, if movement X is not -1, or actually it's not, if it's not greater than, or if it's not equal to 0, that means it is equal to 0. So what's gonna happen? Well, over here we're going to call the animation to play it, and over here we're going to call the animation to stop it. Don't worry about that. I will explain everything what is going on in a moment. So when the value is greater than 0, or when it's lower than 0, that means we're moving either to the left or to the right side, and we're going to animate the movement. Else, if that value is not greater than 0 or equal to 0, greater than or less than 0, then we are going to set this to false, because then we are not going to animate the character. And let me show you that. So when I go back over here and hit the clear button, now when I run the game, you will see that the player is not being animated. But if I try to walk, he's being animated. If I go over here, he is being animated. And again, if I move left or right, left and right, he is being animated. When I don't press anything, he stops moving. So that is why I've explained all of that, what we are doing with the get access raw, and this is how we can use that information for our own benefit. Now, one thing that you probably saw is that our player is he's not facing the direction where he is going. So if I hit the play button again, if I move him to the right side, he's facing the direction, that is correct. If I move him to the left side, however, he's moving backwards. This is not something that we want. And there are two ways how we can fix that. First way is for us to use the transform property of the player, of the game object, and its scale, to be more precise. We have the scale that basically determines the size of the player. And notice over here what I mean. If the scale for X, Y, and Z is currently set to 1. If I set it, for example, to 3, you see how the player is being enlarged. So the scale will make the player larger or smaller. Now you're asking, but teacher, you're crazy. We're making the player smaller. We're not animated. You are correct. I am crazy, but you're not correct on the other assumption, because I can use the scale X, and instead of using 1, I can say -1, and automatically you can see he is facing the opposite side. That is one of the ways how we can fix it. Another way how we can fix it is over here in the sprite renderer itself. For the flip property of the sprite, we have the flip X and flip Y. So if I check the checkbox for flip X, there you go. He is, facing the side, the different side. You see that. If I flip him on the Y, you also see what's happening, but we don't need the Y, but basically it works the same way. That is the reason why I got a reference to the sprite renderer over here. So the sprite renderer component has the flip property over here that we can use to change the direction where the player is looking. So over here, when we are looking or going in the right side, we are going to say SR, sprite renderer, flip X is going to be equal to false. Why false? Well, because over here, we are going to the right side. If I go back, you see by default, the player is rotated to the right side. And when he is rotated to the right side, you will notice over here, the flip X value is not being checked. So it's not true. It's actually false. So that's why over here, I'm also setting it to be equal to false. But when we are going to the right side, then I am going to set that value to be equal to true. Which means now, if I go back, you will notice... So if I hit the play button, you will notice that when I go to the right side, he's animated correctly. If I go to the left side, he's also animated correctly. And there you go. You see the player is being animated and yada, yada, yada. So the side where he is going is being animated. Now, one thing that I want to show you is regarding the animation. What is this set bool? What is this walk animation? True or false? If you remember, inside of the animator panel, we created a parameter called walk. If you remember over here, then we used it for these transitions that are going from idle to walk and from walk to idle and vice versa. So we are using the walk parameter to control those transitions. If it's equal to true, that means we are going from idle to walk. If it's equal to false, that means we are going from walk to idle. And if I select these transitions, you will notice that is true. And in order to do this in the code, why I'm calling set bool? Because if you remember this parameter that we created, it's a boolean, it's a bool. So boolean or bool is shortcut for boolean. That means this walk is a boolean, and if I want to call it in the code, I need to call it set bool, provide the name of that parameter, which in our case is walk. So the name over here, walk, needs to match up with the name that you pass over here. I'm passing my local variable called walk animation, or class variable, that is, walk animation over here, that I set it has a value walk. What is the wisdom behind this? Well, instead of us doing this, so instead of you doing this over here and this over here and this over here, on 3 places, you hard-coded a string, which means it can happen that you make a mistake. How, you are asking? Well, because this name over here, walk, needs to exactly match with the name you type here. If you type here lowercase walk or with lowercase w and go back and you try to move your character, so if I hit the play button and let me go here inside of the console, if I'm moving to the right side, it works. If I'm moving to the left side, you see it doesn't work. You see parameter walk doesn't exist. The player is not animating on the left side. There you go. Because the parameter doesn't exist. The name, capitalization, and everything needs to match up with the name we use here. So instead of us using a string every single time over here, which will open the opportunity for us to make a bug, because we can easily make a mistake like this or something like that. Instead of that, I put it in one place. So walk animation over here, and I just do this, and I put the walk animation here, I put the walk animation here, and I put the walk animation over here. Because now if I have a problem in any of these, I know that I only need to fix it over here, and it will apply that fix everywhere where I'm using the walk animation variable. So going back over here, when we set that to be equal to true, as in these two cases, we are moving, and that means we need to animate the movement. And if I set it to false, that means we're standing and we don't have to animate the movement. One last thing that I want to talk about when it comes to the animation, you will see now that when we are moving, pay attention. You see the animation is playing, you see the blue thing, it is playing, and now when I start to move, you will notice that these transitions are working. And one thing that you will probably notice is that if I try to stop, you see I'm stopping and then I try to move, the player is not animating right away. You can see like he's sliding a little bit. I don't know if you can see that exactly, but I'm sure that you notice that bug. How you can fix that is you can select the transition that you have over here, and in the inspector you have the settings drop down list, and you can click on the settings for the drop down list. Now over here we have a few parameters. We have the exit time, fixed duration, transition duration, so on and so forth. Basically this time over here, these parameters will tell us how much to delay the transition, or how long the transition from one animation to another will be. Now in our case, we don't need it to be long, we want them to be instant. So instantly go from idle to walk and instantly go back from walk to idle. That's why I'm going to use the transition duration over here and set that value to 0, because I don't want the transition to last even a half a second, even 0.01 of a second. I don't want that, because it will make my player slide. He will appear like he is sliding a little bit. So I'm going to select the walk, or the transition from walk to idle, and also set the duration back to 0. There you go. And if I hit the play button, you will notice now how the transition is instant. If I stop, right away the player stops. If I move, right away the player starts walking. You see? There you go. Now one more thing that we can do, if you find the walk animation too fast, we already changed it over here. So we set the sample rate to 24. Actually we didn't, but now I did. So actually this is for the idle, excuse me for that one. So let's go back over here. We set the sample rate to, so it's over here, come on, there we go, to 24. If you think the animation is still too fast, what you can do is you can select or click here in the animator tab, the walk animation, you can click on that. And over here in the inspector, you will notice that we have motion and we have speed. The speed is how fast the animation is. 1 is basically the normal speed of the animation. If I say over here 0.5, that is half time slower. So twice as slow as normal time. And if I hit the play button now, let me just move my Unity editor up, and if I try to move, you see how the animation is a lot slower. So I'm probably going to set that at 0.7, 0.8, whatever. You can experiment with that, that's up to you. It's not mandatory to have the exact same settings that I have, so yeah, don't worry about that. Experiment it. I encourage you to do that. And also don't forget that everything we're doing for player 1, you also need to do for player 2. So make sure you take the player 2 and you open the prefabs folder, put him over here, attach the script on him, and apply everything that we did so far for player 1. That is your assignment to do. Moving forward with the player, the next thing that we are going to do is make the player jump. So inside of my script over here, right below the animate player, what I'm going to do is I'm going to create void player jump. There you go. And over here, what's gonna happen is that I am going to test if the input.get button down. So before I explain that, so let me just write it. So get button down, and I'm over here going to say jump. Now this jump is predefined by Unity, and it is basically for every platform, but depending on the platform, it will utilize the keys for that platform. For example, if we are on a computer, when we press jump, that will count as space. If you are on console, when you press jump, that will be maybe X or whatever button is assigned to that. If you are on mobile, then, you know, it will be a touch, but basically for mobile, we use other things. But anyways, this is platform neutral. basically for which platform we are creating or using this code, it will use the default button that is used on that platform to perform a jump. Now, what is this get button down? Let me explain that. So I'm going to go over here in the update and I'm going to call here player jump like this, just so that we can see what is going on. Get button down, you see, returns true during the frame the user pressed down the virtual button identified by a button name. This is going to tell us, so debug.log, this is going to return true during the frame where we pressed down the button. So let me just show you that. And I'm going to say jump pressed. And let's go back here in my Unity editor just so that I can show you this, because we have 3 things that I need to show you so that you can understand when it comes to buttons. So going back over here in the play, when I press, so I have pressed the button, which is the space on my keyboard. And you see here jump pressed has been printed in the console. Now I have released the button. Again, I'm going to press it and I'm currently holding it. This is important to notice. I'm currently holding it. I have pressed it and I'm holding it, but only once we see jump is pressed. You see, only once. And again, I have pressed it and you get the point. Why is this important? Well, we also have over here get button. So get button up. What is this? Well, let me show you now. If I go back and if I hit the play button, now I am going to press the button, the space button, and I have pressed it. So I'm holding my finger on the space button and I'm not releasing it. Notice what happens in the console when I release it. Bam, you see I have released it, it says jump pressed. Again, I have pressed it and I am still pressing it and I have released it. Now we see jumped or jump pressed. And we have a third thing, which is only get button. So let me show you the difference between them. So going back over here, let me clear it, hit the play button. Notice now I am going to press and release. You see, it is pressed basically 2 times. I just pressed it and released it. How come? Well, again, I'm going to press and hold. You see what happens when I press and hold? It is called all the time. So basically, when we call get button, this will return true while the virtual button identified by button name is held down. When we use get button down, it will return true when we press down the button. And when we use get button up, it will return true when we release the button. So we press it and then we release it. This is important to know. And this is not only for jump, this is for any key, be that if you're using A, B, C, D, any key on the keyboard and so on and so forth. So the same principles apply. So this is important to know. Now, I'm not going to call this in the update function. Instead, I'm going to call this in fixed update. So it's basically void fixed update. There you go. And this is where I'm going to call my jump button, or actually jump player jump. Why in fixed update? And what is fixed update and update? What is the difference? Well, if I hover over the update, it will say update is called every frame if mono behavior is enabled. Basically meaning if this script is enabled, so if the script is enabled on the player, then it will be called every frame. If I hover over fixed update, you see this function is called every fixed frame rate if the mono behavior is enabled. Basically, fixed update is not called every frame. It is called a fixed number of intervals, so fixed number of rates, and you can see that it is over here. Let me just go. I believe it is under edit and then project settings, and I believe it's over here. Is it under physics? No, it's actually under time. Yeah, here it is. It's under time, and this fixed time step, it's currently 0.02. So fixed update will be called every 0.02 seconds. And why is that? Well, because in fixed update, we use it usually we use it to perform physics calculations involving the physics system such as the rigid body. So over here, if we get button down is jump, then what we are going to do, we are going to say my body that add force, which is basically going to apply force. You see, it is going to apply force to the rigid body, and the force is going to be new vector 2 because we want to apply force on the y-axis. On x we don't want anything, so 0. On y it's going to be jump force, and over here I'm going to say force mode impulse. Now what the hell is this, teacher? I don't understand, you're confusing me. Is this some weird math? No. Same as how we can move our character by using the transform.position and adding to it this value over here. This is how we can move a rigid body by adding force to it. And new vector 2 is denoting we are adding the force on x-axis and we are adding the force on y-axis. Except for the x, the value is 0, so no force on x-axis, and jump force value, which is this bad boy over here on y-axis, which means we are pushing our player upwards. Force mode 2D impulse basically means add an instant force impulse to the rigid body using its mass. Basically, it's just going to push the player right up. It's just going to push him, move him upwards, and that's all there is to it. Now, if I go back, we are going to see what is going to happen. So if I hit the play button, now when we jump, you see, there you go, wee. Now the player is falling down a little bit slow. I don't want that. Because of that, I'm going to select the player, and here in the inspector under rigid body, you have something over here called mass. You see this mass? Currently by default, it is set to 1. That's basically the mass of the player. But we also have something over here. We have gravity scale, which is currently set to 1, meaning the gravity will affect the player normally, so 100%. If gravity is negative 9.81 or 82, I forgot the value of the gravity, this one will denote that multiplied, so gravity multiplied by 1 will affect the player. If I set here 2, that means now gravity multiplied by 2 will affect the player, so he will fall twice as fast. Now take a look at this. So if I go back now, and if I hit the play, or actually if I hit the space button, you see how he is, you see now? He is not falling slower and he's not jumping that high as he jumped a moment before. Now, I'm not going to go again and show you that. You can test it on your own, but I'm going to override this and make sure that you do the same thing for player 2. So over here, set the gravity scale to 2. Now, one thing that we have an issue over here is if I go now, I only want to allow the player to jump once, because now I can jump in infinity. You see, I'm just pressing space and the player is jumping in infinity. He's over there. Now he will land. There you go. This is not something that I want. So how can we fix this? Well, for this, we need to improvise a little bit in our code. What we are going to do is we are going to create over here a private bool called is grounded. So is grounded. Now, this is not like your parents telling you you're grounded, you cannot go outside, none of that, so don't cry. This is basically just to test if we are on the ground. So over here, if input get button down is jump and is grounded is true. So now going back to the lecture of if statements, conditional statements. Remember, I've used this if to test two conditions. So instead of me typing this, if input get mouse button down is jump, or get button down, excuse me, is jump, then if is grounded, and then we, jump. Instead of doing all that, we can simply test that in a single if statement and passing it over here, which means both of these. So this needs to be true, that we press the jump button, and is grounded needs also to be true, so we are on the ground. So in this case, when we jump, we are going to say is grounded is equal to false. So this will not allow us to jump 2 times now. So it will not allow us to jump 2 times. And this will fix our problem. So I'm just going to put it here by default to be equal to true so that we are able to jump once. And let me show you what I actually mean. So if I hit the play button now, I'm going to jump once and try to jump again. I jump once and I'm pressing the button and now nothing is happening. So and I'm trying to jump right now, but again, it is not allowing me to jump again. So what the hell is wrong, teacher? You said that this is going to help us, but this is not helping us, and I'm going to start to panic because game dev is hard, and I'm going, no. Game dev is not hard. Let me show you, because now we have jumped. And is grounded is false, which means when we press this button next time, is grounded will be false, so this statement will be not executed. Basically, it will be false. How can we make the is grounded back to true again? Well, for that, we need to go over here inside of our game and in the ground holder. selecting all of these grounds, you see all of these grounds, we need to know when we land on the ground that we are actually on the ground. And how can we do that? Well, first, we are going to go here under tag. Select any game object in the hierarchy and go under tag, click on the drop down button and click here add tag. Next, click on the plus button over here and create a tag called ground and copy its name. So make sure you copy its name and now press save. So now we have a tag called ground. So I'm going to select now all 31 ground objects that I have in my scene, and I'm going to click on the drop down list for the tag and I'm going to select the ground tag, which means now every ground in my game has a tag called ground. So now I can go over here in my code and I can call on collision enter 2D, which is a built-in function into MonoDevelop or MonoBehavior, which will allow us to detect collision between two game objects. This collision parameter will be the second object we are colliding with. And how it works is basically the player over here, when he falls on one of the grounds, so when he touches them and lands on them, he is landing on a collider because you see we have a collider on the ground. And in the code, we can use onCollisionEnter to test the collider that we have landed on. So over here, I can say something like if collision.gameObject.compareTag. Now notice this over here. What is this compare tag? I'm going to add a string over here, and if I hover over, it will say, is this game object tag with the tag? And over here, we can say ground. This is everything what we need to do. But of course, if you remember what I said, we're going to copy this. We talked about the animation, so we're going to do the same thing with the ground. So we're going to say private string, and I'm going to say ground tag is equal to, and like this, simple as that, easy peasy. So there you go, we have the ground tag. And instead of using the name like this, I'm simply going to pass it like this over here. So essentially what we are asking, okay, computer, the game object that has a collider that we landed on, is the tag of that game object equal to the tag that we passed over here, which in our case is ground? And again, same as with the animation, the name that you added for your tag over here needs to match up. So the name added here needs to match up with the name here. If the G is capital, G also needs to be capital over here. If it's not capital and over here it's capital, it will not work. So if we landed on a game object that has a tag ground, then simply we're going to say is grounded is now equal to true. And we can say that because we know that only the ground game objects have the ground tag because we set it up like that. It's impossible for other game objects to have that tag. So this is the function onCollisionEnter 2D for 2D and simply onCollisionEnter like this for 3D. So it's 2D, let me put that back so it will not work. This is the function that we use to detect collisions between game objects. So now I can go back and I can hit the play button. And now when the player falls on the ground, we will notice, yeah, we have collided. Now I can jump, there you go. And again, when I fall, I can jump. And just to illustrate that, what I'm going to do over here, I'm going to say debug.log. And over here, I'm going to say we landed on ground, which means now we can jump. Grounded is true. And let me just clear the console, hit the play button, and let's try it out. So now you see we have landed on ground. Don't mind this being printed 2 times because, you know, when the player lands, because of the mass and the physics system, he will jump off the ground a little bit. Same as in real life when you know, throw a ball and it starts jumping and, you know, that sort of thing. So let's try it out. There you go. You see we landed on ground. And again, there you go. We landed on ground. And this is why and how we can utilize a Boolean and collision in order to allow the player to jump only once and not allow him to jump a gazillion times. If I run the game now, we can play the game with the character, he can move and all of that, but we have one problem. That is the character goes out of bounds of the camera and yeah. simply that happens, so we don't see the player. What we need to do now is make the camera follow the player. So let's go back here inside of our scripts folder and right click, and I am going to create a C# script, call it camera follow. And what I'm going to do now is select the main camera, and I am going to attach the script on the camera. Simple as that. And double click it, open this bad boy in Visual Studio. So over here, let me just tag the class. And what we are going to do is we are going to get a reference to player's transform. So we're going to say over here, private transform, and I'm going to call this player. And we are also going to have a private vector3, which is the temp position of the camera. Now, in order to get the player's transform, we are going to use something called find with tag. And we saw the use of the tag over here when we tried, or when we are comparing the tag here with the ground tag to see if we're colliding with the ground tag. Well, for the player, select him, and over here under tag, simply select the player tag and make sure that you apply to all, and make sure that you also do that for our second player. So don't forget to do all the changes we do for player 1, do those changes for player 2. So tag player 2 as well. So what's going to happen now is that here in the start function, when we initialize the game, we're going to say player, which is the transform property, is going to be equal to game object, and it's capital G, so game object dot find with tag. So find me a game object with the tag that we specify here, and the tag is player, and I need to say dot transform because we want to get the transform property from the player. Now, of course, you can create the variable separated over here, but this is the only place where we are going to use this. So only place over here, we're not going to use it anywhere else. So it's totally fine to use it over here, because even if we make a mistake, we know where to look. This is only, or we use these things over here like this, so we declare them just in case when we are using them in multiple places for the most part. But again, when you're using it only on one place, you can do it like this, or you can create a variable. It will make no difference. Anyways, so now this game object find with tag, and if I hover over, you will see returns one active game object tagged with the tag, returns null if no game object is found. So this basically, this function is built into game object, and it will go inside of the scene and it will look for a game object that has a tag that we specify over here, and it will get dot the transform position property, from that game object. So going back over here in the update, what I'm going to do is I'm going to use the temp position. So temp position, and not this one. So copy this. Temp position is equal to transform.position, which is the current position of the camera. Next, I'm going to say temp position x is equal to player.position.x. And then simply we're going to say transform.position of the camera is equal to the temp position. So what's happening over here is that the temp position of our, or basically the temp position, we are storing that value over here. So we are storing the current value of the position of the camera. So this is the current position of the camera. So X, Y, and Z. Next, take the temp position, which is storing the current position of the camera, and the X of that position, set it to the player's current X position. And now assign that value back to the current position of the camera. And this will, basically what this will do is the camera will have its own Y and Z position, but the X position will be the one from the player. So this is how the camera will follow the player, and we can test that right now. So we can go back over here. We have attached that on our main camera, so it is attached. If I hit the play button, now we will see that the camera is following the player. But you can see this glittering, this jittering, and what the hell is this, teacher? You know, what is this? Some kind of recording issue? No, it's not. My recording is totally fine. Don't worry about that. But the issue here is we are calling this in update, because also here the player is being moved in the update function as well. Now this is not a bad thing, but sometimes it can cause problems like the ones you see over here. So in cases where you want the camera to follow the player, usually what you do is you call that code in late update. Now in the player, we saw that we have update, we saw that we have fixed update, but what is late update? And I've explained what is update and what is fixed update, but what is late update? Well, basically late update is called every frame if the behavior is enabled. Same as with update, but what is the difference? The difference is that the late update is being called after all calculations in update are finished. So after every calculation that is done in the update, such as moving the player, that calculation is finished. So we have a new and fresh player position, which is already calculated and done for us to use in late update. So now we will not have conflicts because both functions are called in the update. We will not have conflicts because of that. So we can go now over here, and if I hit the play button, we will notice now what is the difference. You see now we don't have that jittering, we don't have that glittering and all of the good stuff. So yeah, that is that. But we do have one issue. And that is, I can walk with the player, as you can see, but what happens when we get till the end? You see over here, what happens when we get till the end of the level is this over here. You see, I don't want this. I don't want the camera to follow the player up to here. I want the camera to follow the player up to here, for example. So up to, we can see that the value for the position is -60. So what can we do in regards to that? Well, basically, we need to go over here and right below our temp position, we need to create two serialized fields, and they are going to be private float. So it's private float, and one is going to be minimum X and another one is going to be maximum X. Now you're going to be like, teacher, what you're doing? You wrote two. This is not what. Calm down. Do not worry about it. Basically, instead of me typing it like this and then again, private float, then maximum X, you get the point, and another serialized field. If we have two variables of the same type, such as a float over here, we can declare them on a single line by using comma. So I can say here comma, and I can remove this from here, and this is counted as two float variables. One is called minimum X, another one is called maximum X. And that's all there is to it. And I set them to be serialized fields because over here we can now edit them in the inspector tab. So over here in the inspector, so the minimum we said it was -60. So somewhere around here, there you go, exactly here. -60 is the minimum X, which means the maximum is +60 right away. So right off the bat, I can just go over here and I can say +60 and there you go. So this is up to where we want the camera to follow the player, and we don't want the camera to follow the player outside of those bounds. But okay, how can we make that happen in the code? Because at the moment, nothing is happening in the code. Well, basically, what we need to do after we get the temp X from the player current position, we need to test if temp position X is less than the minimum X value. That means we are going outside the minimum value. So for that, we're going to say temp position X is equal to minimum X. And if temp position.x is greater than the maximum X value, then temp position.x is equal to the maximum value. Now, in order for you to see this visually in a better way, I'm going to take the game tab and I am going to, instead of setting here -60, I'm going to say here -20 and +20. So only up to 20 will my camera follow the player. And you will notice that now. So I can go over here and we can see the camera. So you see I can move and pay attention. The camera's value currently is at 4. When we get to number 20, which is currently now, you see, pay attention over here. The player now goes out of bounds. You see, the player is again out of bounds. He is here. You can see him. We don't see him in the game tab, though. We see him in the scene, but the camera is not following him anymore because now the player's, the allowed maximum X is greater. So the player's position X is greater than the maximum allowed X where the camera can be, which means now we're setting that position of the camera to be to that maximum allowed position, which basically means we are allowing the camera to go up to this point over here. So if the player's position is over here, way off the point, we are not going to allow that. Instead, we are going to set the camera's X to this position and not allow it to go out of bounds. So this is what we are doing. And we just need to go back and change the values again to the original ones, which is -60 and +60. So -60 and +60, which means now I can run the game. And again, let me just demonstrate that for testing purposes. Let's go into the positive side so that we can see it over here. We will notice now when the player gets to that value, you see the player now is moving, the camera is not moving anymore. You see the player can go, he can go outside of bounds here, but we're not going to do that in our gameplay, but the camera will not follow him, and this will not allow us, you know, to see the gray area where our game is not played and yada, 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 and all of the good stuff. If the player tries to go back now, the camera is following him back up to the negative or the minimum in the negative side, or basically the maximum in the negative side. So it will follow him up to -60, you get the point, and it will not go beyond that point again. So this is how we can restrict the movement of the camera even though it is following the player and not allow it to go out of bounds. If something was not clear in this lecture, please make sure that you ask in the comment below and I will explain everything. What is up, gamsters? See what I did there? Gangster, gamester. See what I... Anyways, never mind. Moving forward, here in our sprites folder, we have our monsters, or enemies, basically. So what we are going to do is the good old sprite mode from single. So the sprite mode doesn't want to be single. He doesn't want to have, you know, be alone. He wants a girlfriend, so I'm going to give him a multiple. Let's go over here, sprite editor, and voila, these are the monsters. So we have the ghost, we have, you know, you see the monsters that we have. So what I'm going to do is simply click on the slice, and yeah, there you go. So here is the ghost. I am going to rename these bad boys. So select the ghost, and I'm going to say ghost. And this is going to be ghost 1, and then ghost 2, and then ghost 3. Let's go over here, 3. And then 4, and then, I mean, this is a little bit tedious, so I am going to stop with the ghost. I don't want you to, you know, like, watch me rename all of this, because, well, yeah, you don't want to watch that. Simple. So you can rename it if you want it on your own. I'm satisfied with this. Let's go and hit the apply button. So now we need to create enemies from these sprite sheets. Now what I'm going to do is go over here into the animations and right click and create a folder to call it enemy animations, and inside, of course, we are going to create folder for every enemy. So the first one is going to be the ghost, and it's not with double S, it's a single S ghost, and then we have enemy 1, and then we have enemy 2. Simple stuff, no need to explain what I'm doing, it's pretty clear. Right click over here, pretty clear. Right click over here, throwing bars at you, you know, moving forward. Here, this was going to be ghost controller, there you go. And going back over here, we are going to have the enemy controller, or enemy 1 controller. Enemy 1 controller. And last but not least, and this is, by the way, the animator controller, which you can see and you can assume because we already did this. So enemy 2 controller. Now you can pause the video to, you know, do all of this because, you know, this is not new stuff. We did this for the player, and I'm going to challenge you right here. Just stop the video, pause it, that is, and try to create the animations for the enemy 1, 2, and the ghost on your own before you continue watching this video. And I'm going to continue and create it right here. So let's go into the sprites folder. I'm going to drag the ghost, and I am going to name this bad boy ghost. Set here the order in layer to player. And what I'm going to do is set the player on order in layer 1, or basically they can be on the same order in layer. I don't think that matters because we don't want, you know, when they collide with each other, they are going to, you know, the player is going to disappear. When he is touched by the enemy, he's going to die. So yeah, I mean, simple as that. Next, we have the enemy 1. So going to say here, what did I write? Enemy 1, and set him on the player layer. Player layer! Now, going back over here. There you go. Come on. Come on. Finally. And last but not least, let me just see, this one is at enemy 14. So yeah, enemy 14, there you go. Select him, player layer, there you go. And I'm going to call this bad boy enemy 2. Not enemies, but enemy 2. There you go. So what is the next step? The next step is to select all 3 of these and attach an animator controller on them. For the ghost, as we already know, we are going to attach the ghost controller. For the enemy 1, we are going to attach the enemy 1 controller, and for enemy 2, we are going to attach the enemy 2 controller. I am also going to select the ghost and attach a box collider 2D on the ghost. So this is what we want, basically on both of these. So attach a box collider 2D, and on all 3 of these we are going to attach a rigid body. So rigid body 2D. Now for the ghost, everything is cool. We don't need to change anything, but for these 2 enemies, I do not want their collider to be over here. Instead of the collider is going to be over here. So select him, and here on edit collider, we did this already. There you go. This is the collider. So do this and select or click on that button and simply just move the collider like this. And I know I told you to pause the video and first do the animations, but the animations are going to come anyway. So that was your assignment. Hopefully you did it. And I don't doubt that you did it, because you are a phenomenal student. I gave you A+ right now. There you go. So let's go now and create the animations. Selecting the ghost, and I'm going to move the animation tab over here. Let me just select the ghost. What is this? Why is the player, not player 1, but the ghost? For some reason, it is not giving me. So ghost controller, there you go. Animation. Why is it giving me the animation of the player? Let me just close the tab, close the animator tab as well. So go back over here into animation and animation. Okay, here we go. So now when for some reason it was showing me the player over here. So the player's animation, I don't know why. So let's go over here into the ghost, and I'm going to simply call it ghost animation. We are only going to have 1. So don't worry about having, idle and so on and so forth. That is only for the player, because the ghosts are going to be constantly moving. Selecting enemy 1, I'm also going to create the animation for enemy 1. So over here, enemy 1, I'm going to say this enemy 1 animation. There you go. And selecting enemy 2, click on create. And I am going to save this into the enemy 2 folder. And this is going to be called enemy 2 animation. Simple. Selecting the ghost and going over here into the sprites, I'm going to drag and drop all of the ghost animations over here. Voila, there you go. Now for our enemy 1, we need to select this enemies from 13 to 7 or from 7 to 13. This is for enemy 1. So make sure that you select enemy 1, and it's from 7 up to 13. And then simply drag and drop them over here. And last but not least, we have enemy 2 from 14 to 20, and simply drag and drop them over here. So let's go now inside of our scene just to preview the animations. Here is the ghost. I'm going to preview the animation. See, the ghost is wobbling like a crazy person. See, he's wobbling like he, has a seizure or something. We do not want that. So over here, we are going to set the sample rate to 24. And voila. I believe this is okay. Yeah. Enemy 2, or actually enemy 1. Yeah, he's running like crazy. There you go. Crazy. We don't want that. So over here, I'm going to set the sample rate to 24. And now he is running a little bit more normal, which is what we want. Last but not least, enemy 2. Again, let's see. Yeah, crazy. Going back over here, sample rate 24, hit here the play button. Now he runs a little bit better. If there is a need, we will also open over here again window and animator tab. We will open it and then we will, you know, slow down the animation by selecting it over here. So you can select the animation over here, click on it, and then over here inside of the inspector you have this speed. So 1 is the normal speed of the animation. 0.5, for example, is half the speed of normal animation. 0.1 is like 10% of the speed of the normal animation. You get the point. You can experiment with that and see that on your own. So going back here in the prefabs, we just need to drag and drop them. So ghost, enemy 1, and enemy 2 in order to save our enemies as prefabs. Moving forward, my game dev gangsters, now we are going to move our enemies. So let's go over here inside of the scripts folder and right click and create a new C# script, and we are going to call it monster because why not? Let me just double click this bad boy, open it over here, and what the hell are we going to do right now, teacher? Let me just put this to be on the full screen because, you know, why not? So what do we need inside of our script? We need a public float speed variable, which is going to be the speed of the monster. And I'm going to set it to be hide in inspector. The reason for that is because we do need this to be public. We need it to be accessible. In other script, we will see that. Do not worry about it. But I don't want it to be visible in the inspector tab. I also want the private rigid body 2D, which I'm going to call my body. As you already know, you know me, your body, my body. Anyways, my body is equal to get component rigid body 2D and not the question mark. This is what we need. So we need to get a reference to the rigid body, and that's all there is to it. Now, instead of the update inside of fixed update, and we explained what is the difference, fixed update, and late update. So in fixed update, we are going to use my body dot velocity, and that's going to be equal to new vector 2 speed for the x, my body dot velocity dot y for the y. What the hell is this, teacher? You're confusing me now. I want to kill you. I totally understand. Don't kill me. You will go to jail and you cannot learn game development. But what I want to say over here is, instead of, such as what we did with the player. So for the player jump, we use the add force. So there is not only one way how we can alter the gravity or forces affecting the rigid body. One of the ways is using add force. Another way is to actually set the velocity. Now the velocity, you see, it's a linear velocity of the rigid body in units per second. Think of velocity as a force, or basically it pushes the player to move. And let me just draw this again. Basically, velocity pushes the player to move left, right, and up and down. So this is what velocity will do. And as you can see over here, we have the velocity for the x and we have the velocity for the y. In a 3D game, we would have velocity for the z-axis. So over here, what I'm doing is I'm adding speed value to the x velocity, which will push the player to move left and right. And for the y velocity, I'm just using the same value that it already has, because we do not want to change the y velocity for the enemies. They're just going to move on a horizontal line, so either left or right, depending on where they are spawned within the game. So that's why I only use the speed on the x value and apply the same value of the current velocity that we have on the y axis. So that's all there is to it. This will move our enemy on this, well, straight line. And I'm going to do this. First of all, I'm going to select all of the enemies and attach the monster script. Monster, there you go. And I am going to override all, so apply this to the prefabs, but I'm going to turn off enemy 1 and 2. And what I want to do with the ghost is I want the ghost to be floating. So the ghost is not going to go on the ground. So he's not going to go on the ground like this and move and stuff like that. Instead, the ghost is going to be floating. But before we proceed, we do need to go back over here and inside of my awake, well, we can delete this later on, but the speed value is going to be equal to 20 so that we actually are moving, or that we are actually going to start to move the ghost. I'm just going to set it, let's say it's 7, just by default, you know, so that we can see that he is actually moving. Because currently, you know, over here it is set to be, you know, no value, which means the default value is 0. So it will not move the ghost. Let's just run the game and I want to show you something. So going back over here, as I said, I want the ghost to float, but the ghost, as you can see, he is moving, he's animating, and you see this also, the ghost flipped. I wanted to show you this a little bit later on in the game, but I guess, well, now is a good time to do it. And I'm going to use the player as an example. And how I'm going to do that is I'm going to take the ghost over here, and I am going to put him over here, and I'm going to turn off the monster script so that you can see what's going to happen with our player. As I said, I wanted to show you this later on, but you know, the time is right now because you saw it, so let me explain it. You can see on the player as well, so pay attention. When the player falls on the ghost, you see he fell down, and now look at what happened. Look at what's happened. Like, the player is like swimming like a fish. Look at that. He's swimming forward now, backwards. What is happening over here is that in the rigid body, and then over here we have these constraints. So again, selecting the rigid body, and then over here we have these constraints. We have these freeze position and freeze rotation. We need to freeze the Z rotation for the player and for the enemies. So make sure that you freeze the Z rotation, and now when you freeze the Z rotation, when the player lands on the enemy as he did before, you see he is not falling down because, you know, his Z rotation is frozen and he cannot fall down. So we're going to do the same thing for the enemies. So let me just turn them on because I want to save this. So first, freeze the Z rotation for all enemies and then apply to all. Before I forget, so that we don't have any issues later on, we're going to do this for the player 2 as well in the prefabs folder. So now I can turn off enemy 1 and 2 again, because what I want to do is, as I said, I want the ghost to be floating. So this is how I want the ghost to be floating. I don't want him to stand on the ground. So let's go over here and hit the play button. And we see that the ghost again is standing on the ground. This is not something we want to do. If I turn on the monster class, you see he is moving. I don't want this. I do not want the ghost to do, you see what he's doing. So what is the solution? How can I make the ghost float and not fall down? First things first, let me turn on his monster script that I turned off. And by the way, when I say turn off, this is that button over here, this checkbox. You see the checkbox over here will determine if the component that we are currently working with, if that component is enabled or not. Now for the rigid body, we don't have that option, but over here for the box collider, we have that option, which means this component can be attached on this game object, but it can be turned off, so it will not have any effect. Same as what you can see over here with the monster. It is attached, but it's not turned on, which means it's not affecting the player, or in this case, the enemy. Now, in order for us to actually have the enemy, or in this case, the ghost, to float, what we need to do is we need to select here our rigid body. And you see the first component, or actually the first, how can I say this? The first variable, or the first, whatever, you get the point. My brain is stuck. So this body type over here, the first thing that you see is it is set to dynamic. What we can do is we can set it, or click on it, and you see the drop down list. We have static, we have kinematic. We can set it to kinematic. Now what the hell is this kinematic? Well, kinematic, it will allow forces to affect this rigid body. So it will allow it, and we can apply forces, but it will not apply gravity to it, which means it will not start to fall down. So if I hit the play button now, and if I go into the scene, you see it is floating. Now it is not falling down. The reason for that is because gravity is not affecting our ghost anymore, and he can, you know, go like this forever. Later on, we will see how we can stop him from doing that. Don't worry about that. But the point is we have made him float. So now we made him float, and he's now floating and not falling down like he used to do. So this is how we can fix it. And if you're wondering what this static is, well, static is basically for a game object that you want to have a rigid body for whatever reason, but you don't want to apply forces and you don't want to apply gravity on that game object. Basically, that game object has a rigid body but is not movable. So that is what static is. Kinematic, forces can be applied to it, but gravity is not applied to it. And dynamic, you know, it has gravity and all of the other stuff. So I'm going to click here, overrides. We're only going to do this for the ghost. We're not going to do this for the enemies because the enemies are going to walk. So they are going to walk, and that is totally fine. The only thing that we are going to do now is, let me just turn off monster script for the ghost, just so that I can see one thing, and that is how high I want to set the ghost. So because we want our player to be able to jump over him, and at the moment he's not able to jump over him. So what we are going to do, I'm going to lower him a little bit more, something like this, and I believe this is, yeah, so this is how we can make our ghost, or how we can make the player jump over the ghost. So what we need to do is we need to take the ghost and lower him a little bit, so down, something like this, because also one thing to notice is that all the changes you apply during gameplay, so when I press the play button and now it is applied, any change you apply right now to any of these game objects, they will not be valid when I turn off the gameplay. So for example, I can take the ghost and I can remove his box collider, which if I go over here and select the ghost, he doesn't have the box collider. It is disabled, as you can see, but when I, unpause the game, you can see it is enabled. So any change you make during gameplay will not be applied, so you need to apply it or change it again when you unpause the game, or basically stop it. So I am going to lower him just a little bit more, something like this. I believe this is enough, because the player can jump over him. We want to make him, or make the player jump over the ghost, or otherwise he will kill him every single time when he passes by. And also don't forget to enable the monster script, and also hit apply, so on overrides, and hit apply to apply changes to all the prefabs, or just to the prefab of the ghost. So there you go. And for the enemies, they can stay as is because we are going to spawn them. So we are going to spawn them, and then when we spawn them, they are going to land down. They're going to fall down because gravity is affecting them, and you can lower them a little bit down if you want to, but as I said, gravity is affecting them. There is no need to do that. We will spawn them, and then they will fall down and start running left and right. In order to put these monsters in the game, we need to create a spawner, and this is what every game does. And a spawner is not something like, a game object that I can right click and create a spawner. No, it's called a spawner because it spawns new game objects, in our case enemies, and we're going to create it with a simple script. Now before we do that, I'm going to right click over here and create an empty game object that I'm going to call spawner, because this is the spawner, and he's going to hold the script that we are going to use to spawn these enemies. Now also I'm going to right click on the spawner and create another empty game object that I'm going to call left, and another one that I'm going to call right. Now what we are going to do with the left one is I'm going to take him, and first I'm going to tag him so that I can see him here inside of the game. What do I mean by tagging them? Well, when you select the game object, for example the left one, what we can do is over here at the top, you see in the inspector, we have this cube icon. We can click on that. And when we click on that, we can, choose one of these tags over here. I can click on this yellow one, and there you go. You see now I have the left tag. It's being tagged, and I can see it in my game where it is. Because when it doesn't have anything, we cannot see it in the game. And in the game, I mean in the scene. It's not going to be visible in the game anyways. So over here, I'm also going to tag the right one. Let's put a red one on him, it doesn't matter, and I'm going to take the left bad boy and I'm going to position him over here, so somewhere around over here. Let's say -68. I believe that is enough, so -68. And the right one is going to be at +68, and there you go. Let me just see for the left one. Yeah, I set the position to negative. Let's take the right one, and there you go. When I say position negative, I mean on the y-axis, so that we can bring him a little bit down, maybe a little bit more down, something like this. So -2.73. So we can use this for this is for the ghost, because we want to spawn the ghost at that position, which is -9, so -2.95. This is going to be the position for the ghost, because we're going to use the left and the right as positions. So these are the positions basically where we are going to spawn our enemies, and we set them approximately over here. This is the right one and this is the left one. So from here is where the enemies are going to be spawned, and the ones that are spawned here are going to run towards this way. The ones that are spawned here, they're going to run this way, and that way the player is going to jump, avoid them, and yada yada yada. So let's go here inside of the scripts folder, right click and create a new C# script, and I'm going to call this bad boy monster spawner. And of course, wait for it to, create, and then select the spawner game object and attach the script on him. And let me just double click the script so that we can open it in Visual Studio. I'm going to tag the class here at the bottom, and I am going to give a little bit space over here so we can see what we are typing. So the first thing that we need are the enemies or the monsters that we are going to spawn. So I'm going to create the serialized field because I want to create a private game object array, and this is going to be our monster reference. Now, why monster reference? Because we're going to create copies. We are going to create copies from these game objects over here that you see. So enemy 1, 2, and ghosts. And I'm going to delete them from the hierarchy, so we don't need them. Instead, I'm going to select the spawner, and over here we have the monster reference. Currently, the list is empty. I'm going to go into prefabs and select enemy 1, 2, and the ghost. But before that, let me just select the spawner. And you see, we can drag them like this. We can drag one enemy, so we can drag it over here. Then we can drag this enemy over here. But this can be tedious. How? Imagine that we have, let's say, and over here I'm going to say 0. Imagine we have 100 monsters in our game, and we need to drag them one by one. That will not work, as you see. So what we are going to do is we are going to select the spawner. You see, select the spawner. And when you select him, over here in the inspector tab, at the top right, you will see this small icon which represents a lock. Click on it. What this will do is it will lock the inspector panel on the spawner game object or any other game object that you have selected while you click the lock icon. So now if I click on the right, the inspector panel will not show me the properties of the right game object. Or if I click on the player, it will not show me the properties of the player. So I have locked it, which means now I can select the enemy 1, 2, and the ghost, and simply selecting them, I can drop them over here, and all 3 are dropped at once inside of this array. And now since I have done that, I can simply uncheck this lock icon, unclick it, and there you go. So now when I click on the player, it will show me the properties of the player. When I click the spawner, it will show me the properties of the spawner. You get the point. Now, we are also going to do the same thing for the positions. So over here, I am going to create a serialized field for private transform, and this is going to be left position and right position. So let's go back and do this for both of them. So we have left and right. And here is left, so here is the position, and here is the other position, and there you go. So we have the left position, we have the right position. The next thing that we need is a reference to the spawned game object. So I'm going to say here, private game object, spawned monster, and we will see what I am going to do for that. And the last 2 things are private int random index and a private int random side, because we need to determine on which side we are going to spawn the enemies, left or right, and we also need to determine the index of the spawned monster. And all of this is going to happen in a coroutine. So I'm going to create IEnumerator. And why a coroutine? Well, because we can call it over an interval of time, which means that we can call it over and over again every 5 to 10 seconds and so on and so forth. We will see that in a moment. So I'm going to call this one spawn monsters like this. There you go. And what I'm going to do in this coroutine is first you're going to say yield return new wait for seconds, and then we are going to set the seconds to be random range. So random range between 1 and 5. So between 1 and 5 seconds every single time we are going to spawn new monsters. And over here I'm going to say start coroutine, passing this over here, and there you go. As I said, we are going to call this in a random interval, so between 1 and 5. So every time this random range is called, it will give a number, random number between 1 and 5, and this is how many or how much time we're going to wait until we spawn a new monster. So in order to spawn a monster, we're going to say random index is equal to random range between 0 and monster reference, so monster reference dot length. Because this is going to give me, and we talked about this and we saw how we use this in arrays, so using arrays. So we're using random range, which will give us a random number between 0 and the array's length minus 1, which means the array will not go out of bounds, so we will not try to access an element that doesn't, on an index that doesn't exist, and we will randomize those enemies every single time. Also, our random side is going to be equal to random.range, and we're going to say between 0 and 2. So now what we are going to do is I'm going to say spawn monster is going to be equal to, we are going to call a function that's going to create a copy of our monster. So we're going to call instantiate, and we are going to pass the monster reference, which is this bad boy over here, and we are going to pass the random index inside of the square brackets. So every time we call instantiate, it is going to create a copy, and if I hover over, you see, actually we don't see, so we don't have an explanation, but anyways, the instantiate function will create a copy of a game object that we pass it here as a reference, and we are passing it the monster reference array and the random index, meaning it will return either 0, 1, or 2 because we have 3 enemies over here, so 3 monsters. So it will either return, enemy 1, 2, or 3, depending on the index. If index, random range, or random index is 0, it will return the enemy which is at index 0, and so on and so forth. So now we have the monster and we have the random side. So now we are going to test if our random side is equal to 0, because we are using here a random index, you see, random range, to determine the random side. So if the random side is equal to 0, this is going to be our left side. Else if, or simply else, if it's not equal to 0, then we are going to be on the right side. This is how I'm going to determine if I'm going to spawn the enemies on the left or on the right. If we are on the right side, I'm simply going to say spawned monster dot transform dot position is equal to left position dot position. So remember, in our game, we set the left game object to be over here. So we are using its position, which is this one right here that you see it on screen, and we are setting the spawned monster that we spawned over here. If the monster or if the random side is the left side, then the position of that monster needs to be on the left over here, which means the monster is going to come from the left and go to the right side. And next, what we are going to do over here in the monster, we set the speed to be equal to 7. We're going to delete this. We don't want it like this. Instead, here in the spawner game object, I'm going to say spawned monster dot get component, and we're going to get the monster component from it, dot speed, and we're going to set that to be equal to random range between 4 and 10. You see what I'm doing here? This is why I set this float to be public. Now, of course, the speed can be private and then we can use accessors, but as I said, that is a general rule in programming, but it doesn't apply every single time. There is no need for us to create a public or actually a private speed underscore speed, or call it underscore speed, then create a public accessor float speed, and create a getter and a setter. We don't need to do that. Simply, we don't. So this is also, sometimes you need to simplify code, even though it doesn't follow the official conventions of all programmers, and true programmers have died now for me saying this. Anyways, you get the point. This is why I set the random speed or speed to be public. So now we're setting it to the random range between 4 and 10. Else, if we are on the right side, meaning the monster is spawned on the right side, I am going to copy all of this, and I am going to set his position to the right position. So this time he is not on the left position because now he is spawned on the right side. And I'm going to set his speed to random range, but I'm going to set a minus in front of it because it's going to be a negative number. The reason for that is because if the value is positive, it will push the monster to go from here to here in this direction, from left to right. But when we spawn the monster on the right side, we need him to go from right to left. And we know in the coordinate system, I have explained, we have the, x and the y. So this is the x coordinate, this is the y coordinate. On the right side is the plus, which means the positive. On the left side is the negative. Similarly for the y, up is positive, down is negative, which means if we want our monster to go from right to left, meaning going to the negative side, we need to set over here minus in order to, make him go to the left side. The last thing over here that we need to do is we need to set the rotation, or the monster needs to face the direction where it is going. Because if I spawn the monster, any monster, if I spawn this one on the right side and he needs to go to the left, this is how it will look like. I'm not going to demonstrate that because the default orientation of the monster is right, or looking, to the right side. So if he is spawned to the right side and going here, he needs to look, at that, he needs to look left. So instead of, we saw the example with the player, we used the flip, and we flipped it like this. So for the player, that is what we're going to do. But for the monster, I'm not going to flip it. Instead, I'm going to use the scale and set it to -1. You see now, and when I set the scale to -1, then it is going to flip that. So it is going to flip the monster. So I'm going to say spawn monster.transform.local scale, not local Euler angles, but local scale is equal to new vector 3 -1f, 1f, 1f. So -1 for the x to flip him, and 1 and 1 for the z and the y. Okay, we have everything. We're calling start coroutine in the start function. Let's test it out. We have the monsters. Here is our spawner. We have the monsters attached on it. There you go. We have everything. And if I hit the play button and go inside of the scene, we will see one of the monsters soon being spawned. There is it. There is it. One monster is being spawned, which is the ghost. And there you go. So now he's going to come over here. Here he is. And we need to jump over him. And there you go. And all of the good stuff. And yada, yada, yada. But we have one issue. Let's try it again and you will see what the issue is. So let's try it over here. Let's see the monster that's being spawned. There we go. Another monster is being spawned. And also look at the monster. It has, so we have two issues that we will fix. Do not worry about that. But notice, we only have one monster. There is no other monster being spawned. What is the issue? First, I'm going to clear that issue. Then we're going to clear the issue of the monster getting stuck over here and why he is not moving. Well, the issue is that we're calling the coroutine only once. You see, the coroutine is being called only once. And when that is the case, well, what we can do. So what is the solution? Well, we can do this. So we can go over here and I can select everything that I have over here. So I can copy all of the code inside of the coroutine and I can put all that code in a while loop. So while true, we are going to put all that code over here inside of that loop. What this will do is it will basically run forever. And I know that I said when we talked about loops, especially while loop, and I said that the while loop needs to have a condition that sometimes will, that eventually will come to be false, or otherwise this will run forever and it can block or crash your computer. But in this case, because we're calling it in a coroutine and we have the yield return statement, every single time the while loop is being called, and let me just see where the while loop, so here I'm going to say while. So while loop, so that we know where the while loop is. Let me explain how the while loop actually works. So when the execution enters the while loop, so it enters, it will execute all the code that's in the while loop, and when it reaches the end, so when it reaches here, the end of the while loop, it will then revert and go back over here and again execute all the code that's inside. That's why it's important, as I said when we talked about it, that's why it's important to have a condition that will eventually come to be false. Because the while loop is very fast. It runs very quickly and runs, you know, if you put it in an update, or basically when you start it in the start function, it will run forever. Update function runs on a while loop. You know, every update function in every program, it runs on a while loop. So it runs forever and it runs pretty fast. So if you don't have a condition that will eventually come to be false, then you can have issues. But why am I putting this now in a coroutine? You're going to say, teacher, you're crazy. Listen to yourself. Do you hear what you're talking? I hear myself. I know I'm crazy, but that's another topic. What is the catch over here is we have this yield return statement, which is a coroutine. So we are in a coroutine. This means that every time the while loop goes back, so it reverts back to execute all of the code, the first line that it will execute will be this yield return. And it will wait. It will not continue to execute the code that's down below before the return, before this wait is over. So, and the wait is either 1 or 5 or in between. So it basically, the wait second is either 1 second, 2, 3, or 4 or 5 seconds. So we will wait that time before all of this code gets executed. And that's why this while function will not be heavy. It will not crash your computer because it is not executing this whole code every, you know, second, every frame. No. It is waiting this many seconds that we specified, and then it is executing this code. But if we didn't have this statement, if you just create a function, which is not a coroutine, and you don't have the yield return, and you just put this code in a while loop, then it will crash your computer. So that is the difference. That is the difference because a coroutine needs to wait. So now we have a while loop that is set to true, which means infinity. It will run over and over and over again. We can go back in our Unity editor. So let me just go back and wait for it to compile and all of the good stuff. There you go. So when I hit the play button, we will see the monsters being spawned and over again. You see they're being spawned, and again, one of the monsters is stuck. I will talk about that. You see the other monster pushed him, and yeah, there you go. You see the other one is stuck again, and why don't we have a monster being spawned from the right side? For some reason, every single monster, there you go, one is spawned on the right side. Now, before I, wrap this up, what is the issue over here? Why are the monsters being stuck? Well, if we go over here, for our grounds, we set all of the grounds to have a collider. So they have a box collider, and also the monsters, they have a box collider. What is wrong? So when I select the enemies, they have a box collider. Well, the issue over here is that sometimes you can see that these box colliders can get stuck on each other. I don't know what is the reason, do not even ask me. So what we need to do is, instead of having box colliders on the enemies, I'm going to click the enemy, the prefab one. So we have the prefab. I'm going to click on it, and then I'm going to click here, open prefab. So open prefab, now I can edit this prefab. Instead of having a box collider, which I'm going to remove, I'm going to attach a capsule collider 2D. So search here for the component capsule collider 2D. There you go. Of course, we're going to resize it. So I'm going to click. First, I'm going to click here on these 3 dots. You see here these 3 dots that you have on the component. You can click on those 3 dots and you can rearrange where the components are in the hierarchy. So I don't want the capsule collider to be below the monster script. I want it to move it up so it's above it. And yeah, it can be below the rigid body. I'm going to click on Edit Collider for this capsule, and I am going to move it here and here and here, something like this. I don't care about the top, and this is that. So now that we have a capsule collider, monsters will not be stuck anymore. We're going to do the exact same thing for enemy 2 or monster 2. So select it, remove the box collider, and then attach a capsule collider 2D, and click on the 3 dots, move it up. Click on the Edit Collider and move it over here. There you go. Move it over here. There you go. Move this a little bit here. There you go. And click on the Edit button again, and voila, it's finished. Also, do this for both players because they can get stuck as well. So I'm going to remove the box collider from the player, and I'm going to click on Open Prefab first and go over here and select it and click on the edit, and let's go and edit the player's collider. There you go. For the feet, just move it a little bit here. Click on the edit button and voila. And do the same thing for player 1. So now we are going to avoid player 1 getting stuck and any of the players actually getting stuck. Again, capsule collider, again, move the component up. So move it up, there you go. Click on the edit button. This is perfectly arranged on this one. So I'm just going to move the one for the feet a little bit up. And that's all there is to it. There you go. So now the enemies will never get stuck. So even if I hit the play button, even if I hit, like it's, you know, that's important to even if I hit, you see now, every single time they are spawned, they will never ever get stuck now because they have a capsule collider, which is a bit different. And don't worry about this. You see enemies colliding with each other and having the player here. This is going to, you know, when the enemies touch the player, they're just going to, you know, destroy him. Don't worry about that. But the issue that I want to show you now, or actually the issue that we fixed, is that the enemies are not getting stuck anymore. What is you been cracking, my gangster? Now going back, what we need to do is, we have a few issues. So let's hit the play button and see those issues that we have. The first and obvious one is that when the player is colliding with the enemies, you know, basically nothing is happening. You know, the player is not being destroyed, he is not being killed. As you can see, bam, 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 you know, they're hugging now the player. It gets into a weird twist. I don't know, some kind of, you know, I don't want to say what is going to happen, but you get the point. So we do not want that. In order to fix that, what we need to do is we need to go inside of our script for the player. So let's go into the player script, and here we have on collision enter 2D. What we need to do is we are simply going to test if our collision.gameObject that has this collision. So basically collision 2D is details returned about by 2D physics about the collision callback. This is basically it. So we talked about this function and we said that here is the information about the other game object we have collided with. Now from the collision we can access that game object, and then we can say again compare tag, and this time what I'm going to do is at the top we are going to create another tag. So currently we have ground, but now I'm going to say private string enemy tag, which is going to be equal to enemy, like this. I mean, it's simple. How else I'm going to call it? So over here, I'm going to put that tag and I am going to compare it. So if the game object we have collided with has a tag enemy, then what? What we are going to do? We are going to destroy the game object, which is the current game object. Who is the current? This is the player game object. So this game object, see the game object, this component is attached to. You see when I hover over it says the game object, this component is attached to. And this script or component is attached on the player game object. Now we're going to have one more issue when this happens, and you're going to see what that issue is. And then I'm going to show you another way how we can detect collision, and we're going to implement that on the ghost. So let's go over here into the scene. And yeah, by the way, the tag enemy is not, you know, defined. It's a good thing to define the tag. So there you go. Let's go over here and make sure that you type enemy, and there you go. Also, because I'm stupid, we need to go and select the enemies and the ghost and tag them over here with the enemy tag. Otherwise, as you can see right away inside of the console, we got an error because the enemy tag, which is the one over here, which is this bad boy over here, was not defined. And the same rules apply. So this, you know, the signature, capital E, enemy and everything, so needs to match up with the enemy tag that we added over here, or otherwise no works. So let's see the first issue that we have. Let's wait for the enemies to spawn. There is one enemy. He is going towards the player. He's rushing and come on, and the other one has reached him. Notice now when he touches the player is going to be destroyed. Bam. And voila, you see, we have a problem. Now, what is this problem? It says over here, the type or the object of type transform has been destroyed, but you're still trying to access it. Where does this happen? Notice here, you need to learn how to use the console. In the asset store, there are also more powerful consoles than this one, but this one is also pretty good, but you need to learn how to use them. So basically it says here, when I click on it, it points over here where the error is, and the error is in the assets, scripts, camera follow script on line 26. So we need to go back into the camera follow script, which is this one, and on line 26, which is this over here, it's trying to access the player position, but we have destroyed the player. Because over here, when he collides with the enemy, we have destroyed him. And that is the issue. So how can we fix that? Now, this is going back to classes and objects. And again, let me just explain. So you have a class over here and you create an object from this class, and you can create another object from this class. Now, these two are references. They are references. So here you have, for example, variable P1, which is pointing to this reference, and you have variable P2, which is pointing to this reference. When you destroy one of these references, so you destroyed this one, P1, so P1 now is equal to null. It is not pointing anywhere. So it's not pointing anywhere to no reference. And this is what happens. This exactly, the error that you just saw happens because we are not pointing, or this, for example, in this case, which is this player transform, it gets destroyed. So this player variable is left without a reference. It's null, it's empty. That's why you get an error here. So how can you fix this is you can test over here if, and over here I'm going to use an exclamation mark, and I'm going to say player, and then I'm going to say return. Now, what the hell is this, teacher? You are confusing me. How can you use an if statement? Well, basically what I'm asking over here is if player is not equal to null. To demonstrate that, I'm asking here if player is not equal to null, or actually if player is equal to null, then return. This means if the player reference, which is this one over here, if it's pointing to null, which will happen when it gets destroyed over here, that means return. What does happen with return? Teacher, you said that only function that return a value can have a return statement, but over here you have void. Let me explain what will happen. In a void function, when you use a return statement, what will happen is when the code enters in this function and it starts executing, it will first execute this line of code, and because this is an if statement, it will test the condition. So it will test if the player is equal to null. If it's true, it will hit this line. If it's not true, it will continue to execute this line, then this line, then this line, then this line, then this line, this line, and at the end, this line. But if this is true, so this turns out to be true, and it hits this line, automatically it will skip all other lines, it will go till the end, and it will exit outside of this function, and then of course it will return again and repeat the same process. So in a void function, when you use return statement, it will simply not execute any code that's below the return statement. So any code below the return statement will not get executed if return statement is executed in a void function. This is in a void function. And also in a function that returns a value. For example, if you test for something and if that is true and then you return the value here, even if you have, more lines of code below, they will not be executed. So this is what the return statement does. And over here, instead of me typing if player is equal to null, we can simply add an exclamation mark in front of it. The exclamation mark will make what's after it the opposite. So essentially what we're testing here, again, even if we don't use, pay attention over here. Here we're testing if we have a player, meaning if we just leave it like this, if player, it's the same as if we have typed if player is not equal to null. So basically these two statements are exactly the same. So here we're testing if player is not equal to null, meaning player has a reference. So this player variable has a reference. If we add an exclamation mark in front of it, then we are asking if the player is null, meaning the player doesn't have a reference, because it will test if player doesn't have a reference, and if that is true, then there you go, it will, hit the return statement. Basically, again, essentially what we're asking over here with the exclamation mark, because it will make what's after the opposite, we're asking if the player is equal to null. And if that is true, there you go, it will hit the return statement. Now, if we are asking, if we say here, if exclamation mark true, now this will be false, because exclamation mark makes what's after it the opposite. And if we say exclamation mark false, then this will forever be true. And there you go. So this is what we are doing here. Again, if something is not clear, just ask in the comment below, but don't worry, many other examples of this will come. So now if I go back into Unity, we will not have this null reference exception when the player gets destroyed, because now we are asking, is player null? If that is true, we will hit the return statement and, we will not execute anything that is below it. Now, what I also want to show you is, pay attention now, when the ghost touches the player, there you go, player has died, and notice we don't have the null reference exception anymore. But what I want to do is with the ghost, because the ghost is floating, there is no need for the ghost to have a solid body. Meaning I'm going to select the ghost over here in the prefabs, and for his box collider, I'm going to check this is trigger checkbox. So make sure this is checked. So I'm going to check it. And what's going to happen now is that we need to go in the player class and right below on collision enter. And this is another way how we can test for collisions. Over here, I'm going to check on trigger enter 2D. It also has a collision. Basically, it's a collider 2D, but also named collision as a parameter. And we can do the same thing. We can call over here. We can say if collision.gameObject.compare tag to the enemy tag, and then we can do the exact same thing. We can call destroy our game object. Now, the collision tag or the collider tag parameter or the collision collider 2D game object, it can access compare tag right away. So we can simply call compare tag on collision itself, whereas we cannot do it on collision 2D, but on collider 2D we can do that. Now also one thing that I want to show you is inside of an if statement, if after it we only have a single line of code. You see over here we have an if statement like this, and then we only have one single line of code. We can omit curly brackets. So we can omit them, and this is totally fine, it will work. If, however, we have one more statement below it, for example, gameObject.tag, and we are going to change the tag to WE, this right here is not part of this if statement. Instead, we would have to put it inside of these curly brackets like this, and now this will be part of the if statement. So if after the if statement we only have one line of code, we can omit curly brackets and only put one single line of code below it, and then it will execute. So we can do the same thing over here, and we can do the exact same thing over here. So now we have on trigger enter, and in order for this to work, so in order for on trigger enter to work and for us to detect collision in it, one of the colliders we are colliding with needs to have this trigger checked. So let me just scroll down a little bit. So is trigger, you see it needs to be checked. So again, let me just get it, not highlighting the mouse. So is trigger checkbox needs to be checked in order for us in the code for this on trigger enter to be executed. One other thing that I'm also going to tell you is in order for us to detect collision in Unity, one of the game objects needs to have a rigid body. Try making two game objects without a rigid body collide with each other and see if these, if the collision will be called. Anyways, now let me go over here and hit the play button. We will notice that now when the ghost touches, and I'm going to delete the enemies who are not the ghost, hoping that the ghost will soon turn out, just so that we can see. Come on, where is the ghost? Where is the ghosty ghost? Come on. I hate it, when I want to try it out, it never happens. You see, where is the ghost? Still no ghost? Finally, there is the ghost. Come on. So now you will see that when the ghost touches the player, and here is the ghost, pay attention now, bam, same exact effect. The effect is exactly the same, but the only difference is that the ghosts collider with an S, denoting that the collider is, from the ghost, is a trigger. That's all there is to it. And a trigger is not a solid collider, so things can pass through it. So even if we don't use this line of code, now the ghost game object will simply pass through the player. But we have one issue. We have an issue now with other enemies. Pay attention over here. Other enemies can obscure each other when they collide, or when they clash with each other, when they touch each other. You will see that. So just wait for another enemy to be spawned on the right, because now you will notice that my ghost is a solid game object, and it simply went through the enemy. But these two enemies, they are solid. Notice now, they are solid. They cannot pass through each other, and look what is happening, you see? So now they have an issue. They're not passing through each other, and this is the difference between a trigger and a solid game object. You see, solid, it's like a wall. But notice now the trigger one, you see, the trigger is not solid, and he passes through solid game objects. How can we fix this issue with a solid game object? Well, for that, we need to go under Edit. So click on Edit, and then Project Settings, and then go into Physics 2D. And next we need to scroll over here where we have the layers. And what are these layers? Well, basically they are the collision layers that we have over here. You see this one layer, and it says that currently we have a default, but when we click on it, you see we have transparent, raycast, blah, blah, blah. But we can also click on Add Layer. And we can also click here to create a new layer that I'm going to call Enemy, and I'm going to hit the Enter button. And let me just go back over here and refresh now the Physics 2D. So now you will notice that inside of Physics 2D, we have an enemy layer, an extra layer created over here. So what's the deal with this layer? The deal is that here inside of this Physics 2D, over here for the layers, we can specify which layers can collide with each other. You see, the checkbox is checked on every layer, which means every layer can collide with every layer. But over here, if I hover over on this one, you see now, you will notice that it will say enemy/enemy, meaning this layer with the enemy layer. See, here is the enemy layer, and here is the other enemy layer. So it is basically telling us, the checkbox is telling us that the enemy layer can collide with itself. It can collide with the enemy layer. Well, I'm going to uncheck that checkbox, which means now every game object that is put on this enemy layer will not collide with another game object who is on that same layer. So now I can simply take the enemy 2 and 1 and even the ghost, and I'm going to set them from default layer to the enemy layer. So simply change their layer from default to enemy. And now look what is going to happen. So I'm going to hit the play button. And now when two enemies collide with each other, you will notice, and you saw that, we saw a moment ago, pay attention, this one is going to pass. You see, he passed through him. Of course, the ghost is going to pass through every game object because he's not solid, he's a trigger. But now these game objects, for example, look at these two, they just passed through each other. Now look at these two, they're going to pass through each other, and the red one is going to pass through both of these green ones. And over here, see, simply they're now passing through each other because we have denoted over here in the physics system, okay, the enemy layer should not collide with the enemy layer. So the physics calculation between them is totally ignored, and we cannot, even if we have any code that will detect that, it will not run because they are on the layer that is set to not collide, with itself. And this is how we fix this issue. Of course, if something is not clear, make sure that you ask in the comment below. Moving forward with the issues that we have, this one is an interesting one, and that is what happens with the monsters who the player jumps over. So for example, now we see the ghost is coming over here and the player will jump. Well, I didn't get to jump, but you get the point. Anyways, what I want to say is when he goes out of bounds, let's pretend that I jumped over him, so he goes out of bounds over here. And same as these that will go out of bounds over here, you see? And forever they will go out of bounds, notice. And even these players, or actually these enemies, the zombies, they will start to fall down. Notice now, they will start to fall down because they have gravity affecting them. You see, they're falling down, and you get the point. What's up with them? What can we do? We don't want to keep them in the game because now they are out of bounds, out of the reach of the game. Even they are inside, we cannot reach them because, the camera will follow the player up to here. approximately, it will not follow him outside of that. So what we can do is we can create an empty game object that I'm going to call collector holder with capital C. And I'm going to right click and reset his position. And I am going to create another empty game object. This one's going to be left collector. And you can assume that I'm going to position the left collector over here. What the hell is this, teacher? Well, I'm going to attach a box collider on the left collector, and here is my box collider. Now, what we can do with a box collider that you already know is we can click on this edit button and we can resize it like this, as you can see, and there you go, and yada yada yada. But we can also resize him over here, so we can set offset and everything should be okay. So 111. But what I can do is I can resize him over here. You see, like this. I can resize him on the size property that we have over here. There you go. So I can simply take his Y and I can resize it and maybe just a little bit lower the X, something like this. And there you go. And I am going to position him somewhere around here. There you go. So this is where I want to position him. This is the left collector. And I'm also going to make sure to check the is trigger checkbox, and I'm going to duplicate it with Command D or Control D on Windows, and this one is going to be the right collector, so right. And I'm simply going to, instead of minus, so negative 72.7, I'm simply going to remove the minus, which will simply bring him over here, and voila, that's all there is to it. Now let me just see, the left one is, I think, is a little bit closer. I don't think so. Maybe we can move a little bit here, just a little bit closer, maybe negative 72 exactly. There you go, negative 72 exactly, and this one is going to be at 72 exactly, so the right one. There you go. So what are we going to do with them? Why is this important? Well, let's go now inside of the scripts and right click and create a new C# script. I'm going to call this one collector. You saw the movie The Collector. This is not that guy. He's not going to, steal your ribs and, put some deadly traps. Not that collector, but this collector over here. What we are going to do with this one is that we are simply going to say void on trigger enter 2D, because we check the checkbox to be a trigger, and simply we're going to say if collision.compare tag, not composite. So collision.compare, what did I type? Compare tag, here it is. And I can put here the enemy tag, there you go. And again, we can either create a variable over here, which we will do because we're also going to have, or if you have the on collision enter instead of on trigger enter. So if you have on trigger enter, you would put a private string, enemy tag, and all of the good stuff. We already discussed this, but over here I'm going to leave it as is. And then if that is true, I'm simply going to say destroy the collision.gameObject. Now this time I'm not going to destroy the game object itself. So I'm not going to destroy the game object, meaning simply game object like this, which is referring to the game object this component is attached on, which in our case is the collector. No, instead I want to destroy the collision.gameObject, meaning the game object I have collided with, which in this case is the enemy because we're comparing the tag with the enemy tag. That means we want to destroy the enemy. Now we can do the same thing with the player because the player can also go out of bounds, but let me just show you first this. So if I go back now inside of my editor and wait for the scripts to compile, you will notice now when the enemies reach the collisions, or the collision game objects. So they are spawned, as you can see, there are the enemies, they are going and yada, 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 all of the good stuff. Maybe we can take the right one and position it a little bit, the collector is for some reason not, the collector holder is for some reason not positioned correctly. But anyways, it's not important. Notice now, bam, you see, he is out of bounds and he is destroyed. And all of these over here, you see now, look at that. Bam, he is destroyed. And there you go. Let me just see the collector for some reason. Is he positioned correctly? Yeah, yes, he is. But yeah, it doesn't matter. Anyways, what we can do is we can take the right one and maybe position a little bit closer. That's all there is to it. Nothing else. So anyways, you saw that when the enemies reach the collector game object, they are automatically destroyed and they are no longer inside of our game because, you know, it's only logic. We do not need them in the game since they are going out of bounds, because beyond this point, they will be out of bounds, out of reach, we cannot reach them, and so on and so forth. So just as a one more reference, I will show you that. So there you go. You see when this one reaches the collector, there you go, the green line, bam, he is destroyed. Again, destroyed. So there you go. Now, as I said, we can do the same thing with the player because essentially the player can go out of bounds. If I go back over here and if I try to run, you know, if I try to jump, let's try to jump and avoid the enemies, and yeah, I cannot avoid them. But anyways, you get the point. If I try to jump and reach this end over here, I can potentially go out of bounds. And we can, let me just take the spawner and turn him off so that we don't have enemies, because for some reason I'm not that good at this game. So I can potentially reach, even though the camera will stop following me, but I can reach out of bounds. You see, I can reach these bounds. You see where I am. Look at where the player is. And I can, if I go over here, see, I am out of bounds and the player is, you see, he is over there. But of course, later on, we are going to add buttons. As you saw in the preview of the game, we're going to add 2 buttons to restart the game. We can do that as well. But if you want, and that would work, I'm going to turn on the spawners. If you want, and as I said, that will work as well, you can also over here, you can add another line of code. And I'm going to do that just to demonstrate the use of OR. Remember the OR pipes that we used, and they are over here. Or if collision compare tag is player tag. So if we collide with the enemy tag or the player tag, we're going to destroy the game object. This is a shortcut. Instead of us typing over here, if collision compare tag is colliding with the enemy, just imagine that we don't have this. And then over here, we would use, you know, collision compare tag with the player. Instead of typing all of this, we can type it in a single line of code like this. And remember, this was a lecture about if statements, and this is the reason why I implemented, just to show you that implementation and explanation. So if we collide with the enemy tag or the game object that has the enemy tag or the game object that has the player tag, we are going to destroy them. Even though for the player it's not mandatory, I've explained why, but you can do it like this and it will work the same way as it did for the enemies. Yo, game dev gangster. So the next step, since we have everything working basically, we are now going to create a main menu. And in order to do that, we are going to go here in the scenes tab. You see, we have one scene which is called gameplay, where all of the cool action, everything what we did so far is happening. Now we want to go into the boring part where we have the menu. So under file, I'm going to create new scene. So again, it's under file and then click on new scene. And we want, you see this one, basic 2D built-in. So this is what we want. It contains an ultra-graphic camera setup for 2D games. That's all there is to it. So simply double click on that and this is what we want. Now, this is an untitled. Basically, we still didn't save it in order to give it a title. So I'm going to Control or Command S on Mac, and it's Control S on Windows. If you used any basic program, you know how to save anything in that program. So in the scenes folder, I'm going to save it and I'm going to call this bad boy main menu. Now, before we can proceed and do all of the good stuff, first I'm going to introduce you to Unity's UI system. Now, in order to create any UI element in Unity, you are going to right click and go under UI. And when I say right click, I mean in the hierarchy, and then go into the UI. And here are different UI elements that you can have. So text mesh pro, image, raw image, button, blah, 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 blah. I'm going to show this example with an image. And when I click on image to create it, you can see this gigantic thing is created over here, which is basically the canvas, because every UI element that you create must be a child of a canvas. Because pay attention over here, I clicked to create an image, but actually a canvas was created, an image was created, and this event system was created. So what the hell is this? Don't get confused. As I said, every UI element needs to be a child of a canvas. And since we didn't have a canvas, didn't have. So there you go. I'm also an English teacher. So we didn't have a canvas previously in the game or in the scene. That's why it created a canvas. If I were to go right click right now and create, for example, another image, it's simply going to add it as a child of the existing canvas. That's all there is to it. And this event system is basically a game object containing all of these scripts that allow us to detect input on the UI system. When we touch a button, even when we touch an image, when we touch a text object, so on and so forth, so they are created automatically. Now, what's important over here, before we dive into the image and some, UI examples, the canvas game object controls how the UI elements, look like. What's important to know when it comes to the canvas game object, when you select it, is this canvas over here that you have, the canvas component. Now over here we have something called render mode, which currently is set to screen space overlay. This means that it will overlay the screen no matter the size. You see where the image is? The image is at the bottom left corner. It's a simple white image, and I'm going to take it and I'm simply going to put it at the center by using 0, 0, 0. So now, no matter, as I said, which resolution we use, it will fill out that resolution. As you can see, I'm changing the resolutions, full HD, even in portrait mode. If I go into full HD, it's still going to, fill out that, it's going to fill out the whole screen. So this is when it comes to screen space overlay. When I say overlay, I mean it's going to overlay the screen. And what is weird, or what somebody or most beginners will find weird, is that this is the main camera. So this right here is the camera of the, of the gameplay. And when we add the player, this is where we see it. But this huge big thing over here, the other big rectangle, this is the canvas. So notice over here, this whole thing is the canvas. And this small thing over here is the camera. And yet when you go into the game view, this is what you see. It's not like, huge. So I'm not sure how this works behind the scene, but basically this is, screen space overlay. It overlays the screen. Now, one thing that is also important when it comes to the canvas is this over here, the canvas scaler. See here, we have something called scale mode, which is currently set to constant pixel size. What I usually do is I change that and I set it to scale with screen size. And then I enter my reference resolution that I use to create my game, which in most cases is 1920 by 1080, which is the full HD resolution. And I set here to match width and height to 0.5, which is equally. So basically what this means, when I create my assets, I create them like I'm creating a game for this full HD resolution. And I set the canvas scaler to this option, so scale with screen size, and then I put here 1920 by 1080 and match the width and height equally. Why is this important? Well, this is important because later on, when you ship your game on different devices, it will use this reference resolution. When I say on different devices, mostly this is concerning mobile, and I assume a lot of you guys want to, create mobile games. So when you ship your game on mobile devices, there are different screens, different resolution, different sizes. Well, when you create your game like this, it will try, or Unity will try to scale your UI assets to constantly fit your reference resolution and yet look very good on any other resolution where your game is being played. This is basically what it is doing. So next over here, we have something called screen space camera, which is the same exact thing as with screen space overlay, except now we attach the main camera here as the render camera. And notice here in the scene how the canvas is going to get small. There you go. We don't see the huge thing that we had so far. Instead, it is small, or basically it is the same as the shape of the camera. So if I select the camera and I select the canvas, they're basically the same shape, same width, same height, because now the canvas is set to screen space camera, meaning the camera will be the main thing that the canvas is using, and it will, draw all of its element within that camera area. And last but not, and everything that I talked about, the reference resolution 1920, 1080 applies to the, screen space camera as well. And the last thing is over here, world space, which basically we don't need it in a 2D game. Maybe you need it, but this is mostly for 3D games. And one on top of my head example is if you see a player or an enemy and you see a health status above him, for example, well, that's, if the game is created in Unity, then this is what is used. So the canvas is used with render mode world space, and then you can basically have your canvas within the game's world space. And the world space is this in the scene that you see. But as I already said, you don't need this for a 2D game. I mean, maybe somebody will say, well, teacher, you can actually, I don't know. I never used it in a 2D game, but usually in 3D games where you have a 3D space, you can utilize this. But anyways, yeah, that's why I cannot show you this directly, how to use it. But anyways, what I usually do is I use screen space camera, and then I attach the main camera by simply dragging it. So selecting the camera and simply dragging it here to be the main camera. And that's all there is to it. And then I set the reference resolution 1920, 1080, match width and height, and voila, there you go. So now we can go over here and finally talk about our image. So when it comes to the image, if I go over here, the first thing that you will see, and let me just, you see when sometimes this happens, you don't see the grid layers. What I do is I change the layer to default, and then I go back to my layer. And let me just change the free aspect to full HD, and voila. But again, we don't have it. Anyways, it's not important. Let me just talk about, so over here, canvas and image. So what's important to know about the image is when you select it, you will notice one thing. That is, it doesn't have a regular transform component. It actually has a rect transform. And this rect transform has here anchors, pivot, and yada, yada, yada. It has other things as the normal transform. It has the position X, Y, and Z. It has a width and height instead of the scale, but it also has a scale right here. So you can change the width and the height of the image. For example, we can make it 500 by 500. And when we go here, you see how, large it is. But one thing, or the most important thing that I want to show you is this over here, this anchor preset. So when you click on this little, whatever this is called, this, rectangle or cube, you have these anchor presets, which basically will allow you to define the center of your UI element. What do I mean by center? Well, for example, currently you see it's set here at the middle center. If I set it at the top left corner, and if I position the image at 0, 0 for the X, notice it is using the top left corner as the center position for, for itself. So this is what I mean. Why is this important? Well, imagine that this image is basically, I don't know, let's say a health indicator. So it indicates how much health we have, and we want to position it over here, and we want it to be at the top left corner all the time, no matter which resolution we have. Well, then you simply select the anchor, you select the top left corner, then of course you move it where you want to move it, but it will use the top left corner as its origin position to position itself. So notice now, even if I move this, you see when I move the tab, resize it, and so on and so forth, it is still sticking at the top left corner, even if I change the resolution. There you go, another resolution, changing over here. No matter which resolution I change, even if I change it to portrait mode, you see it's still sticking at the top left corner because we told it by using these options, by simply setting this at the top left corner, setting the anchor. The same way, top right, middle, top, I don't know, left middle, middle center, right middle, bottom left, the same way. They work in that same way. So even if you want to set it over here, for example, just set the anchor and then move it where you want it to be, for example over here, and look at this. So now if I change it to full HD, again it is repositioning itself to the anchor, or closest to the anchor that we have specified over here. So these are the main points when it comes to UI elements. And of course, later on, don't worry, I'm not going to introduce every UI element right now because we will use them in our games, and don't worry about that. We will mostly introduce buttons in this part. We will use images, we will use text, we will use whatnot. But what's important to know is this. The anchor is the most important thing when it comes to laying it out, because prior to new Unity UI system, I say new, this UI system came out in Unity version 4.6, but before that, you had to code the behavior of your UI elements so that they stick at a certain position. But now with this, it's all about anchors. So that's why this is important. Of course, this same thing applies to any UI element, be that a text, an image, raw image, button, slider, toggle, scroll bar, blah, 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 blah. You get the point. So you get the point. It's the exact same thing. So don't worry. This is everything we need to know for now when it comes to canvases, images, working with UI elements, because we will explore them more in our games and so on and so forth. And yeah, if something is not clear, make sure that you ask in the comment below. Okay, my game dev gangsters, moving forward in the main menu, we now know what is a canvas and how can we use it. So we are going to reuse the canvas from the previous video. If you don't have it, just create a new one, right click and go over here under UI and create a simple image because we will need it for the background. And here you go. So then set the screen space to screen space camera or the render mode to screen space camera, drag and drop the main camera over here and set the scale mode to scale with screen size 1920, 1080, and that is that. So now what I'm going to do is take this image, and from the previous video, my anchor is about at the bottom left. I want to set it at the center, and I'm going to call this one BG because, you know, why not? Why not? I'm not going to call it Kenny, okay? So let me go here inside of the sprites folder, and I am going to take the background, which is this bad boy, and I'm simply going to drag and drop it here in the source image. And this is how you can, so simply select here, so take the background and drag it over here in the source image. That's all there is to it. Now, of course, it is too small. We can resize it, so I can do something like this to resize it, and something like this to resize it, and there you go. But what you can also do when you want an image, in most cases a background, to cover the whole space of the camera, you want to set here the anchor to stretch, which is this right here at the bottom right corner. So when you click on stretched, and you set everything here to 0, 0, 0. So this is for the left, right, top, and the bottom. And for some reason, it's giving me this number over here. I don't know why. Let's try over here. There you go. So now everything is at 0, 0, 0. It is always going to stretch on the, full, you see, even on free aspect, it is going to stretch. Even if I change over here to whatever, let's see over here, portrait, it is always going to stretch and fill out the screen that it is currently on. Of course, you should be careful which backgrounds you set like that, because some backgrounds might look really stretched on some resolutions, but of course that is all testing. So next, what I'm going to do is right click over here, and I am going to create another UI image, and this one is going to be the moon, and I am simply going to drag and drop the moon over here as that image, and click here set native size. So from the image component over here, you have this set native size, which will set the size of the image to the size of the sprite that I am using to represent that image. So when I click on that, you can see the moon has resized, and I'm going to set the moon over here at the top left corner and set his anchor at the top left corner as well. Now, of course, where you position him doesn't matter in terms of that will not affect the game. You see right here, it's enough. I love it. You should love it. Everybody should love it. And there you go. Next, what I'm going to do is go over here and right click and create a UI text. And this is going to be our game logo. So this, I'm going to call it game logo. And this is a new component that we didn't talk so far. But basically, if you worked with any text component, then you know how to work with the text component in Unity, because it has everything same as any text component. So over here, if you pay attention, you see this new text. It's the default text that you can put in. Of course, inside of the code, we can also change the text. We will not need to do that for this game, but we will do for other games. Do not worry about that. Over here, you have the font that you can select, which means you can import your own default font and then use it in your game. Over here, you have the font style, which is that thing you see, bold, normal, italic, blah, blah, blah. Here you have the font size, line spacing, alignment of the paragraph. You see over here, you can align it wherever you want to align it. You also have, a color property. that you can use to change the color of the text. Basically, as I said, like any other text editor. So over here, I'm going to say Monster Chase because that is the name of our game. And I am going to click here and choose the font. So when I click here, I can choose the fonts, one of the fonts that I have imported. And they are imported over here in the assets and then fonts. So these two, I have imported them. So what you can do is, as I said, you can either click on this little, circle icon. And if you didn't see it where it is, it's right here on the fonts, this little circle icon. There you go. And by the way, this little circle icon is also here for the image. So you can click on that and then search from all the images that are available in your project or in the scene. So you can do that as well. And what I'm going to do is I can also drag and drop here the font. That also works. I'm going to set here the font style to be bold and change the color to white. And that's all there is to it. Of course, we do need to align it over here. There you go. Set the alignment. I'm going to set the position X to 73, position Y to 307. The width of the text is going to be 1511. And the height is going to be 433 because I want to make the font size to 300 or 230. So this is what we see. This is our Monster Chase logo. And again, you can experiment, and I encourage you to do that because this is what I have been encouraging you to do so far. Make sure that you experiment. So experiment with these options over here. Try to change the font size. See what happens. Try to change the line spacing. See what happens. Of course, some things might have an effect, others don't, depending on other options that you set over here. But try, change the color. Do this, do that. That is the best way to learn. But these are the basic things. As I said, if you worked with any text editor, then the options are the same. They're not, not different. And then the last two things that I am going to do is set our buttons. So right clicking on the canvas, I am going to go under UI and create a button. And the button component consists, the default button component, it has an image that we can use, to represent the image, how the button is going to look like. It has a button component that will allow us to click on it. And it also has a text. The text, because if I, zoom in, this is the default button, as I said already. So I can resize it like this, you see, and I can take the text and I can, resize the text as well. And there you go. You see now I have a button. If I go over here, you can change the text to, play game, for example. So play game or simply play or whatever. So you can also do that. But for our case, I'm not going to use the text. I'm going to remove it. I am going to set the value or the name of this button to 0. And I am going to position him at negative 326 on the x-axis and negative 150 on the y, and the width is going to be 341 and the height is going to be 341. Now before we do anything else, I'm going to go into the sprites folder, and we have this player select, which are the buttons of the players. See over here, this is the player select, this bad boys. We are going to use them as buttons. So select them and go over here to single and change it to multiple. So give him a girlfriend, click on the sprite editor, slice the bad boy, click on the slice, and there you go. So here I'm going to say player 1 select, so select, and from here I am going to say player 2 select, there you go, and hit apply, and voila. So now taking this button, we can simply click on the drop down list for the player select, and I can drag player 1 select as an image over here. And now what I can do is I can duplicate this bad boy and change his name from 0 to 1 and simply change his position from negative 326 to positive 326 and drag and drop the other image for the player 2, and voila. So this is what we have. Even now, I can press on the play button even now, like we can do it before. And now I can, click on the buttons. You can see probably that the buttons are like, flingering, how this is called. This is because this is the effect of the button. This means we are pressing them. So we are pressing the buttons, as you can see. There you go. This is totally fine. This works, yada, yada, yada. You see, la, 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 la. Anyways, the point is that this actually works and we have created our main menu. Now that we have a working main menu, how can we actually navigate through it? How can we, go from main menu to our gameplay, same as any other game? Well, for that, as you can assume, we need to create a script. So let's go over here into the scripts and right click and create a C# script. And I'm going to call this bad boy main menu controller because he controls the main menu. Now, inside of our main menu, I am going to right click and create an empty game object that I'm also going to call main menu controller. And you're going to see in a second why we need a game object. So I'm going to drag and drop the main menu controller over here and double click it and open it over here. So here is my main menu controller. Let me just tag the class. And how do we execute, a touch of a button? So when we press a button in Unity, how do we execute, something? Well, let's see that. In order for us to be able to execute code, when we press a button, we need to create a function that needs to be public void. So the function needs to be public void, and then you can name it. So I can say play game. The function can only have one parameter if you need it. So if you need it, and that parameter can be a Boolean, integer, a float, and I believe a string and an object. But for this example, we don't need that, so don't worry, we will cover it in some other examples, but I'm just mentioning that out there. If you want to add a parameter, it can only have one parameter, it cannot have more parameters. So the signature of the function needs to be public void play game, so public void. And then I said play game, but actually the name of the function. And in order for this to work, how can we attach it to the button? Well, you select the button, for example, my 0 button. When I select it and scroll down inside of the inspector panel, you will see this. It says on click and it says list is empty. Now, what we need to do is we need to press this plus button over here at the corner. And when you press that plus button, you will see now that you have over here a field where you can drag an object. And that object is going to be main menu controller. So I'm going to drag it over here and place it, but we're still not done. Because what we need to do now is the main menu controller is here. We have dragged it from here. That is totally fine. But now we need to click here where it says no function, because now we need to select a function from the main menu controller. And when I click here, you will see the scripts that are attached on that game object. Now you see game object and you see transform. These are by default inherited, but you also see main menu controller. And inside the main menu controller, you will see this play game as well. So there you go. This is how we can select the play game function so that now when we press this button over here, this function will be executed. Of course, nothing is inside of this function, so I'm simply going to say debug.log, and I am going to say something like, so over here I'm going to say button is pressed. There you go. So button is pressed, and if I go back now and hit the play button, so when I click here to play the game and go inside my console and click over here, you will notice, bam, button is pressed, bam, button is pressed. If I press this one over here, it's not working because we didn't attach the function on this button. So if I click here, bam, button is pressed, again, bam, button is pressed. So there you go, there you go. This is how we can execute a function when we press a button. Now, one thing to notice is that we can have multiple scripts attached on the main menu. That's why over here, when you click on the drop-down list, you see different scripts that are attached. Among them, you see main menu controller. If you have more scripts, I don't know, whichever they are, maybe, level menu controller, maybe character menu controller, whatever, then you will see those scripts over here. And when you click on them, another drop-down list will be opened. And from there, you will search for the function that you have defined. So the function name that you have defined, in our case, play game, that you can see over here, which is this function over here. And then you select that function to be the function that is going to be executed when the button is pressed. And how you will know which function will be executed, you will see over here. So we are using main menu controller and its function called play game. So this is the function that will be executed when this button is pressed. Now for the second button, we are going to do the same thing. So I'm going to click here plus, and I am going to drag this main menu controller. And then from here, I am again going to select main menu controller and I'm going to select play game. So now when I press both of these buttons or any of these, you will see now, bam, button is pressed, bam, button is pressed. There you go. Now, one thing that you are probably wondering is, how are we going to know which character we have selected to play the game? And you already assume that when we press this button over here, the left one, we are going to select the left character. When we press the right button, we are going to select the right character. But how do we know that? Because we attached one function on both buttons. If I were to do something like public void select character 1, and this is the function, and then I attach it to button 1, and then here select character 2 and attach it to function 2, so this one is attached on this one is attached on that one, you will know how we do it. There is no issue. But how can we do that with a single function? Well, that is the reason why I have named these buttons 0 and 1, because we are going to use an array same way as we used an array over here for our monster spawner, and we are using random range to randomize the index to get the monster from the array. That is how we are going to get the player from that array. So over here we have 0 and we have 1. But before we actually do that, how can we navigate from one level to another level? How is it done? In order for that to work, because we need to go from main menu, then we need to go into the gameplay, and inside of gameplay is where we will play the game with the selected player. But how is it done? Well, on top over here, we need to say using Unity Engine.Scene Management. So Unity Engine Scene Management. And now when I press the play button, or play game, excuse me, we're going to say scene manager dot load scene, and then inside we are going to pass the scene name, same as the name we gave it over here inside of our scenes folder. So if I go into the project, assets, and then scenes, we want to play the gameplay scene. So if I click here, enter just to, copy the name and paste the name over here, because the name over here needs to match with the name of the scene over here. If they don't match, this will not work. So if it's capital G, then over here it needs to be capital G. So now if I go and hit the play button, you will notice that when we press either of these buttons, we should go into the gameplay scene, and voila, there you go. So now we are in the gameplay scene. Now we have our player 1. So over here we have player 1, he is selected, but don't get fooled by that. If I go over here and if I press this one, you see again player 1 is selected. The reason for that is because if I go here into the gameplay, player 1 is by default in the game. If I remove him from the game, so let's go quickly to remove him, come on, there you go. If I go and remove him and go back over here and hit the play button, and I press over here, there you go. We do not have our player. You see, we do not have, and we have also null reference section for the camera. Do not worry about that, but we will cover it. One thing that I want to point out is if you cannot load these scenes, so when you press the button, you cannot load the gameplay scene. What you need to do is go under File and then Build Settings, and this scene needs to be added over here. That is the reason why I can load it, but by default, when you create a game, then this scene is automatically added to the build. If I remove it from the build, now that you see I have pressed the delete button and hit the play button, now if I try to go to gameplay scene, you see the scene gameplay could not be loaded because it has not been added to the build settings or the asset bundle. What the hell does this mean, teacher? As I said, by default, when we create a game, the first scene that is created will be added to the build on its own by default, which was the gameplay scene. But If we need to add them on our own, you need to go over here under File and then click on Build Settings. And while you are in the current scene that you want to add, so we want to add main menu and we also want to add gameplay, you're simply going to click here, Add Open Scenes. You see now it added main menu, and now I'm going to go here and open gameplay, and again open my build settings and click here, Add Open Scenes. So now I have added main menu and I have added gameplay into the build settings. So now, because they are in the build settings, I can load them. I can load them both. So I can go from main menu to gameplay, and I can also go back from gameplay to main menu. Again, ignore this for the camera follow. We will, cover it. Do not worry about that. But this is important to know that under File and Build Settings, any scene that you want in your game, and also when you're shipping your game, any scene you want to be in your game, you need to add it here in the build. So that is what you need to know. And you add them by being in that current scene and clicking here, Add Open Scenes, and that's all there is to it. If something is not clear, make sure that you ask in the comment below. Now that we know how can we navigate from one scene to another, we are going to select our character, go from main menu into the gameplay, and then, spawn the selected character. But first, how are we going to know which character we have spawned? Well, in order to paint the picture, what we're going to do with that, I'm going to go into the scripts folder and I'm going to right click and I'm going to create a C# script and I'm going to call this one Game Manager. Now, I'm going to right click inside the hierarchy and create an empty game object that is also going to be called Game Manager. And for this Game Manager, I'm going to attach the Game Manager script on him, because inside of this bad boy, we are going to have, and where is my Game Manager? For some reason, we do not see the Game Manager. Here he is. There you go. Because inside of this script, we are going to have an array of our two characters that we are going to spawn. So here at the top, we are going to have a serialized field, a private game object array, and this is going to be our players or characters, however you want to call them. So you can call them characters, for example, characters, there you go, and yada, yada, yada. So before we proceed, we are going to go back. And now here in the inspector panel for our game manager, we can attach the two characters. So we can take the two characters, select the game manager, lock the inspector on him, and take the player 1 and player 2 and simply drag and drop them right here. And for some reason, come on, there you go. Now it's working. So we have our game characters. How are we going to know which game character we have selected? This is where the 0 name and 1 name comes up. Now, going back inside of our script in the main menu controller, here I'm going to comment this line of code out and I am going to get the button that I have pressed. And in order to get the button that I have pressed, we are going to call Unity Engine .event systems .event system .current selected game object .name. Now I see, or I understand that this looks, large, but this is how we can get the name of the button that is pressed, or basically the UI element that is pressed. So we call Unity Engine, and this is because we don't want to import that over here. So we can import Unity Engine event systems, and then we will call event system current. So this can, be done like this as well. So we can say using Unity Engine. So come on over here, using Unity Engine event systems. We can do it like this. Then we can call event system current selected game object name. We can do it like that as well. There is no issue with it, but because we don't want to import a whole library just for this one thing that we're going to use, so we're going to call it here Unity Engine event systems .event system, and these are all classes. A class in a class in a class, in inheritance and all of the good stuff. You get the point. This is where all the inheritance comes from, and now you see why it was important for me to talk about it. So anyways, this is going to get us the name of that game object, and I can also do this. I can say string clicked obj is equal to, and there you go. You see, I have stored it in a string, and I can say debug.log, and I can say over here index colon, and then I can say plus clicked obj, and this is going to print us in the console, you know, what we clicked or the button that is clicked. And I can go back over here since the names are 0 and 1. So I'm going to click over here or hit the play button. Since the names are 0 and 1, notice what is going to happen. When I click this here, index 0. Click on this one, index 1. There you go. Whee! Yay! I know you're happy, but calm down. So what does this mean? Why are we doing this? Well, because inside of this array for the game manager, for the character, we have 1 character, 2 character. They are at index, you see, index, and what is this? For some reason, it added this as an element, so I'm going to remove it. There you go. And actually, it has 2 elements. So over here, we are going to have our player 1 assets. So player 1, and over here, we're going to have our player 2. For some reason, it attached 3 game objects. Not important. Anyways, so the first element is at index 0. The second element is at index 1. That's why we can use this, you know, 0, which is the 0 index, and we can get that element or that player, and 1, which is 1 in the array, or actually the second place in the array, because we talked about arrays. They are 0 based. So first element is at index 0, second is at index 1, so on and so forth. Last element is at the length of the array -1, so L -1. And that is how we are going to get that element. But we also have one issue. If we try to get that element by using a string over here, it is not going to work. And we need to convert a string into an integer. Because again, we cannot say inside of an integer array, so int array, for example, int array a is equal to, you know, new int array like this. So new int array with, let's say, 10 elements. We cannot say a, and then we used clicked obj, pass it as an index, and that is equal to 10. You see, this doesn't work. You cannot implicitly convert type string into an integer. So what is the solution? The solution is we're going to take this, and I'm going to say int selected character is going to be equal to, and on the second line, I'm going to say int.parse like this. So int parse, and inside I'm going to paste all of this, and now I can do this and it works. Now, before you panic, teacher did this too quickly. I don't understand. What the hell is wrong? I'm confused. Just a second. Just a second. Int.parse, you see, converts the string representation of a number to an integer. So this will convert a string, which represents numbers, into an integer. Now, when you are doing int.parse, so when you are converting a string into an integer, you need to make sure that that string has only numbers in it. It cannot have letters. If it has letters, this will not work. So what you need to do is, again, call int.parse, and now it is going to parse and create that into an integer. And notice now when I use selected character here as an index, it works. So now we need to inform our game manager that we need to inform the game manager which index is selected. But before we do that, we need to know what are static classes. So we'll first take a look at that, then we will take a look at another concept called singletons, and then we can continue with loading the characters when the scene is loaded. We saw that in order to access variables from a class, and over here I have a public warrior class as an example. So to access the name and the power, we need to go over here and we need to say something like warrior, W is equal to new warrior. And then from there, if it has, parameters in the constructor, then we can pass it. If not, we can create it like this. Then we can say from here, we can say something like v.name is equal to warrior. We can say v.power is equal to 10. And there you go. And we talked about this, and these are regular classes. And we know also that this means that we are creating a new object with the name W, which is a type of warrior. So this right here is creating a new object, type of warrior, by using the new warrior, and then we can use that object or the name of the variable that we passed it, which in this case is W. So we can use that name in order to access its variables, the public ones, of course, and public functions. And we know also that this has a reference in the memory of the computer. So this is a computer right here. This is the memory in the computer, and this is pointing to this reference in that memory. What we don't know is that there is another way how we can access variables that are in a class without the need of us to actually create a object or an object from that class. And that way is using static variables. So over here we can simply say public static string instead of, simply string. And again, we can say public static int, and there you go. That's all there is to it. This is everything we need to do. So now over here, instead of using W warrior, W is equal to new warrior, and all of the good stuff that we did so far, we can simply say warrior.name. And we can say that is equal to warrior, like this. And we can say warrior.power, that is equal to 100. And it works. So it works. If we print this now in the console, it will totally work, and it works, simply as that. So this is called a static variable. A static variable is a class variable. So you simply denote it, and also functions can be static as well. Don't worry about that. For this example, we are not going to dive, into it, but know that, also functions, and I blocked there for a second, functions can also be static. So you denote or you declare a static variable by simply typing public, and then you have over here static after it, which means now over here, as we saw this example, that we can access those variables by simply calling the class name, in this case warrior, because you see public class warrior, simply call the class name warrior, and there you go. And this is how we can access their variables. Why is this important? This is important because now for our game manager, we're going to do that same thing, but we're going to create an instance from that game manager. So over here, I'm going to close the warrior class, and inside of our game manager, we are going to create a variable that's called public static, and this is going to be game manager instance. And instance, there you go. I cannot spell sometimes. Now, what the hell is this, teacher? What is this instance? Well, as opposed to creating our private string, or actually private integer, which is going to be private, as you can see over here, int underscore char index, like this. And here I'm going to create a public int char index, like this. And what we are going to do here is that we are going to create a get that is going to return underscore char index. So char index, there you go. And we're also going to create a set that is going to say char index is equal to the value. Why is this important now? What is this instance? Well, notice over here, the instance is the game manager. Why? Well, because now we can create that instance from itself, meaning this class itself will have access to an object from this class, which is called an instance. And from that instance, we can access all of these public variables and public functions that are inside. And in order to create an instance, we do this in awake. We say if instance is equal to null, meaning instance is not initialized, then we're going to say instance is equal to this. Remember when we talked about data encapsulation, we said that this keyword is referring to the class where it is used. So referring to the class itself. So instance, setting this object instance is equal to this, meaning it is equal to an instance of this class. So over here now inside of our main menu controller, we can say, after we get a reference to the selected character, as you can see over here, so we got a reference to the selected character, we can say game manager dot instance dot char index is equal to selected character. There you go. You see, this is what we are doing, and this is what I meant when I said that I'm throwing bars at the Mars and moving forward. So this is what I meant when I said that we can use the class variable or class name to call a static variable from it. In this case, the static variable is the instance of that class, meaning an object from this class is actually a variable of the class, which means when we use that way, when we use that approach, we can access all of its public variables and public functions, and we can access them like this. So over here, as you can see, we set an instance to be equal to this. If it's equal to null, now it is equal to this. And after that, we can call it over here and set the character index, and it will be stored. So the selection that we make, depending on which character we have pressed, that will be stored over here so that when we go in the next level, we can use that data char index to know which character we should spawn. And this is basically what we need to do. But we will have one issue, and that is I am going to go back in my Unity editor, and inside of so after we load our level, this is where we are going to spawn our character. But we have one issue, and that is I'm going to hit the play button. We will see that issue. Inside of our, game main menu, we have the game manager and everything works perfectly and yada, yada, yada. If I click here to load the level, I'm loading the level. But one issue that we have over here is inside of our gameplay, you see, we do not have the game manager. Notice. We don't have the game manager in here. As you can see, main menu, game BG, spawner, collector, enemies. We do not have the game manager who is responsible now to spawn, who is responsible to actually spawn the character. What is the issue? The issue is the following. Imagine we have one scene, which is our main menu scene. So we have one scene, and imagine this scene, so this square now that I've drawn, that is the scene. And here these lines are game objects that we have in that scene. And maybe you don't see it here clearly, so I'm going to draw it over here. So this is one scene that we have, main menu, and it has these objects. Let's say it has 4 objects inside. When we press a button, in this case this one, when we press a button to go from this scene to this scene over here, all objects and everything that was in the previous scene will get destroyed. When Unity moves from one scene to another scene, it will destroy all game objects that were in the previous scene. So all game objects that are inside the main menu scene, they will get destroyed, and we move then into the gameplay scene, which has its own objects, as you can see. So it has its own objects, and it doesn't have the game manager object which holds the information that we need to spawn the character. And that is the issue that we are facing. And don't worry, there is a fix that is called a Singleton Pattern, but, well, we're going to see that in the next video, how we can, utilize the Singleton Pattern and use it to spawn our character. So, going back to our issue, how can we transfer Game Manager from this scene to our gameplay scene? How is that possible? Well, as I said, we need to use a Singleton Pattern. What is a Singleton Pattern? Well, over here, we're just creating an instance out of this class or out of the Game Manager. In order to create a Singleton Pattern from him, we need to do it like this. Over here, we have if instance is equal to null, then over here, else. What's gonna happen over here? A Singleton Pattern is, before we proceed, a Singleton Pattern will allow us to only have one copy of a game object, in this case of the Game Manager. So in order for us to have one copy, first we need to test if our instance, if the Game Manager instance is equal to null, then we are going to set the instance is equal to this, meaning we have created a copy of it, it's equal to this. Else over here, if it's not equal to null, we are going to call destroy on the duplicate. So else, if it's not equal to null, destroy the duplicate, meaning the already created instance that we had. But we also need to do one more thing. If we want to make this game object move from one scene to another scene, we need to call over here, don't destroy unload game object. If I hover over, it says, do not destroy the target game object when loading a new scene. A perfect explanation. I couldn't have said that better myself. So this will make sure that the game object that is holding this script will not get destroyed when we load a new scene. Let's test it out and see that. So over here now we see that we have a game manager in our scene. And just to, convince you that this works, I'm going to go in the gameplay. In gameplay, we have main camera or main camera, game BG, spawner, and collector holder. So you don't see a game manager inside of the hierarchy. Is that true? That is true. I know you answered that because I'm reading your minds. Anyways, let's go back here in the main menu. If I hit the play button now, everything is like normal. And over here we have something called don't destroy unload, which is like a grouping game object, a grouping parent, which has this game manager. If I press a button over here, notice now what happened. I have moved in the gameplay scene, and here is the gameplay scene. It has its own game objects that we have over here. So it has the main camera, game BG, spawner, collector, and one enemy is spawned, but we also have now the game manager. We also have game manager inside of our game. And we can, we can now use that to load our character. And I'm going to do that in the camera follow script over here. Just for a brief moment, I'm going to, comment out this line of code, and I'm going to say game manager.instance.char index. But before that, I'm going to say debug.log, just so that we can see over here the selected index, and over here plus, and I'm going to pass the game manager instance. Why I'm doing this in the main camera? Because the main camera is inside the gameplay. It's not over here in the main menu, so it's in the gameplay, which means now when we load, I'm going to hit the play button. When we load our game, I'm going to hit here, pay attention, the selected index is 0. You see what is happening there? So now we know which character we are selecting. So this is how we can transfer data from one scene to another scene. Of course, there are other ways, but we are not going to talk about them right now. This is one of the most common ways because, for example, in every single one of my games, I have instances or singletons like you see right here. So I have one for my ads, I have one for my save data, I have one for my gameplay manager, for a lot of things. So this is a pretty common pattern in Unity game development. So this is how we can transfer data from one scene to another scene. And just to make sure that, to actually convince you to believe, if I press this one over here, see the selected index now is 1. And you see where it is called. It is called in the camera follow script. There you go. Now going back to the singleton pattern. Before we wrap this up, I'm going to explain to you what the hell is a singleton pattern. So a singleton pattern, as I said, will allow you to only have one copy of the game object, and it will destroy a duplicate. You see, if instance is null, set the instance to this and don't destroy unload game object. Else, if the instance is not null, meaning we already have an instance, then destroy the duplicate. How does that work? How does that work? Well, let's show you, or let me show you now. We see now in the main menu we have a game manager, but we don't have a game manager inside of our gameplay. Now, in order for me to do that, I'm simply going to create a prefab out of the game manager just so that you can see how it works. So I'm going to go here into the scenes and in the gameplay, and now I'm going to drag the game manager inside of the gameplay. If I go over here into the scenes and from main menu, if I hit the play button, and if I select the character, press here, you see I went over here, we only have one, you see we only have one game manager. We don't have two game managers, only one. And in order for me to paint the picture more clearly, I am going to do this. I'm going to comment out the else part. I'm going to comment the else part, and we have if instance is null, instance is equal to this, and don't destroy unload game object, and we are not going to destroy the duplicate. So I'm not going to use else to destroy the duplicate. Let's go again back over here. We saw already that we have one game manager in the gameplay. If I hit the play button, first thing that you're going to notice is over here, we see we have the selected index is 1, and if I go back over here, pay attention what we have. Notice we have two game managers. So here is one game manager, and here is another game manager. What the hell is this, teacher? You are making me, is this magic? No, it's not magic. It's because we are not destroying, you see? It is because we are not destroying over here the duplicate. You see, destroy game object, if instance is already, if instance is not equal to null, destroy the duplicate. You see, if instance is equal to null, instance is equal to this, don't destroy unload. Else, if instance is not equal to null, destroy the duplicate game object. That's all there is to it. And since we are not destroying that, here it is, game manager, game manager. There you go. So that is the reason why we need to call this else destroy. So now it will destroy the duplicate game object, and it will make sure that only one copy of this game object is inside the game. Only one copy of this instance game manager is in the game, and that will make sure that... Why is this important? This is important because now it will make sure that when we call over here, inside of our main manual, we call the game manager instance and character index, we set it to a value, it will make sure that value is unique. We don't have two instances of this game manager so that it will, so now the computer will get confused. Maybe it will call one instance, or it will call another instance that has another value, and so on and so forth. We have a unique game object with unique values with its variable and functions and all of the good stuff. So this is what we are doing over here. Of course, if something is not not clear, make sure that you ask, but don't worry if you don't understand in depth everything what is going on. We are going to reuse this over and over and over. So this is just the first example that you see. If you don't understand it right away from the very first example in high depth and you don't understand every single thing, don't worry about it. Repeat the process, rewatch this video, ask me in the comments down below, and I will answer and help you out. Now, one thing that is left for us to do, and I'm going to remove this from here and uncomment this line of code. One thing that is left for us to do is to load the selected character when we press, when we go inside of our gameplay. Because now when we go inside, so let me just clear this. When we go inside of the game, if I click, for example, the second character, we are not spawning that character. He is not being spawned. How are we going to do that? Well, for that, we're going to use something called events and delegation. We are going to first learn, or we are going to check when a scene has been loaded. In order to do that, so in order to check when a scene is loaded, over here inside of the game manager, I'm going to remove start and update. And I'm going to create a function void on level finished. So on level finished loading, which takes a scene. So over here, we first need to say using, so sorry for that one, using Unity Engine scene management. So this one takes a scene as a parameter, and I'm going to call scene, comma, it also takes load scene mode. There you go. And inside of our void on enable, I'm going to subscribe to that event. So I'm going to say scene manager dot scene loaded plus equals on level finished loading. And I'm going to copy this and I am going to paste it. So over here, I'm going to say minus equals, and this is instead of on enable, this is going to be on disable. Now, before we proceed with this, we first need to explain what are delegates and what are events. I have a really cool video about that on my YouTube channel. I'm going to point you over there, even though you can watch it over there, but the next video is going to be about that. So I'm not going to create a new one because I explained events and delegates in depth in a 30-minute video. So I highly encourage you, even though it's a 30-minute video, please watch that video till the end in order to understand what is going on. And then we are going to go back to this and we are going to, load our character when the scene loads. So watch the next video and then I will see you in the video after that. Well, I mean, I will see you in the next video as well, but I will see you also in the video after that. Now, what I did is I've created a simple 2D project, and as you can see, I am in Unity 2018.1.1. You can download any Unity because we are going to go directly into scripting. And I have created two scripts. One is called receiver, another is called sender. Now, before we dive into these scripts and start coding and explaining things, I'm going to go in the hierarchy and I'm going to right click and create an empty game object, and this one is going to be the sender. I'm going to duplicate him, and this one is going to be the receiver. So attach the appropriate scripts. I'm going to attach the sender here and attach the receiver right here. So if I go in Visual Studio or Mono Develop, depending on which one you are using, here I already gave a little bit of space. You know what I'm doing. And let us start doing things. So what is delegation? Well, delegation is a form of, it allows us to subscribe to an event. Let's say we have, or you have a company, and that company creates newspapers, and it creates newspapers every week. So every week you have a newspaper that is a new newspaper, and you want to send that newspaper to all of your subscribers. Well, your company is the delegate, and your newspaper is the event, so the event that happens. And when that event happens, you want to inform all people who have subscribed to receive your newsletter or your newspaper so that they know there is a new edition and they need to come and get it, or you will send it to them. So let's say here I'm going to create a public delegate void, and I'm going to call this one, for example, player died. Now, this is a delegate that I named player died, and this is how we declare a delegate. So we type public delegate, so we need to denote it is a delegate. Void, because it is like a function. It can return a value or it can not return a value. We will see that, so don't worry about that. And this is the name of that delegate. Now, this name depends on us. You can give it a name Carl, you can give it a name, I don't know, whatever. But I called it player died because we know that we name our variables with meaningful names. This player died, what is it telling you? It is telling you that we're going to use this delegate to inform the subscribers to the event that the player has died. Now, the delegate is only the declaration. Think of the delegate as the company that makes newsletters or newspapers. But a public static event, player died, which I'm going to call, let's say, player died info, or this is the dude who is actually going to inform us that the player has died. Now, the event is the one to which we subscribe so that we know what is going on. Now, how does this work? I'm also going to remove the update function because we don't need it. Let me go into the receiver because the sender will send the information, and I'm going to go inside of our receiver and get that information. Now, one thing to know is in order to get this event or to receive an event, we need to create a function, and that function needs to have the same signature as we declared our delegate. What do I mean by that? Well, our delegate here is void, so the function needs to be void. So here we can say void player died listener, for example. This is how I name the function that will be subscribed to this event right here in order to receive the information. Now, how can we subscribe to this event? Well, for example, we can go inside of the start function and we can call our sender dot, and since our player died here, player died info is a static variable, we can call it here sender player died info plus equals to player died listener, like this. And this is how we subscribe to this event. Now, going back to our company and newsletter or newspaper scenario. So this is your company that creates those newspapers, and this is the newspaper. So we have subscribed to receive the newspaper with this right here. So plus equals, and we subscribe with the function. And notice here, as I already said, the function needs to have the same signature as the declared delegate. So if the delegate here is void, the function also needs to be void. If the delegate here has a parameter, the function also needs to have a parameter. We will see those examples, so don't worry about that. Now that we have subscribed to this function, what do we need to do? How can we call this event to execute and inform us? And here I'm going to use the print statement, and I'm going to call event has called this function to execute. So when we call this function, we will execute the code that is here. Currently, I have the print code, which will only inform me that we will print in the console, but we will know that this function has been called. The point here is that we need to see that this actually works, because in your real world project, you will have some other code. For example, the code when the player dies, you will do some things, so on and so forth. So how can we execute this code? Well, in order to execute the code, we need to go here in the start function, and we need to say if our player died info is not equal to null, and we will go back to this later, don't worry. Then we will simply call player died info. This is how we call this event to execute. You see here, this is that event. Simply call it player died info, same as if you are calling a function. So you call it with the name that you declared here, open close parentheses, and end with a semicolon. This right here, when it's called, it will call every function in every script that has used this signature, that has subscribed to this event. Now, if we try to run this, I'm going to go in the console. Let us see if this actually works. So if I hit the play button, we see in the console, event has called this function to execute. Now, this works, but this is not what I recommend you to do. And this is not how you will test things, or actually how you will do things in your real world project. I'm going to remove this. And for the receiver, inside our void on enable, this is where I am going to subscribe to events, because in Unity, this is the recommended place where you should subscribe to your events, simply in on enable. Now, there is another side of subscribing, that is unsubscribing. Why? Well, because we have subscribed to this event, and this function is tied to this event. So it will be called when the event executes. Now, we need to prevent memory leaking, and in order to do that, we need to unsubscribe from those events. So here we're going to call void on disable, which is also a function built into Unity. And in on disable, we are going to unsubscribe from this player died info. So here I'm simply going to say sender.player died info minus equals player died listener, like this. So plus equals subscribes you to the event, minus equals unsubscribes you from the event. So think of this, you have subscribed to receive newspaper every week, but now you don't want to do that anymore. You don't want to receive those newspapers, so you say minus equals to unsubscribe yourself from that service. Now, inside of our sender here, I'm going to create void execute event function. And here I'm simply going to say player died info and call it. But before that, I'm going to say if our player died info is not equal to null. And we will explain this in a second, but I also want to, well, test it out now. And here I'm going to say invoke, and I'm going to I'm going to invoke this method name here. So the method name is execute event, and I'm going to execute it after 5 seconds. Why am I doing this after 5 seconds? Well, first of all, we are going to wait 5 seconds before we call this function. Now, invoke will call the function with the name here in this given time manner, if you don't know what invoke is. So the name of the function is execute event, and this function, so execute event, will be called after 5 seconds when this line of code has been executed. Now let's go and execute this, and then I will explain what is going on. So if I hit the play button now, we will wait 5 seconds. So 1, 2, 3, 4, 5. And now we should see here, event has called this function to execute. Why did I do it like this? Because as I said, you will not use these events and call them right away in the start function. There is no scenario that I can think of in a real world project that you can do that. For what are these events good? Now I'm going to go through that and then we will break all of this line by line. Let's say, for example, you have a gameplay controller who controls the gameplay of your game, and you have a player and you have enemies that are attacking the player. You need to have a way to know if your player has died, and if he dies, you need to inform the gameplay controller so that he knows that, and then he will take the appropriate action, such as displaying game over panel, stopping the game time, stop counting the score, so on and so forth. Well, let's say this is your gameplay controller, or actually this is your player class, because this is where we need to declare that the player has died. So this is the player class, and we declare these delegates here, player died and player died info. And here, for example, we can test if player died, for example, is not, or if this is a Boolean variable, let's say, so if have here private bool is alive, for example. So here we are going to say if is alive for the player is equal to false. So player has died, and player died info is not equal to null, meaning somebody has subscribed to that event. Then we are going to inform that class or whoever has subscribed to the event that it needs to execute. Now we saw here in onEnable, and by the way, the execution order of functions in Unity goes like this. So first, awake is called. So awake is the first function that is called when your Unity project runs. After awake, onEnable is the second function that is called after onEnable start is called, but usually we use awake and start to initialize variables, but you need to know this. So the execution order is the following. First, awake is called, then onEnable, and then void start. Now, onEnable and onDisable have another feature, and that is they are called every single time when a game object is disabled or enabled. And here I'm going to test that out for you and display. So here I'm going to say print, and I'm going to say game object enabled. And here I am going to say game object disabled. So we can go in Unity now, and I can clear the console, and I can click here the plus button, or actually the play button, and take the receiver. And you see game object enabled has been called. If I turn it off, game object disabled has been called. If I turn it on again, game object enabled has been called. So every single time we on-enable or disable or enable our game object by using that checkbox right next to the cube icon to disable and enable the game object, on-enable and on-disable will be called, which is the exact same place where we need to place these. Why? Because every time we enable the game object, we will subscribe to the event that we need to subscribe to. And in order to prevent memory leaks, we unsubscribe in on-disable. So that is for subscribing and unsubscribing. Now going back here for our function, let's test it out like this. So if I simply call player died info like this without testing if it's not equal to null, and I'm going to comment this line of code here so that we don't subscribe to the event, notice what is going to happen. I'm going to click clear to clear the console. I'm going to hit the run button, and we are going to wait 5 seconds. So 1, 2, 3, 4, 5, and bam. You see here, null reference exception. If I click here, it is pointing to this line of code. The reason for this is because no one has subscribed to this event. No one has subscribed to the event. Now, we subscribe by using plus equals. I have commented this line of code out, so that is the reason why we did not subscribe. And I'm going to put this line of code back here. Now, is it clear why are we testing if the player died info is not equal to null? Because we need to make sure that at least one function, at least somebody has subscribed to this event. So if in one class, if we have 1,000 classes in our game and only in one place we type this, to subscribe to this event, this right here will not be equal to null and it will execute the code. As well as if we type this on 1000 places, again, it will not be equal to null. It will call all of those 1000 functions that are subscribed to this event when we execute the event. Now, one thing that I see that confuses people is that they don't know how this functions or this delegation and events, how does this work? Well, think of it like this. You have the delegate that you have subscribed to, and the delegate you declare as how you wish with meaningful names. As I said, this one will inform us when the player has died. Now the event here, just ignore the delegate. Let's say delegate, we need it. This is a company that prints newspapers. So we need the company to print the newspapers, but the event is the one who informs us when the newspaper is ready, when it is printed and we can start using it. So we have the delegate declared. An event needs to have the same signature. So player died is the name of the event, same as the delegate, and you give it a name here, how you want it. And we put it to be static so that we can subscribe to it from any class by simply using the class name and the name of the static variable plus equals and subscribe to it. Same way we unsubscribe with minus equals. But think of the event like this. The event is simply, let's say this event is your phone and you have a phone number from your friend. So your friend gave you his phone number, which means he has subscribed to your phone event. And when you need your friend, you call him. So here you're testing if you have your friend's number, call your friend. And that is that. This is how you can think of the delegate to make it more clear. Delegate and event, that is. In this case, we're talking about event, but when I say delegate and events, I refer to the whole concept. And again, here I'm going to lower this to 3 so that we don't need to wait 5 seconds to execute. And why did I use invoke to wait 5 seconds before in order to execute? Well, I wanted to show you that this, whenever it is called, it can be called after 1 hour playing your game, or 3 hours, or 5 hours, or 10 hours, does not matter. But you use this event to inform your classes about something that has happened. And we are using here a case player died. So if we have a player and we play, we shoot, we fight our zombies, but eventually a zombie kills us, then we can say if the player is not dead or not alive anymore, so if is alive is equal to false, and we have somebody subscribe to the event to know that the player has died, then bam, simply we are going to call that event, which will call every function that has subscribed to it. Now you see here we have player died listener. We can also create void test like this, and we can say print, and we can say called from test, and we can go here and we can say sender dot player died info plus equals to test like this, and here we need to unsubscribe, just so that I want to show you that we can subscribe multiple functions to a single event. And if I go back here and if I hit the play button, so clear the console, hit the play button, we will wait 3 seconds. So 1, 2, 3, and you see event has been called, or event has called this function to execute and called from test. So we subscribe 2 functions and we are calling them both. But you will not do this from a single class. You will do this from separate classes, but I am showing you that you can use multiple events or functions, to subscribe to an event. Let's say you have another class where you also need to inform that the player has died. You can do that by simply creating function inside of that class, calling sender player died info plus equals to player died listener. So my whole point is that you create here a delegate, an event for that delegate, and you create a function that will subscribe to that event and execute the code that's inside when this event is called. Now, you can do this as well, for example, if let's say you are going through your game and you touch some trigger that will trigger a boss fight, you can do that as well. So you can use delegates and events on that trigger class, and you can detect when the player passes that class using onTrigger enter, bam, that happens. You can say player, if that, let's say the name of that event is also player died info, if it's not equal to null, inform the classes that have subscribed to this event, and then the boss will appear because we have informed that the boss now needs to appear. Now I'm going to remove this invoke and I'm going to go here and I'm going to create public delegate void. Let's say here, I'm going to name it player died, but I'm going to comment this out and I'm going to comment this out as well. And let's say here, I'm going to say it's not, it can be void, but player died. And here I'm going to say it takes a bool parameter that is, well, let's say the name of that bool parameter is alive. So this bool parameter will also need to be right here. So now you see we cannot subscribe. Let me just go back here and I'm going to declare here a public static event and player died, and I'm going to call it player died like this. Now the thing here is that now we have a parameter inside of our delegate. So the event is declared the same way as you see here, but if we go here, we cannot now subscribe to that event. Does not contain definition player info. Okay, it's not important at the moment. I'm going to remove this from here. But what is important, that we need to have the same signature for the function. And here I can say player died info. And as I said, we need to have the same signature for the function as we had for the delegate, because the delegate here has a parameter bool. Now we need to have a function that has a parameter or takes a parameter. If we do it like this, so I'm going to do it like this. Notice we cannot do it because you see no overload player died matches delegate. It does not match the delegate. Why? Because it does not have this signature. It does not have a bool is alive. So I can go here and I can say bool and I can name it is alive, or I can name it alive. The parameter name can be whatever you want. And here I'm going to say print and player status, comma or dash is alive, colon, and I'm going to say plus alive, which is this parameter right here. Now we can go and we can subscribe to this delegate or to the event from this delegate. And going back here where we are calling, now we need to call it with a parameter. So now we don't call it simply by typing player died info. We need to say here either true or false, because that's a Boolean parameter. If here we have an integer, we need to type some name. If we have a string, we need to pass here a string. And if I go here and if I uncomment invoke with execute event, and if I go back here, let me just clear the console. I'm going to hit the play button, and now we're going to wait 3 seconds and we're going to say player status dash is alive true, because we called it here with true. If I call it with false and go back here, and if I hit the play button, notice what we are going to get inside of the console. So now player status is alive is false, because we called it here when we called our player died info. Simple like that. So this is how we can use delegates with parameters. So this is how we use delegates with parameters. And you can, the concept of subscribing and creating this delegate is the same, except that this delegate now has a parameter. So for example, if you want to send out to your gameplay controller that player has only 30% life left, you can test if player health is less than or equal to 30. Then you can simply test if player died info is not equal to null. Then you can call the event and pass here number 30. This is a scenario where you have integer as a parameter. Then you can call number 30, and then you can inform the gameplay controller, and then he can, for example, display a pop-up like health critical or something like that. These are just some ideas on top of my head for what you can use these delegates with parameters. Now this all depends on you. I get a lot of questions. Okay, how can I use this and for what can I use this? This depends on you and how you create your game. So for example, as I said, if Let's say you have some enemies that can only appear when your player has 50% of his life left. You can use delegation in the player class to declare delegate an event, and then you can test if the player's health is less than or equal to 50%, you can call the event that you created for that delegate, and any class, any enemy class that has subscribed to that event, it will be called. So the function that has subscribed in every class, it will be called and it will summon that monster when 50% of health is for your player, or when your player drops to 50% of his health. And these are just, as I said, some scenarios on top of my head. Now we can also have these events. So I'm going to simply copy this and I'm going to comment this out and I'm going to paste it here. Instead of our bool alive parameter, I'm going to say here it will return a bool, or it can return an integer, for example. Let's use an integer because we already used a bool. And now, since we don't have a parameter, we cannot call it here with false. So we need to remove this. We are simply calling the event as the name of the event, but the function that is subscribed to that event now, it needs to return here an integer. So here we need to say int, and here I simply need to say or remove this parameter. And what can we do with this? Well, the signature is the same, except here I can say return, and I don't know, let's say return number 5. Now, for what can we use this? Well, maybe there is a scenario in your game where you need to calculate the distance from your player and your enemy. So here, for example, you can pass vector3 parameters you can have here. So you can do something like vector3 player and vector3, and here I can say target, for example. And here we need to pass a transform. So let's say, for example, new vector3, I don't know, let's say 1f, 1f, and 1f. And here new vector3, and let's say, for example, 2f, 2f, and 2f, like this. And we need to return this value as a distance from them. And here, instead of int, I'm going to use a float because the distance is in float. And here I can say return. And also here, we need to have those parameters. So we need to say here vector3 target, for example, and vector3 player, or vice versa. So here is player and here is target. Now here we can calculate the distance and we can return that distance. So we can say something like print, and we can say function is called dot distance is, and here we can say plus vector3 distance from player and target. But we also need to return this because this function returns a float, so we need to do that. So we can say here return vector3 distance from player and target, like this. And now we are good to go. If I go inside of Unity here, and if I hit the clear to clear the console and hit the play button, we will wait 3 seconds. So 1, 2, 3, and we will see here in the console distance is 1.73 blah blah blah. So this is also one of the ways how we can use these delegates. We see that we are returning here a value. Now you can use this value where you need it. If you don't need it, if you only need the distance, you can omit returning. So you can be, or you can use this as a void and also declare this as a void. I am just giving you here examples how these delegates can work. So they can have parameters, they can return values, same as a function. So same as a normal function. The only point is that when you subscribe to that event, you need to have the same signature as the declared delegate. So this delegate here returns a float and it takes 2 parameters, vector3 and a vector3. That means that a function that subscribes to the event from this delegate, which is this event here, needs to have the same signature. So this function needs to return a float and it needs to take a vector3 and a vector3 as a parameter. So that is my whole point. And when you need to call or inform that function to execute, the function that has subscribed, you simply test if it's not equal to null. So if the event is not equal to null, call the event with parameters if you have any, without parameters if you don't have any, and this is how it works. How will you use it depends on you and the logic of your game that you are creating. I gave you already a couple of examples in this video. For example, if you want to perform if the player has died, or if the player health is now equal to 30%, or whatever. If the player has picked up some special pickup item or special collectible item in your game, you can do that as well. So there are many scenarios for what you can use this. If you are enrolled in my Ultimate Game Development Academy, then you will see a lot of examples, like 100 examples using delegation, so on and so forth, for different scenarios, to inform when the boss should appear, to inform the enemies when they should chase the player and when they should stop chasing the player. A lot of examples are there. This is just a brief introduction to delegation, talking a little bit more in detail than in some other videos that I did. Now, I said it's a brief introduction, but actually I talked a little bit more in detail what they are, for what you can use them, where should you subscribe and unsubscribe from them, so on and so forth. So I hope this video will help you clear that misunderstanding or non-understanding from these delegation and events, and that they are nothing complicated. They are not complicated as some students think. They are pretty simple once you get to know how they work, of course. I also was confused in the beginning, don't get me wrong, but when I understood, or when that dot clicked how they work, I see that how this concept is very simple. So you declare a delegate, you declare an event for that delegate, and the event is the main guy to which functions are subscribing to be executed when the event is called. Fahir here from AwesomeTunes.com. I will see you guys in the next video. First of all, sorry for the previous video for the background to be white. I try to use now dark in every single video, but I didn't want to redo that video because it's so well done, and I know I'm praising myself, but I really got a lot of feedback from people who could not understand events and delegates in Unity and what they are and how to use them. That video made it clear to them what are delegates. So now going back to our issue over here, now you understand what here or what this is. We're using this delegate, this scene loaded, we are subscribing to it with our on-level finished loading function over here. And over here we're unsubscribing. And also, which I hope that you watch that video till the end and the full video, you know that now the order of functions in Unity when the game loads, the awake is the first function that's being called, after that the onEnable, after that the start function is being called. So in onEnable and onDisable, we subscribe and unsubscribe respectively on or for events. So now what we simply need to do is inside of our onLevel finished function that we have subscribed to the event. So we are now listening to the event when the event happens, and we're going to say here if the scene.name that is being loaded is equal to gameplay. And again, you can create a separate string variable for this to have it named gameplay and put it here because we talked about this. I don't want to repeat myself. If the scene that is loaded is equal to gameplay, then we can simply call instantiate, and over here we are going to call our characters array, and inside of the square brackets we are going to call the char index because we are setting that value for the character index to be equal to here. When we click on a button, be that the left one or the right one, we are parsing the name of that button, which is either 0 or 1, which are the indexes used now to spawn a character. And we can test this out very easily. So if I go back over here inside of my Unity editor, and if I hit the play button now, if I select the character, this one, if I click, there you go, he is now being spawned, and I can jump and I can move and all of the good stuff. Let us test with the other character as well. So if I hit the play button, go back over here inside of the my main menu, click here, there you go, the other character is being spawned. He can jump, he can move, he can do, he can kill, he can kick, and all of the good stuff. There you go. So of course now we need to be careful to not we need to jump over the enemies, otherwise this is not going to work. You see, come on, oh no, well, there you go. Anyways, you get the point. I cannot play my own game. So yeah, one other thing that I also want to show you is over here, if we go inside of our camera follow, in the start function, we are calling the game object find with tag to get a reference to the player, because we know we need a reference to the player in order to follow him. And what is cool is that over here inside of the game manager, in on enable, we are subscribing to the event. So as soon as the level is loaded, on enable will be called, this event will be called, and the player will already be instantiated. So there will not be a null reference exception, for the reason that there is no player or no game object with the tag player that we saw previous, if you noticed in the previous 2 or 3 videos where we used singletons to move left and right, or actually from scene to scene. So yeah, that is the issue that we also fixed there. Of course, if something is not clear what we did so far, just make sure you ask in the comment below. But if you watch the previous video till the end, which I urge you to do, if you didn't do, please watch it till the end, because it explains a lot of things that you will need now and later on, especially later on. So all of this right here will be clear what we are doing. So we're using this function which has subscribed to this event, and as soon as a new scene is loaded, it will inform this function, because we have subscribed to that event, it will inform that function similarly like in the example that I use in the video. So as soon as a new newspaper comes out, we will be informed in this function, because we have subscribed to the service to know when a new newspaper comes out. And this is essentially what we are doing. And then inside of this function, we can simply use this parameter scene to get the name of the scene that is being loaded. And if it's equal to gameplay, then instantiate the character for us to play the game. Okay, my little game dev gangsters, the last step is before us, and that is to have in our game a way to, restart the game and go back to the main menu to select the other character, because currently we can only play the game, you see, with one character. But what if this character gets killed? You see now I'm getting killed, I died, and all of the good stuff. So you see now that basically I cannot do nothing. I cannot restart the game is playing without me. So for that, we're going to right click over here, go under UI, and I am going to create a button. There you go. But before that, select the canvas, and it's going to be screen space camera, attach the main camera, scale with screen size, everything what we did so far, what we talked about and explained, and all of the good stuff, 0.5 over here, and yada yada yada. There you go. So we are also going to go over here for the canvas, because we need to use the sorting layer that we talked about for our sprites, also apply to the canvas, because currently it's set on the default for the canvas. You see the sorting layer on the canvas, it's on default. It's not rendered, we cannot see it because of our game elements. So I'm going to add an extra sorting layer that I'm going to call UI. And I'm going to select the canvas and set him on that UI. And pay attention now, voila, there you see the button right there at the bottom left corner. So I'm going to remove the text from the button, and I am going to take the button and position him at the top left corner. And I am going to go in my sprites folder, and for this button, this one is going to be the restart. So I'm going to drag and drop the restart, and I'm going to hit the native size, but this is too big. I'm also going to set here the anchor at the top left corner, so somewhere around here, but as I said, this is too big, so it's 400 by 400. I'm going to say 250 by 250. I believe this is okay. No, it's not. So let's go over here and let's say 100 by 100. This is too small, I believe. No, it's enough for our game. I mean, we can see it. It's not a mobile. Even on mobile, this would be visible, completely visible, and yeah, you know the drill. So over here, I'm going to use the restart button, maybe just reposition a little bit more, somewhere around here. There you go. And I'm going to copy this, but before that, I'm going to rename it to restart. I'm going to duplicate it, and this one is going to be home, or basically going back to the main menu, and I'm just going to lower him a little bit here, and there you go. But for this one, I'm going to drag and drop the home, and voila, we have our icons. Before we can do anything, we know that we need to go inside of our scripts folder and create a new C# script. I'm going to call this one Gameplay UI Controller. And I am going to select Home and Restart. But before I do that, pause the video and try to do this on your own. So try to attach the script on the buttons and try to create a function for both of these. And then I will tell you how we can, reload the scene, basically using the scene manager. So you can try that on your own. And I'm going to continue right now. So selecting both of these, I'm going to hit the plus button and attach. Basically, I didn't attach the gameplay UI controller. I am going to attach it on the canvas game object itself. And I am then going to drag the canvas over here. There you go. And let's go into the gameplay UI. So here he is. He is only going to have two functions. One is going to be public void restart game, and another one is going to be public void home button, or simply going back to main menu. In order to restart the game, we need to, over here I'm going to say using Unity engine.scene management. And here I'm going to say scene manager.load scene. This is to reload the scene. So in order to reload the scene, we're simply going to add here gameplay, because that's the name of the scene we want to load, which is our current scene where we are, which is the gameplay. This is one of the ways. Another way, I'm simply going to copy this and I'm going to comment it out and paste it below. Another way is that we can use it like this. We can call the scene manager, and we can say get active scene, and we can say .name. So it will get us the current scene we are in, and it will get the name of that scene. And this is the beauty about programming. This is what I love, because everything is named. What do I mean by that? You want to get an active scene? You simply call scene manager get active scene, and there you go. You get the scene that is currently active. And then you simply type name of that scene, and it will return. You see, returns the name of the scene that is currently active in the game or app. If we are in the gameplay, it will return gameplay. If we are in the main menu, it will return main menu, and so on and so forth. And last but not least, over here, I'm simply going to paste this, but instead of gameplay, I'm going to say main menu. Just make sure that the names over here, so this name matches up with the name of your scene that you have stored inside of Unity. So over here, you see it's main menu, and there you go. So for the restart, I'm simply going to select the function gameplay UI restart game. For the home, I am going to go over here and say home button, and that's all there is to it. So now we can go from our main menu, and I can, hit the play button. I can restart the game. You see, it is restarting and it is reloading the game with the same player. If I go back to home and click here to reload with, or to play the game with the other player, there you go. You see, now we can play the game even if we die. So even if I die and I'm waiting for, one of the monsters to kill me, but apparently no monsters are killing me because I am so awesome. Are there any monsters? Yes, here it is. Bam. The monster has killed me. I have died. But now I can press the restart button and play the game again. And so in infinity. So there you go. So now I can play this game in infinity. But we are not going to live until infinity, okay? And I can also go back and I can also hit the play button. Select another player. And voila. That's all there is to it. What else can I say? I have the ghost. I can go over him, and there you go. So yeah, this was Monster Chase game.